Hello everyone. This video is quite special because I'll be covering 42 years KCET differentiation topic from 1984 to 2025, all PYQs. 1984, so quite long back, correct? So it's quite interesting to see the questions from the differentiation chapter from various CET papers from 1984 till 2025. They're covering 42 years KCET questions. Okay, topic is differentiation. Not only just covering the previous year questions of this chapter, I'll be explaining the concepts as well, how to tackle it in a simple way, in an easier way, in a lesser time. We'll get the ideas. Okay, we'll be exposed to variety of questions. Number of questions are there. I have not counted the number of questions, total number of questions actually. Maybe 190 to 195 questions might be there. If I see the number of questions, I'll be covering all the different topics. Are not included continuity in this, only the differentiation chapter. Okay, continuity will be done separately. And those who are watching for the first time to our channel, my channel is Abhiram's Maths Marathon. Okay, I'll be uploading more and more videos. Okay, in the previous videos I've done JEE, PYQs, also synopsis, NCERT exercise of inverse trigonometry functions is covered. More of NCERT syllabus also I'll be doing. NCERT exercise problems will be solved along with the concepts. Okay, both first PU as well as second PU. KCET PYQs also I'll be covering, even JEE as well as JEE mains and advanced, and many other competitive exams. It may be NDA or it may be any other competitive exams. Okay, I'll be doing one by one. Have plan of uploading more number of videos in the upcoming days. Okay, please subscribe to my channel. Okay, the differentiation topic included in this video. Okay, various number of questions appeared so far in 1984, 85, 86, all has been indicated here. So till 2025, and not included continuity and not included the differentiability. I mean where you find the left hand derivative and right hand derivative and you see whether the function is differentiable or not. That topic is not included. Only differentiation means the methods of differentiation like chain rule, implicit function differentiation, inverse trigonometry function derivatives, parametric differentiation, logarithmic differentiation, second order derivatives, all those things. And one more thing, Rolle's theorem and mean value theorem were there in the earlier syllabus actually. Now it's deleted actually. It's deleted. Questions were asked from Rolle's theorem and mean value theorem in the year 2014. One question was asked. Even in 2019, one question appeared. Even in 2024, like it forms an AP here. 2014, 2019 and 2024. Questions were asked from Rolle's theorem and mean value theorem, which has been deleted. I have not included that. Okay. This is a various number of questions asked in different years. Okay. More or less, I can tell on an average, 5 questions can be asked from this topic. If you see last 15 years, say 2010 onwards, 2010 4 questions, 2011 6 questions, 2012 4 questions, 2015 6 questions, 2016 5 questions, like that. You can see on an average we can tell it's a high weightage chapter. I can tell you CET is for 60 questions, in each subject. Mathematics has 60 questions, correct? Out of 60 questions, 4 to 5 questions, 4 questions or 5 questions, nearly it comes to 7 to 8% of the weightage. Okay, 7% I can give rough weightage for this topic. So high weightage chapter for Karnataka CET exams. Okay, it's a very important topic as well, and many interesting questions are asked. And if you go to 1984, 85 till 1995, now when the CET was introduced in the year 1984, that time the questions were quite easy, but still we'll discuss all those questions, okay, one by one. So various topics are covered. These are the various topics covered, as I told you: derivatives of composite function, derivatives of inverse trigonometry functions, implicit function differentiation, logarithmic differentiation, parametric differentiation, and second order derivatives. Only these are topics are included in this video. Okay, so altogether we got more than 190 questions in this. I'll be discussing one by one along with the concepts. Okay, you'll get the idea, you learn the techniques also of solving these problems. Not just solving the PYQs. Along with PYQs, I'll help you to understand the topic and also make you learn the new techniques in this chapter. So list of differential formula given here. Derivative of x power n is n into x power n minus 1. Derivative of x with respect to x1. All the basic formulas. Derivative of root x 1 by 2 root x. Derivative of 1 by x minus 1 by x square. So first of all, if you are practicing this, if you want to practice this chapter, first learn all the formulas thoroughly. That's the most important thing. Derivatives of trigonometry functions are given: sine, cos, tan, cot, secant, cosec. Derivatives of exponential and logarithmic functions are also given, and also as well as derivatives of inverse trigonometry functions are shown here. Okay, so learn all these formulas. Not so difficult to learn the formulas because differentiation is such an important topic. Even after finishing second PU, if you join engineering also, we come across in engineering mathematics, you got differentiation. Not only in mathematics, in other subjects also it links. So mathematics is called as a queen of all sciences. You know that. So let's begin now. The number questions. The first I'm going to discuss about the algebra of derivatives of the functions. So f and g are the two functions which are differentiable. How to differentiate sum of the two functions, how to differentiate the difference of two functions, all those things is given here. Algebra of derivatives. If you want to differentiate sum of the two functions, differentiate the first function plus differentiate the second function. If it is if you're differentiating the difference of two functions, then differentiate the first function minus differentiate the second function. Derivative of k into f of x. K is a constant. Constant you keep as it is and differentiate the function f of x. And we got the product rule. Derivative of f into g. First function keep as it is, differentiate the second, plus second function keep as it is, differentiate the first. This is called as the product rule in differentiation. Derivative of uv also we can call. Derivative of uv is u into v dash plus v into u dash. Some teachers will use such kind of notations also. D by dx of uv you can call. So also called as uv rule. Whenever there is product of two functions, we can apply this. Derivative of uv is u into v dash plus v into u dash. This also can be taken as another formula or a method, okay, to differentiate the product of two functions. Or f into g also works anywhere. U and v are two variables or functions. If it is quotient of two functions, how to differentiate? Right, denominator square the denominator. In the numerator, we start from denominator into derivative of numerator minus numerator into derivative of denominator, and derivative of constant is 0. Constant into variable doesn't become 0. Constant into variable is there, means constant you keep as it is, differentiate the variable, and derivative of constant is 0. This is quotient rule. Can also be put in the form of u by v form. Derivative of u by v, d by dx of u by v. How to do it? How to write this? Denominator square. Square the denominator first. In the numerator, you start from denominator. Denominator into derivative of numerator. Dash indicates derivative. Minus numerator into derivative of denominator. Okay? It's called quotient rule. Quotient of two functions is given to you. How to differentiate quotient of two functions. That's called as quotient rule. So this is algebra of derivatives. Questions are asked based on this. Simple questions, one in 2014 and 2015. Many times NCERT level questions are also asked in the exams. So these are quite NCERT level questions. This is f of x is given like this. You want to find f dash of 0. Question asked in KCET 2014. So x power 100 by 100 is there. No, you can treat this as constant into variable. 1 by 100 into x power 100 I can write. Correct? So f of x, I'll write f dash of x directly for the first one. F dash of x. X power 100 by 100 is same as 1 by 100 into x power 100, right? So 1 by 100 is constant. 1 by 100 is constant. To differentiate x power 100, that is 100 into x power 99 plus x power 99 by 99 is 1 by 99 into x power 99, correct? Constant keep as it is. 1 by 99 is constant. Differentiate x power 99, what do you get? 99 into x power 98 plus goes on. Derivative of x square by 2, half into x square. X square by 2 same as half into x square. Half we keep as it is. Derivative of x square is 2x and derivative of x is 1. Derivative of 1 is 0. So here 100 is going to cancel. 99 cancels. 2 cancels. Now I want to find f dash of 0. No, put x equal to 0 here. Put x equal to 0. 0.99 is 0. 0.98 is 0. All the terms which contains x will become 0. Correct? 0 plus 0 plus 0 etc. 0. Last term is 1. So answer is 1. Answer is option C. Similar type of question asked in KCET 2015 here. G of x is given a polynomial of degree 200. Earlier f of x was a polynomial of degree 100. Degree means the highest power of x, right? For the second question, g dash of x is equal to 1 by 200, keep as it is, divided by 200, multiply by 1 by 200, derivative of x power 200, 200 x power 199, correct? All these things you can do orally, mind calculations, no need to write all these things, okay? Still I am doing all the steps to make you understand. Just go on, differentiate, correct? Derivative of x power 198 by 198 is 1 by 198, keep as it is, differentiate x power 198, that is 198 x power 197, like this it goes on, correct? Last few terms, derivative of x square by 2 half into derivative of x square 2x, derivative of x1, derivative of I is 0. Now these terms will cancel, 200 cancels, 199 cancels, put x equal to 0, g dash of 0 means you are finding the derivative of the function at x equal to 0. After differentiating you put x equal to 0. Now at this stage I'll put x equal to 0, g dash of 0. When you put x equal to 0, wherever x terms are there, all those terms will become 0, 0 upon 199, 0, 0 upon 198, 0, all these terms will become 0, this will become 0, 0 plus 1, answer is 1. So g dash of 0 is 1, answer is option A. Simple questions are asked on differentiating a polynomial function, okay, can be asked, I have taken this in the section of algebra of derivatives, 2014 and 2015 questions, okay. Move on to the next one, the derivatives of the composite function, chain rule. A function is given of this type, y is equal to f of g of x. Then how to differentiate this? Dy by dx equal to f dash of g of x into derivative of g of x, that is g dash of x. Okay. If you have g and h are three differentiable functions with y is equal to f of g of h of x, how to differentiate this? Dy by dx equal to f dash of g of h of x. Start from the outermost function. Start from the outermost function. F dash of whatever is given, same thing here, right? Further differentiate the inner one. Derivative of g is g dash. G dash of h of x into derivative of h of x is h dash of x. That is how we differentiate a composite function. Okay? F of g of h of x. Start from the outermost function. F dash of what is given, same thing you write, into derivative of g is g dash of whatever given, same thing you write, into derivative of h is h dash. Hope you understand that how to differentiate a composite function. Now we shall take up the questions on this. The first one, question asked in KCET 2021. Okay, y is given as cos of x square the whole square. Want to find dy by dx. Differentiate this as you differentiate x square. Derivative of x square is 2x, correct? So dy by dx equal to dy by dx. Differentiate as you differentiate x square, correct? It takes the form x square, not exactly x square. So I am using chain rule here. So 2 times cos of x square, correct? Whole to the power 1, correct? Derivative of x square is 2x, 2 into x power 1. But this is not x. So further differentiate. Derivative of cos is minus sign. So minus sine of x square into derivative of x square is 2x. Okay. First we shall write this minus sign. Then I shall write this 2x. Okay. Minus I wrote. 2x I wrote. What is left now? 2 cos of x square into sine of x square. That takes the form 2 sine theta cos theta. We know 2 sine theta cos theta is sine 2 theta, right? We know this formula. 2 sine theta cos theta. 2 sine theta cos theta is sine 2 theta. So I'll be using that formula. 2 sine of x square cos of x square becomes what? In place of theta we got x square. That becomes sine of 2x square. Sine of 2x square. So answer is minus 2x into sine of 2x square. Option C. Hope you understand. 2x I wrote first along with minus sign. This takes the form 2 cos theta sine theta, which is sine 2 theta. Minus 2x into sine of 2x square. Option C. Next one. F of 1 is given, f dash of 1 is given. You want to find the derivative of f of x plus f of x the whole square at x equal to 1. Question asked on in the year 2022, KCET 2022. Also it appeared in the JEE mains earlier prior to 2022. In some shape this question was asked. So the same question is asked in KCET also. I'll take this function as y, okay. I'll take y is equal to f of x plus f of x the whole square. Want to find the derivative of this function at x equal to 1. So first differentiate it, then put x equal to 1. Okay, dy by dx. It's a composite function, right? So we should differentiate. Dy by dx is how to differentiate f of x. Start from the outermost function. F dash of x. F dash of whatever is there, same thing you write. Further differentiate the inner one, derivative of f of x will be f dash of f of x into derivative of f of x, that is f dash of x. Derivative of f of x the whole square, differentiate as a differentiate x square. Derivative of x square is 2x, correct? 2f of x into derivative of f of x, that is f dash of x. Now put x equal to 1. Differentiation is over. Now I'll put x equal to 1. dy by dx at x equal to 1. What do you get? F dash of f of 1, correct? Into f dash of f of 1 into f dash of 1 2 into f of 1 into f dash of 1 is equal to f dash of what is f of 1 given? F of 1 is given to be equal to 1, correct? F of 1 is 1. F dash of f of 1 is 1 into f dash of 1 plus 2 times f of 1 is 1. F dash of 1 is given to be equal to 3. Now this becomes f dash of, again f of 1 is 1. Substitute. F dash of 1 is 3. F dash of 1 is 3. 2 into 3 is 6 here. F dash of 1 is again 3 here. 3 into 3, 9. 9 into 3 is 27. 27 plus 6, 33. So answer is 33. Option C is the answer. Simple question on differentiating a composite function f of x plus f of x the whole square. Differentiate with respect to x. Want to find the derivative and then put x equal to 1. They ask to find the derivative of this function at x equal to 1. After differentiating, put x equal to 1 and use the given conditions. F of 1 equal to 1, f dash of 1 equal to 3, get the answer. Simple one. Okay. Move on to the next one. Question number 3. Given y equal to f of x square plus 2, f dash of 3 equal to 5. Want to find dy by dx at x equal to 1. Question asked in the year KCET 2015. So y is f of x square plus 2. No, differentiate this. Dy by dx. Dy by dx equal to what? How to differentiate f of x square plus 2? F dash of x square plus 2 into derivative of x square plus 2, that is 2x. Start from the outermost function. Derivative of f is f dash. So f dash of x square plus 2 into derivative of x square plus 2, that is 2x. Now put x equal to 1. Want to find dy by dx at x equal to 1, right? So after differentiating, you need to put x equal to 1. Dy by dx at x equal to 1. First I'll write this number 2 into, put x equal to 1 into f dash of, if you put x equal to 1 here, 1 square plus 2, correct? 2 into 1 is 2, f dash of 1 square is 1, 1 plus 2 becomes 3 and f dash of 3 is given to be equal to 5. So 2 into 5 is equal to 10. Answer is 10. Option D is the answer. Fourth one. Y is equal to sine of greatest integer value of pi square x plus cos of greatest integer value of minus pi square x. Want to find f dash of x. They've given the greatest integer function there, KCET 2012. So you must know the value of pi approximately 3.14, rough value of pi. So pi square approximately equal to 9.85. Pi square is approximately 9.85. So if you find the greatest integer value of pi square, it becomes equal to 9. So which are the integers less than or equal to 9.85? Integers less than or equal to 9.85 are 9, 8, 7, 6. There are plenty of integers less than or equal to 9.85. Among them the greatest is 9. So 9. And greatest integer value of minus pi square. minus pi square is how much? Minus pi square means minus 9.85. Greatest integer value of minus pi square. Integers less than or equal to minus 9.85 are minus 10, minus 11, minus 12, etc. Among them, greatest is minus 10. Correct? Greatest integer function. If you want, I can sketch this. 0 is present here, 9 is here, 10 is here, 9.85 is somewhere here. This is minus 9, minus 10, correct? Integers less than or equal to minus 9.85. Integers less than or equal to minus 9.85, minus 10, minus 11, minus 12. There are many integers, correct, which are less than or equal to minus 9.85. This is minus 10, minus 11, minus 12. Among them, the greatest is minus 10. So, the greatest integer value of minus pi square is minus 10. Here, the important thing is that minus is outside the pi, not inside pi. I mean, it is not minus pi the whole square. Some students misunderstand. It's not minus pi square. Minus pi the whole square is not given. Square is only for pi. It's given like this, minus pi square. Square is only for pi, not for minus. Okay. So, don't get confused. Don't think it is minus pi the whole square. Minus pi the whole square is same as pi square. That's different. Now, it's given as minus pi square. Square is only for pi. Okay. It's not like this. It's not like this. It's like this. Okay. So, minus 9.85. Greatest integer value of minus 9.85 is minus 10. So, integers less than or equal to minus 9.85. You must see. Immediate integer less than or equal to minus 9.85 is minus 10. Correct? The greatest integer function we are speaking of. So, f of x will simplify to what? F of x will simplify to sine of greatest integer value of pi square is 9. Greatest integer value of minus pi square is minus 10. So, this becomes cos of minus 10x. And we know cos of minus theta is cos theta. Cos is an even function. Correct? So, this simplifies to sine 9x. We know that cos of minus 10x is same as cos 10x. Correct? Now you can differentiate f dash of x. Derivative of sine is cos. Cos 9x into derivative of 9x, that is 9. Derivative of cos is minus sine 10x into derivative of 10x, that is 10. So I can write this as minus 10 sine 10x. So answer is 9 cos 9x minus 10 sine 10x. Option B is the answer. First simplify the greatest integer value of pi square and greatest integer value of minus pi square. So greatest integer value of pi square is 9. Pi square is 9.85. Integral value of 9.85 is 9. So write the immediate integer less than or equal to given number. Correct? 9.85 is here. You ask the question to your mind, which are the integers less than or equal to 9.85? 9, 8, 7, 6, 5, many are there. There are infinitely many integers less than or equal to 9.85. 9.85 is a rough value for pi square, okay? Approximate value I can tell. So 9.85, which are integers less than or equal to that number, among them take the greatest number, okay? List out the integers less than or equal to 9.85. Among them the greatest is 9. So greatest integer less than or equal to the given number, okay? Similarly for minus 9.85, you ask the question to your mind, which are the integers less than or equal to minus 9.85? Integers less than or equal to minus 9.85 are minus 10, minus 11, minus 12, many are there. Among them, greatest is minus 10. So, integral value of minus pi square is minus 10. Hope you understand. The concept of greatest integer function already you learned in first PU, correct? So, based on that, the question is asked to differentiate it, okay? First, simplify the given function and then differentiate using chain rule. Derivative of 9x is 9. Derivative of 10x is 10. Derivative of cos is minus sine. Derivative of sine is cos. Fundamental formulas. Move on to the next one. Question number 5. F of x power 5 is given as 5x cube. Want to find f dash of x. KCET 2008. So there are two ways of doing this problem. I'll do both the methods if you want. F dash of, so if you differentiate this, equation, what do you get? F dash of x power 5, f dash of x power 5 into derivative of x power 5, that is 5x power 4 is equal to 5 into derivative of x cube is 3x square, correct? Derivative of f of x power 5 is f dash of x power 5 into derivative of x power 5 is 5x power 4. Constant into variable. Constant keep as it is. Differentiate x cube 3x square. Okay. So we can cancel the same numbers. 5 cancels. So what I am going to get is f dash of x power 5 is equal to 3 x square by x power 4. That is 3 by x square. F dash of x power 5 I am getting. Want to find f dash of x. So what you do is you replace x power 5 by x. Or else you can make a substitution for this. X power 5 as t and use new variable. Okay. That is also possible. Otherwise, you can replace x power 5 by x. If x power 5 becomes x, no? X power 5, if x power 5 is replaced by x, this x will become x power 1 by 5, correct? So I'll get f dash of x is equal to 3 divided by x power 1 by 5 square. Or I can write this as 3 divided by 2 we can bring inside, 1 by 5 I can take it outside. X square to the power 1 by 5, which is equal to 3 divided by whole to the power 1 by 5 means it is fifth root. So fifth root of x square it is 3 by fifth root of x square. Answer is option A. If you can't understand this method, I can go by method of substitution. Okay. The second method is you put t is equal to x power 5. Just put t is equal to x power 5. Make a substitution for x power 5 as t. Okay. In that case, what will be x? X will be t power 1 by 5. Correct? Taking fifth root on both sides. So, in that case, what this becomes? F of x power 5 is taken as t is equal to 5 into what is x? T power 1 by 5. T power 1 by 5. The whole cube. So, that is equal to 5 into t power 3 by 5. Correct? F of t is 5 into t power 3 by 5. Now I can bring a new x. Change of variable. Just I'll replace t by x. Not this x, different x. Okay? That new variable is x only. So that I get f of x. Now I can differentiate this. F dash of x. F dash of x. Constant into variable. Constant keep as it is. Differentiate x power 3 by 5. 3 by 5 into x power 3 by 5 minus 1 minus 2 by 5. 5 cancels. 3 into x power minus 2 by 5 is 1 by x power 2 by 5. Which is nothing but 3 divided by fifth root of x square. Because x power 2 by 5 is x square power 1 by 5. X power 2 by 5 is x square power 1 by 5. Okay, fifth root of x square. Same answer you get. Any method you can do. If you're not comfortable with the first method, you can go for the second method. Okay. On to the next one. Question number 6 here on derivatives of composite function. F of x given like this. Sin square x by 1 plus cot x plus cos square x by 1 plus tan x. Want to find f dash of pi by 4. Question from KCET 2011. So this involves a trigonometric function here, correct? So what we'll do is you write cot as cos by sin and tan as sin by cos. For simplify it, you may have a doubt whether I can start with quotient rule. It becomes lengthy. You may get the answer, correct? You can apply quotient rule for this as well as for this. For both the terms, you can apply quotient rule individually. But here, what I'll do is I'll simplify these trigonometric functions. Cot, you write cos by sin. Tan, you write sin by cos. Okay. Then go on simplify. Then finally differentiate. Then put x equal to pi by 4. That's the idea of this problem. How to start the problem, that also always a question arises. Okay. By practicing more and more number of problems, if you are exposed to variety of questions, then only you'll get the idea. First, you learn all the formulas and results, and synopsis part should be very strong. If you have a powerful synopsis, if you are then if you're exposed to variety of questions, you're solving many questions, then you'll get the idea definitely. Okay, so we'll start this by writing cot as cos by sin, sin square x divided by 1 plus cot x. I'll write cos x divided by sin x. Cos square x divided by 1 plus tan, will write sin by cos. Then take LCM here. The denominator you take LCM. What is LCM here? Sin x. Sin square x divided by sin x plus cos x, sin x plus cos x divided by sin x plus cos square x divided by cos x plus sin x divided by cos x. Taking LCM in the denominator, denominator will go up. Sin x goes up, becomes sin square into sin, becomes sin cube. Denominator goes up, cos square into cos becomes cos cube x. So what I am getting here, sin square into sin becomes sin cube x divided by sin x plus cos x. This cos x will go up, cos square x into cos x becomes cos cube x. Sin plus cos is same as cos plus sin. So I can write this as sin plus cos only. I'll take common denominator. Sin x plus cos x is common denominator. That is, if denominator is same, I can add the numerators. Correct? Numerator takes the form a cube plus b cube, which you know a plus b into a square minus ab plus b square. Sin x plus cos x. Factorizing the formula a cube plus b cube, a plus b into a square minus ab plus b square, sin square x minus sin x into cos x plus cos square x divided by sin x plus cos x. Sin x plus cos x will cancel. Sin square plus cos square is 1. So what I am getting? F of x is equal to 1 minus sin x into cos x. Sin square plus cos square is 1. 1 minus sin x into cos x is sin 2x by 2, correct? Half using the double angle formula, sin 2x by 2. From this f dash of x is derivative of 1 is 0, sin 2x by 2, that is divide by 2 means half we keep outside. Derivative of sin 2x is cos 2x into derivative of 2x is 2. 2 cancels. Want to find f dash of pi by 4. At this stage I'll put x equal to pi by 4 minus cos of 2 into pi by 4, pi by 2, cos pi by 2, 0, minus 0, same as 0. Answer is option C. This gone simplified first, writing cot as cos by sin, tan as sin by cos, gone simplified, take LCM, use a cube plus b cube formula, a plus b into a square minus ab plus b square. Identical terms will cancel from numerator and denominator. Sin square x plus cos square x is 1. Sin x into cos x is sin 2x by 2, because we know sin 2x formula 2 sin x cos x. From there we get, then differentiate. Divide by 2 means into half. Half is constant, keep as it is. Derivative of sin 2x, cos 2x into 2. Then finally put x equal to pi by 4. Cos pi by 2 is 0, minus 0 same as 0. Answer is option C. Okay. Move on to the next one. Differential coefficient of f of sin x with respect to x, where f of x equal to log x. Question asked in the year 2004. Okay. So take this f of sin x as y. Let y equal to f of sin x. Let y equal to f of sin x. You want to find the differential coefficient of, means you have to find the derivative of this function. Meaning is same. Want to find the derivative of this function where f of x is log x. Where f of x is equal to log x. So f of x is log x means, what is f of sin x? If f of x is log x, what is f of sin x? So replace x by sin x. From this I can write f of sin x is log of sin x. Correct? This becomes log of sin x. Because f of x is given to be equal to log x. Correct? F of sin x will be log of sin x. Replace x by sin x. What I am getting? Log of sin x. F of x is log x. So f of sin x, replacing x by sin x. Replace x by sin x. Replace x by sin x. I get log of sin x. Now you can find the derivative of this. Dy by dx. Dy by dx. Differentiate this. Derivative of log x is 1 by x. Derivative of log of sin x. 1 by sin x into derivative of sin x is cos x. Cos x by sin x is cot x. No conditions are given that sin x should be positive. Earlier questions, before the introduction of NCERT, we are not just focusing on the domain of the function and all. Log x means log of sin x means sin x should be positive only. Such things we're not focusing, just gone blindly, just mechanically we're working out the problems. It's understood that the given function is defined only for such values of x. We can give the inputs. Values of x are such that the function is well defined. It is assumed to be the function is defined. Okay, we don't give much conditions earlier. Nowadays we are focusing more on the domain of the function. Whenever we define log x means x is positive, such things are given nowadays. Okay, earlier they're not much focused. Okay, so no conditions are given. We accept this question. Okay, dy by dx is equal to cot x is the answer. Want to find the derivative of f of sin x with respect to x, given that f of x is log x. From f of x equal to log x, we find f of sin x. Log of sin x. Derivative of log is 1 by sin x into derivative of sin x cos x. Cos by sin is cot x. On to the next one. Simple questions you can see in the year 1984 where the CET exam was started for the first time. Okay, don't laugh at these questions. The competition was also less. Nowadays there is more competition. The questions are also upgraded. Even the students are advanced. Okay, so very simple questions are asked in the previous. If you go to 40 years back, such kind of questions are there. Okay, simple question. Dy by dx want to find. Derivative of root x is 1 by 2 root x. 1 by 2 root of sin x into derivative of sin x cos x. Orally we can tell the answer, correct? So answer is option A. Derivative of root x. Derivative of root x is 1 by 2 root x. So 1 by 2 root sin x into derivative of sin x is cos x. So answer is option A. Option A is the answer. If you want to write the steps. Dy by dx equal to derivative of root of sin x. 1 by 2 root of sin x into derivative of sin x, that is cos x. By chain rule it follows. Answer is option A. Move on to the next one. Y equal to log of root sin x. Question asked in the 1984 again. Dy by dx equal to, derivative of log x is 1 by x. 1 by root of sin x into derivative of root. Derivative of root is 1 by 2 root. 1 by 2 root of sin x into derivative of sin x is cos x. And this becomes cos x divided by 2 into root of sin x into root of sin x becomes sin x, correct? So cos by sin is cot, divide by 2 means second right 1 by 2, 1 by 2 into cos by sin is cot, so cot x, half cot x. Or else you can use the property of log also here. Root sin x you can write sin x power half, log sin x power half is half log sin x. Using the property, the power can be brought down, the power rule is there, then you can differentiate. So any method you can do, correct? I differentiate directly using derivative of log x, 1 by x, 1 by root sin x, into derivative of root is 1 by 2 root sin x, and derivative of sin x is cos x. And root sin x into root sin x becomes sin x. Cos by sin is cot, half cot x is the answer. On to the next one. Here log of root cos x. Question asked in the 1985. So here differentiate dy by dx. Dy by dx equal to derivative of log x is 1 by x. 1 by root of cos x into derivative of cos x. Derivative of root is 1 by 2 root. 1 by 2 root of cos x into derivative of cos x is minus sin x. Correct? Derivative of log x is 1 by x. 1 by root of cos x into derivative of root is 1 by 2 root. Further differentiate cos. Derivative of cos is minus sin. Root cos x and root cos x becomes cos x. 1 by 2 I shall write first. 1 by 2 minus sin x divided by cos x. I think there is a mistake in the question. I think it should be log of cos root x, I think. Not log of root cos x. Should be, I think, there's a mistake in the question. Earlier it was log of root sin x. I think options are not matching here. I think it should be log of cos root x. Okay. Just to make a correction in this question, it should be y equal to log of, the question should have been y is equal to log of cos root x. Derivative of log is 1 by, so dy by dx will be equal to 1 by cos root x. Okay. Make a correction in the question. Log of cos root x it is. Okay. Derivative of log is 1 by x into derivative of cos is minus sin root x into derivative of root x is 1 by 2 root x. Sine by cos is tan. So I'm getting minus tan root x divided by 2 root x. Minus tan root x divided by 2 root x. Option B is the answer. Make a correction in the question. It should be log of cos root x. Okay. Move on to the next one. Question number 11. Y is equal to 5 power x. Direct question. Derivative of a power x formula. Derivative of a power x is a power x into log a. No? So 5 power x into log 5. Option C is the answer. Quite simple, straightforward question. Y equal to root of cot x. Dy by dx equal to. Derivative of root is 1 by 2 root. Correct? 1 by 2 root of cot x into derivative of cot x is minus cosecant square x. Correct? So answer is none of this. Minus cosecant square x divided by 2 root of cot x, which is not there in any of the options. So answer is none of this. Move on to the next one. Y is equal to cos of log of sin x dy by dx. Dy by dx is equal to derivative of cos. Start from the outermost function. Derivative of cos is minus sine. Minus sine of log of sin x. Minus sine of log of sin x into derivative of log of sin x. That is 1 by sin x into derivative of sin x is cos x. Correct? Start from the outermost function. Minus sine of whatever is given, same thing you write. Further differentiate log of sin x. 1 by sin x into derivative of sin cos. Cos by sin is cot. So I am getting this as minus cot x into sine of log sin x. Correct? This you write first. Cos by sin is cot. Minus cot x into sine of log of sin x. Option B is the answer. Move on to the next one. Y equal to 2 power minus x dy by dx. You know derivative of a power x formula. Correct? A power x means it is constant power variable. Whenever there is constant power variable, we apply the formula derivative of a power x. Derivative of a power x is a power x log a. But instead of x, you are given minus x. Derivative of 2 power minus x is 2 power minus x into log 2 into derivative of minus x is minus 1. Correct? Further, we need to differentiate minus x. Derivative of minus x is minus 1. So, this is equal to 2 power minus x log 2 into minus 1 is minus log 2, and minus log 2 could be written as log 1 by 2, because you know minus log a is log 1 by a. Minus log a is equal to log 1 by a. Correct? So, minus log 2 becomes log of 1 by 2. Minus log 2 is log 1 by 2. Minus log a is log 1 by a. Option A is the answer. Make a note of this. Even in chemistry also you come across this property of log. Minus log a is log 1 by a. Simple question. Answer is option A. Next one. Y equal to cos square root x. Want to find dy by dx. Differentiate. As a differentiate x square. Dy by dx equal to cos square. It is of the type x square. Derivative of x square we know 2x. 2 cos root x. 2 cos of root x into derivative of cos. It is minus sine. Minus sine of root x into derivative of root x. That is 1 by 2 root x. Correct? This 2 can be cancelled here. 2 cancels. Otherwise you can keep as it is, because they are using the double angle formula. 2 sine theta cos theta is sine 2 theta. No? You know this formula. 2 sine theta cos theta is equal to sine 2 theta. 2 sine theta cos theta is sine 2 theta. So I want to use that formula. Minus you keep as it is. Okay. So 2 cos of root x into sine of root x. In place of theta you put root x. That will be sine of 2 root x divided by 2 root x. So answer is option A. Don't cancel this 2 and this 2. Don't cancel it. Keep as it is. Okay. So that we can use the double angle formula. 2 sine theta cos theta is sine 2 theta. So 2 sine root x cos root x sine of 2 root x. Minus you keep as it is. Divided by 2 root x. Option A is the answer. Move on to the next one. Question number 16. Y equal to tan inverse of e power 2x. Want to find dy by dx. No, derivative of tan inverse x. 1 by 1 plus x square. Differentiate as differentiate tan inverse x. Dy by dx equal to. Dy by dx equal to. Derivative of tan inverse is 1 by. So 1 by 1 plus e power 2x the whole square into derivative of e power 2x is e power 2x into 2. Correct? Further differentiate e power 2x. Derivative of e power x is e power x. Derivative of e power 2x, e power 2x into 2. So we get the answer as 2e power 2x divided by 1 plus e power 4x. 2x into 2 becomes 4x. The powers gets multiplied. I can divide both numerator and denominator by e power 2x. Answer looks to be option C, correct? So we can divide numerator and denominator by e power 2x. When you divide by e power 2x for numerator, I'll get only 2 there, correct? I'm dividing the denominator by e power 2x. 1 by e power 2x will be e power minus 2x. E power 4x by e power 2x will be e power 2x. So answer is option C. Divide numerator and denominator by e power 2x to get the answer as option C. 2 by e power 2x plus e power minus 2x. Move on to the next one. Log of tan root x. Want to find dy by dx. Question asked in the year 1988. dy by dx equal to derivative of log x is 1 by x. So 1 by tan root x into derivative of tan root x, that is secant square root x into derivative of root x 1 by 2 root x. So answer is secant square root x divided by 2 root x into tan root x. Answer is option D. Derivative of log x 1 by x. Further differentiate tan. Derivative of tan is secant square. And derivative of root x 1 by 2 root x. Secant square root x by 2 root x into tan root x. Option D is the answer. Move on to the next one. Simple questions are asked. Y equal to cot inverse of x square. Want to find dy by dx. Derivative of cot inverse x we know. Derivative of cot inverse x is minus 1 by 1 plus x square. Likewise we differentiate. dy by dx equal to minus 1 by 1 plus x square the whole square into derivative of x square 2x. Derivative cot inverse x minus 1 by 1 plus x square minus 1 by 1 plus x square into derivative of x square is 2x. So I'll get the answer as minus 2x divided by 1 plus x square that is x power 4. So minus 2x by 1 plus x power 4. Option C is the answer. Hope you understand. Using chain rule. Just differentiate. Okay. Move on to the next one. Y equal to e power sine of log x. Want to find dy by dx. You know, derivative of e power x is e power x only, right? So dy by dx equal to derivative of e power sine of log x is e power sine of log x into derivative of sine of log x. Derivative of sine is cos of log x into derivative of log x, that is 1 by x. And we know e power sine of log x is nothing but y, correct? So this becomes y, this part is y into cos of log x into 1 by x, into 1 by x is divided by x. Option B is the answer. 20th one, y equal to log of secant x plus tan x. If you know the integral formula, directly we can answer this. Integral of secant x is log of mod secant x plus tan x plus c. Integration is the reverse process of differentiation, right? So if you differentiate log of secant x plus tan x, obviously you get secant x. By integration formula, if you know integration is the reverse process of differentiation, integral of secant x is log of secant x plus tan x. Log of mod, of course. Log of mod secant x plus tan x plus c. Correct? So if you differentiate this, you should get this. So derivative of log of secant x plus tan x is secant x. That is one way, directly we can tell. Like that, there are many formulas in integrals, so we can take them as the reverse process of differentiation. Many such formulas are there. Correct? Integral of, we got root of a square minus x square, x by 2 into root of a square minus x square plus a square by 2 sin inverse of x by a plus c. If I ask you to differentiate that, answer is root of a square minus x square, correct? So such kind of questions can also be asked. Okay. So once, and also we must know that integral of secant x, there is another formula, log of mod tan pi by 4 plus x by 2. Once in the common key exam, the question was asked to differentiate log of tan pi by 4 plus x by 2. Answer is secant x directly by reverse process of integration. Okay, by using the reverse process integration as a reverse process of differentiation, directly we can tell. Otherwise, it takes more time. Such things you must be knowing. I'll be doing the detailed synopsis of this chapter also later. This is only PYQs, okay? From 1984 till 2025, all the previous year questions of this chapter I'm discussing along with a bit of synopsis, okay? But later, I'll be doing the synopsis of this chapter entirely. Detailed synopsis will be there. So, if you want the method, already I told the answer is secant x. If you want the method, I'll do it. dy by dx equal to dy by dx, derivative of log x is 1 by x, 1 by secant x plus tan x, 1 by secant x plus tan x into derivative of terms inside the bracket, derivative of secant x is secant x tan x plus derivative of tan x is secant square x. You can take secant x common there in the numerator, secant x common. So what remains is tan x plus secant x divided by secant x plus tan x. Secant x plus tan x will cancel. What we get is secant x. dy by dx is secant x. Next one, log of cos root x. Derivative of log is 1 by, so dy by dx. Derivative of log x is 1 by x. 1 by cos root x into derivative of cos is minus sin root x into derivative of root x is 1 by 2 root x. So I am getting minus tan root x divided by 2 root x. Option B is answer. Simple question. Derivative of log x is 1 by x. 1 by cos root x into derivative of cos is minus sin into derivative of root x 1 by 2 root x. Sin by cos is tan minus tan root x divided by 2 root x. Option B is answer. Move on to the next one. Y is equal to 2 power log x. It takes the form a power x. Constant power variable means a power x formula. Derivative of a power x is a power x into log a. So dy by dx here. 2 power log x derivative is. Derivative of 2 power log x is what? 2 power log x into log 2 into derivative of log x, which is 1 by x. So answer is 2 power log x into log 2 divided by x. Option C is answer. Move on to the next one. Derivative of e power ax into cos bx with respect to x given like this. R into e power ax cos of bx plus tan inverse b by a, where a and b both are positive. Find the value of r. Question asked in the year 2010. One of the most difficult paper in the entire history of CET exam, KCET from 1984 till 2025. The toughest paper is in mathematics was in the year 2010. Okay, so this is a question we can, this is a paper we can tell is a difficult in the history of the CET. Take this function as y, derivative of, want to find e power ax into cos bx. E power ax into cos bx. Of course, it is the product of two functions. We need to apply product rule for two functions, u into v dash plus v into u dash, correct? Applying product rule, dy by dx. dy by dx is equal to, first function keep as it is, differentiate the second function, derivative of cos bx is minus sin bx into derivative of bx is b plus cos bx into derivative of e power ax is e power ax into derivative of ax is a. So I can take e power ax common, right? So e power ax is common. So what remains inside the bracket is a into cos bx, a into cos bx minus b into sin bx. What remains, right? After taking e power ax common. Applying product rule, first function keep as it is, differentiate the second function, derivative of cos bx minus sin bx into derivative of bx is b plus second function keep as it is, derivative of e power ax is e power ax into derivative of ax is a. E power ax is common, so what remains is a into cos bx minus b into sin bx. What we'll do is, I want to express this in terms of cos of bx plus tan inverse of b by a. That means, and you can see the options here, correct? See, ab is there, a plus b, root of a square plus b square, 1 by root ab. You must be knowing the maximum and minimum value of a cos x plus b sin x. If it is a cos x plus b sin x, maximum value is root of a square plus b square, and the minimum value is minus root of a square plus b square. So knowing that, and moreover, the numbers a, b and root of a square plus b square form the Pythagorean triplets, correct? So if you take a by root of, a is the adjacent side, okay, this is the opposite side, this is some angle alpha, the hypotenuse will be root of a square plus b square, correct? Hypotenuse will be root of a square plus b square. So what we'll do is, I can express in terms of cos and sin inside the bracket. I'll multiply and divide by root of a square plus b square. So if a by root of a square plus b square is cos function, b by root of a square plus b square is sine function. So here cos alpha is equal to, we know, adjacent side by hypotenuse. Cos is adjacent side by hypotenuse. A by root of a square plus b square. Sine is opposite by hypotenuse. B by root of a square plus b square. Correct? So this becomes, or multiply and divide by root of a square plus b square. Root of a square plus b square into e power ax. Here a by root of a square plus b square into cos bx minus b by root of a square plus b square into sin bx. What we did, I multiply and divide by root of a square plus b square, so that I can define a by root of a square plus b square. Adjacent side by hypotenuse is cos function. This is cos alpha. This is cos alpha. This is sin alpha. It takes the form cos A cos B minus sin A sin B, which is cos of A plus B, correct? I am getting that form, cos of A plus B. So this becomes, dy by dx becomes, dy by dx is equal to, what I am getting is root of a square plus b square, root of a square plus b square into e power ax into cos alpha cos bx minus sin alpha sin bx is cos of alpha plus bx. Cos of alpha plus bx, or bx plus alpha, both one and the same, correct? What is alpha? Is substitute back, because sin alpha is b by root of a square plus b square and cos alpha is a by root of a square plus b square. From this I can conclude that tan is b by e. Tan is sin by cos, right? b by I am getting. So alpha is tan inverse. So dy by dx will be root of a square plus b square into e power ax into cos of bx plus my alpha. From here I'll get tan inverse of b by e. Why I multiply and divide by root of a square plus b square only? Because a by root of a square plus b square, if you take it as cos alpha, this will be sin alpha. And this number lies between minus 1 and plus 1 for any real numbers a and b. That is more important. Okay. We can't multiply and divide by a plus b or ab or 1 by root ab. It's not guaranteed that those numbers will lie between minus 1 and plus 1 to define it as cos function or sin function. We know the range of sin function and cos function is the closed interval minus 1 to plus 1. For any real numbers a and b, of course a and b are positive, they told. For a and b positive real numbers, a by root of a square plus b square definitely lies between minus 1 and plus 1 if you want to check. Even b by root of a square plus b square will lie between minus 1 plus 1. Here because they told a and b positive, it lies between 0 and 1, I can tell. Correct? Because a and b are positive, this number as well as this number, both these numbers will lie between 0 and 1. Correct? So that's why we multiply and divide by root of a square plus b square, so that we can define this as cos function and this as sin function. Okay? That's the logic. And if we compare now, r will be equal, this is your r value. Correct? R is this. R into e power x cos of bx plus tan inverse b by is given. So wanted to find the value of r, which is root of a square plus b square. Option C is the answer. Move on to the next one. 24th. Given y equal to cos x by 1 plus sin x. The a, b, c, d are given, then which is correct? Only a is correct or only b is correct? Both a and c are correct, both b and d are correct. So to find dy by dx in two different ways, looking at a, b, c, d here. One is I can simplify and then differentiate. Another method is by using quotient rule. There are two ways of finding dy by dx for this. Looking at a, b, c, d. A and B are of one kind, C and D are of another kind, correct? So we can simplify and differentiate, or else we can differentiate directly by using quotient rule. Both the methods we have to do and check which is correct. So first method, by using quotient rule to differentiate this, dy by dx, denominator square, question asked in this year 2025, denominator square 1 plus sin x the whole square, denominator square, denominator keep as it is. Differentiate numerator, derivative cos x minus sin x, minus numerator into differentiate denominator, derivative of 1 plus sin x is cos x, correct? This becomes 1 into minus sin x is minus sin x, minus sin x into sin x, minus sin square x, minus cos square x, divided by 1 plus sin x the whole square. We can take minus sign common here, correct? Minus sign you can take common. If you take minus sign common, sin x plus sin square x plus cos square x. You know, sin square x plus cos square x is 1. This becomes minus of sin square plus cos square is 1, correct? 1 plus sin x minus of 1 plus sin x divided by 1 plus sin x the whole square. So one of this 1 plus sin x can cancel it. So what I'm getting is minus 1 by 1 plus sin x. Minus 1 by 1 plus sin x. So A is correct. If A is correct, the answer can be either option A or it can be option B, correct? So if A is correct, B is not correct because I'm not getting 1 by 1 plus sin x, I'm getting minus 1 by 1 plus sin x. So option C and D are ruled out. Okay. So either it is option A or it is option B. So I have to check whether I'll get dy by dx as minus half secant square pi by 4 minus x by 2 by doing it in another way. Another way of doing this problem is I have to simplify it. Cos x, to write this cos x, the half angle formula. The simplified form, if you remember, it's better. The simplified form of cos x by 1 plus sin x is tan of pi by 4 minus x by 2. I advise all the students to remember this as a standard formula in trigonometry. Cos x by 1 plus sin x. Even in second PU inverse trigonometry function chapter, there is a question connected to this. Writing in the simplest form, tan inverse of cos x by 1 minus sin x is there. Cos x by 1 minus sin x is tan of pi by 4 plus x by 2. Cos x by 1 plus sin x will be tan of pi by 4 minus x by 2. If you want, I'll do it in detail. Cos x, you can write cos square x by 2 minus sin square x by 2. Half angle formula. Write 1 as cos square x by 2 plus sin square x by 2. Sin x is 2 sin x by 2 cos x by 2. Half angle formula once again. Okay. So we have to use those half angle formulas and simplify. Then finally you differentiate. Y is equal to, I'll write here, cos x is cos square x by 2 minus sin square x by 2. Cos square x by 2 minus sin square x by 2. Denominator, write 1 as cos square x by 2 plus sin square x by 2. Sin x you can write 2 sin x by 2 cos x by 2. 2 sin x by 2 cos x by 2. This is what? Which form? A square minus b square. Numerator a square minus b square. You can write a plus b into a minus b. Denominator is a square plus b square plus 2a, which is a plus b the whole square. Correct? You can simplify it. Cos x by 2 minus sin x by 2 multiplied by cos x by 2 plus sin x by 2. Denominator is cos x by 2 plus sin x by 2 the whole square. Here cos x by 2 plus sin x by 2 will cancel. What you get is cos x by 2 minus sin x by 2 divided by cos x by 2 plus sin x by 2. Whenever you get expression of this type, what we do? You divide numerator and denominator by cos. Cos by cos 1. Sin by cos tan. Cos by cos 1, sin by cos tan. 1 minus tan x by 2 by 1 plus tan x by 2 is tan of pi by 4 minus x by 2. All these simplifications we can't do in the exam. I am writing all these steps to make you understand. Okay, I advise the students to remember this as a standard formula. Cos x by 1 plus sin x is, you can remember it as tan of pi by 4 minus x by 2. You have to remember it. If you want to crack the question, entire paper, if you want to finish in less time, within 1 hour, if you want to finish, definitely have to remember. The preparation level should be very strong. Then only it's possible. Okay, we can't do all these things in a CET exam like board exams. It's definitely impossible to complete the paper if you're doing like this. I give a guarantee. So I'm showing all the steps to make you understand. Okay, those are listening for the first time, or if you're not aware of these formulas, for them it's required all these things. So I'm doing all the steps. But if you are asking me to write this, definitely I advise all the students to remember cos x by 1 plus sin x is tan of pi by 4 minus x by 2, differentiate it, get the answer, over. This implies dy by dx equal to derivative of tan is secant square pi by 4 minus x by 2 into derivative of pi by 4 minus x by 2, which is minus half. So answer is minus half secant square pi by 4 minus x by 2. C is also correct. So both A and C are correct. Option B is the answer. Question asked this year, 2025. Move on to the next one. Y equal to a sin x plus b cos x. Want to find y square plus dy by dx the whole square. 2023 question. So differentiate this. Dy by dx. Dy by dx equal to derivative of a sin x is a cos x. Derivative of b cos x is minus b sin x. Therefore, y square plus dy by dx the whole square. Y square, y is how much? Y is a sin x plus b cos x the whole square. A sin x plus b cos x the whole square. Dy by dx is a cos x minus b sin x the whole square. Simplify it. Expand it. Expand this and simplify. What do you get? Expanding this, a plus b the whole square formula. A square sin square x plus b square cos square x plus 2ab part, 2ab sin x cos x. 2ab sin x into cos x. Here also expand. What do you get? A square cos square x plus b square sin square x minus 2ab into cos x into sin x. 2ab sin x into cos x will cancel. A square is common. Sin square plus cos square is 1. B square is common. Correct? A square into sin square x plus cos square x, which is 1. Plus b square into cos square plus sin square is 1. So a square plus b square, which is a constant. Correct? A and b are constant. Therefore, the given expression becomes equal to a constant. Answer is option A. Next we go on to differentiability of the modulus function. Actually there is modulus function here, d by dx of mod x, okay, not x. D by dx of mod x. How to differentiate a modulus function? Actually mod x, no, v-shaped graph, we know left hand derivative is not equal to right hand derivative at x equal to 0, correct? Left hand derivative is minus 1 and right hand derivative is plus 1. So mod x function, no, is not differentiable at x equal to 0. For x not equal to 0, derivative of mod x is x by mod x. If you want to give a proof for this, take y equal to mod x. Mod x. For x not equal to 0, I am discussing. For x not equal to 0. Mod x means root of x square. Correct? So differentiate this. dy by dx. Derivative of root is 1 by 2 root. 1 by 2 root of x square into derivative of x square is 2x. 2 cancels. What we get? X by root of x square. So what we get is x by root of x square is mod x. So x by mod x. For x not equal to 0, derivative of mod x is x by mod x. You must know that. Okay, fundamental thing. And here f of x given like this. Want to find f dash of pi by 6. Okay, we need to simplify this. And pi by 6, you must know the nature of sine and cos. Sine pi by 6 half, cos pi by 6 root 3 by 2. Correct? Cos pi by 6 is bigger than sine pi by 6. Cos pi by 6 is root 3 by 2. Root 3 by 2 is roughly 0.866. 1 by 2 is 0.5. So 0.866 is bigger than half. So in the neighborhood of x equal to pi by 6, at x equal to pi by 6, I'll write. First we'll simplify this modulus function at x equal to pi by 6 or in the neighborhood of pi by 6. I can tell cos x minus sin x is positive, correct? Cos pi by 6 is bigger than sin pi by 6, so the difference is positive. You know, modulus function definition, mod x is equal to x if x is greater than or equal to 0. If x is greater than or equal to 0. Minus x if x is less than 0. Correct definition of modulus function we know. So because cos x minus sin x is positive, mod of cos x minus sin x will be cos x minus sin x. If cos x minus sin x was negative, then mod of cos x minus sin x will become minus of cos x minus sin x. Now terms inside the modulus is positive, so I am using the first line. If x is greater than or equal to 0, mod x will be x. If x is less than 0, mod x will be minus x. I am using the definition of the modulus function. So first simplify f of x. F of x becomes equal to what? Mod of cos x minus sin x will be equal to cos x minus sin x, because it is positive. Now differentiate f dash of x. Derivative of cos x is minus sin x. Derivative of sin x is cos x. Now put x equal to pi by 6. We get f dash of pi by 6. What we get? Minus sin pi by 6. Sin pi by 6 is half. Minus cos pi by 6, root 3 by 2. We can take minus half common here. Minus half is out. So what remains is 1 plus root 3. Minus half into 1 plus root 3. Option A is the answer. Similar type of questions are found in the NCERT exemplar book. Also, I'll be covering the problems from NCERT exemplar book also. Okay, chapter by chapter we can complete all the different videos I'll be uploading in the coming days. Move on to the next one. Answer is option A. Minus half is common. 1 plus root 3. So at x equal to pi by 6, you must check whether terms inside the mod is positive or negative. If it is positive, write itself. If it is negative, write negative of that. Because cos x minus sin x is positive, mod of cos x minus sin x is cos x minus sin x. Differentiate, then put x equal to pi by 6, get the answer. And the differentiability of the greatest integer function. Whenever greatest integer function is there, no, we discuss two cases. Modulus function means we discuss x greater than or equal to 0, x less than 0. For greatest integer function, we discuss integral values and non-integral values. For integral values, we know that greatest integer function is discontinuous. Every discontinuous function is a non-differentiable function. So if x is an integer, then greatest integer function is discontinuous, therefore it is not differentiable. If it is a non-integer, then it is continuous and it is also differentiable, and the derivative is found to be equal to 0. For non-integral values, so greatest integer function derivative is 0. You must know that. So I discussed two cases when x is an integer and x is a non-integer. When x is integer, it is not differentiable. Greatest integer function is non-differentiable because it is not continuous. Every discontinuous functions are non-differentiable functions, because you know every differentiable function is continuous. Every discontinuous functions are non-differentiable function, because statement and contrapositive are always logically equivalent. I'll explain all those things in the continuity and differentiability topic. Okay, more explanation will be given there. The non-integral values, and it is differentiable, and the derivative is found to be 0, the greatest integer function. Whenever they give you the greatest integer function, you have to simplify it at the given point. I'll take a problem based on this question asked in the year 2019, f of x given like this. So we want to find the derivative at x equal to pi by 2. Pi by 2 is definitely a non-integral value, correct? Pi is approximately 3.14. Pi by 2, 3.14 by 2. Approximately 1.57. It's a non-integral value. Non-integral value. First we simplify this. At x equal to pi by 2. At x equal to pi by 2. Greatest integer function becomes exactly equal to 1. Correct? Pi by 2 is roughly 1.57. Greatest integer value of 1.57 is 1. First simplify the greatest integer function. So at x equal to pi by 2, my function f of x becomes equal to what? X minus 1 minus cos x. Now differentiate. F dash of x. Derivative of x, 1. Derivative of 1, 0. Derivative causes minus sign. Minus of minus plus sign. Now put x equal to pi by 2. F dash of pi by 2. What we get? 1 plus sine pi by 2. Sine pi by 2 is 1. Correct? So 1 plus 1. Answer is 2. Option A is answer. Move on to the next one. I'll take up more questions, okay, on a greatest integer function. How to simplify a greatest integer function at a given point and then differentiating it, okay. So I'll take up more questions connected to those. Now this is a question where radian is given. Suppose they give you to differentiate sine of x degree, then how to find dy by dx. Derivative of sine x is cos x, we know. But x should be measured in radian then only. If it is in degrees, we can't differentiate directly. Don't think that derivative of sine of x degree is cos of x degree. That's what given here. Derivative of sine of x degree is not equal to cos of x degree, because x should be measured in radian. Because this is derived from where? Derivative of sine x equal to cos x is derived from where, you know, from the limit theorem. Limit x tends to 0, sine x by x equal to 1, where x is measured in radian there. So if it is given in degrees, we need to convert it to radian. You must know that radian measure is pi by 180 into degree measure, correct? Also we know that pi radians is 180 degree. So x degree corresponds to pi x by 180 radians. So if it is given in degrees, you convert it to radians first. Y is equal to sine of x degree is there, no? X degree becomes pi x by 180 radian. Okay. Now differentiate this. Dy by dx. Dy by dx. Derivative of sine is cos. Cos of pi x by 180 into derivative of pi x by 180, which is pi by 180. Further differentiate terms inside the bracket. And this becomes, I can write this as pi x by 180 is nothing but x degree, right? So we can write this as pi by 180 into cos of pi x by 180 is x degree. So pi by 180 into cos of x degree. Option B is the answer. Hope you understand how to convert degree to radian. You must know this, okay? So if it is given in degrees, you can't differentiate directly. First convert degree to radian. X degree is pi x by 180 radians. More examples I'll take up in the complete synopsis. Okay, this is just a PYQ of CET. And next one is if they give sum to infinity of geometric series, as I explained here. First we have to simplify. The terms of given expression takes infinite GP. That means second term by first term. GP is geometric progression, which you learned already in first PU sequence and series chapter. Second term by first term. 1 by x by 1 by x. 1 by x square by 1 by x. Third term by second term, 1 by x. Correct? We get common ratio as 1 by x. It is constant. The ratio of the two successive terms is constant. That means it forms a geometric progression. So we can use sum to infinity of geometric series. R should lie in the interval, open interval, -1 to +1 to apply this formula. So here mod x greater than 1 is given. If mod x is greater than 1, 1 by mod x will be less than 1. Correct? That means x lies between -1 +1. See, mod x is greater than 1. They told. That means mod x is greater than 1 means 1 by mod x will be less than 1. That means 1 by x will lie between -1 and +1. Here the common ratio is 1 by x. Of course, this forms a sum to infinity of geometric series with common ratio 1 by x. So 1 by x matters for us here. 1 by x lies between -1 +1 because 1 by mod x will be less than 1 because they told mod x greater than 1. Correct? If you take the reciprocal, inequality is going to reverse. So I'll use sum to infinity of geometric series. First we'll simplify it and then differentiate because there are infinitely many terms we can't differentiate directly. So I'll use sum to infinity of geometric series. A by 1 minus r. A is the first term, r is a common ratio. Here common ratio is 1 by x. Common ratio means second term divided by first term or third term divided by second term. So conditions are suitable to apply sum to infinity of geometric series because the common ratio lies between -1 and +1. So first term is 1 here. 1 by 1 minus common ratio is 1 by x, correct? So I can write like this. Y is equal to 1 by 1 minus 1 by x. Applying sum to infinity of geometric series. A is the first term, which is 1. Common ratio is 1 by x. Now I can differentiate this. Differentiate as a differentiate 1 by x. Derivative of 1 by x is -1 by x square. Dy by dx. Dy by dx is equal to, what do you get? -1 by 1 minus 1 by x the whole square into derivative of 1 minus 1 by x. Derivative of 1 is 0. Derivative of -1 by x will be 1 by x square. Correct? Derivative of 1 by x is -1 by x square. Derivative of -1 by x is +1 by x square. Further differentiating the denominator. Correct? So now I can write this as minus, you keep as it is, and 1 by 1 minus 1 by x the whole square. If you take the square of this, no, here y square is what? squaring on both sides. Y square is equal to 1 square is 1 only. 1 by 1 minus 1 by x the whole square. So this is nothing but y square. This part is y square. So minus y square divided by x square, because into 1 by x square is divided by x square. This part is y square, correct? Hope you can see these two are same with minus sign here. So minus y square by x square, option A is the answer. So this is application of sum to infinity of geometric series. When there are infinitely many terms are given to you and ask you to differentiate, you see whether it forms a GP. If it forms a GP, then we can use sum to infinity of geometric series so that it simplifies, because there are infinitely many terms. No, differentiating all the terms is not so possible because we don't know what is the last term, right? It goes on infinitely many terms. So it's suitable to apply the sum to infinity of geometric series and then differentiate it, because it simplifies to one single term expression, correct? So that we can differentiate easily, and also we can express in terms of y itself. So options are given like that. So we can apply sum to infinity of geometric series. Another possibility is when they give infinitely many terms, no, you can also use infinite series expansion. Series expansions are the e power x, e power minus x, log 1 plus x, log 1 minus x, sin x, cos x, tan x, sin inverse x, tan inverse x, 1 plus x whole power, and all those things. Infinite series expansions are there. Maclaurin series expansion, from there it's derived actually. Questions can be asked based on that also. Okay. So next one, that is application of binomial coefficient, binomial theorem derivatives. It's better to remember the sum of the binomial coefficients. 2 power x are given. In place of n are given x. So here sum of the odd binomial coefficients and sum of the even binomial coefficients. Actually this extends actually. Plus and so on. 3 dots are there. Okay. Sum of odd binomial coefficients equal to sum of the even binomial coefficients. Both are equal to 2 power x minus 1. X is the taken the, instead of n I taken x as the variable here, and 1 plus x power n also you can learn this as a formula. Already the questions are asked based on this expression 2 times. Even in 2023 the question is asked, but I have put this type of question in second order derivatives because they ask you to differentiate 2 times. Okay, remember this expression also using binomial theorem, because 1 plus x whole power n expansion we know. What is 1 plus x whole power n? That is nc0 plus nc1 into x plus nc2 into x square, like that goes on, plus nc3 into x cube. Sorry, nc3 x cube is there only, sorry. Last term is ncn x power n. ncn x power n. nc3 x power 3 is there. Last term I am writing ncn x power n. nc0 is 1, nc1 is same as n into x, nc2 is n into n minus 1 divided by 2, 2 factorial is 2 into x square, like this goes on. If you want this term, I'll write nc3 into x power 3, nc3 is n into n minus 1 into n minus 2 divided by 3 factorial, 3 factorial is 6 into x cube, plus dot dot dot, ncn is 1, 1 into x power n is x power n. So it's better to remember this expression, is quite important. Important expression, already asked 2 times based on this. Okay, in second order derivatives I have put the question, okay, on this. Later I'll be showing this. Okay, question connected to this. And use of the algebraic identities in composite function differentiation. Can learn these formulas: a square plus b square, a plus b the whole square. Identities, it is not f I plus t, identities. Okay, a square plus b square, a plus b whole square minus 2ab, a cube plus b cube, a plus b whole cube minus 3ab into a plus b, a square minus b square, a cube minus b. All these formulas better to learn, okay, because in this 2 times the questions are asked, 2006 and 2023, on the use of algebraic identities in composite function. G of x is given like this. F of g of x is given. F of g of x. F of g of x is f of g of x, composite function. F of g of x is given as x cube minus 1 by x cube. And g of x is already given, no? G of x is given as what? X minus 1 by x. So f of x minus 1 by x is equal to x cube minus 1 by x cube. Now I'll use a cube minus b cube formula in terms of a minus b. So a minus b the whole cube we know already. What is a minus b the whole cube? A minus b the whole cube is a cube minus b cube minus 3ab into a minus b. Here you put a as x and b as 1 by x. X minus 1 by x the whole cube is equal to x cube minus 1 by x cube. You put a as x and b as 1 by x. Put a as x and b as 1 by x. Put a as x and b as 1 by x. Correct? X will cancel. So what do you get from this? X cube minus 1 by x cube. X cube minus 1 by x cube is equal to what? X minus 1 by x the whole cube. Correct? This you move it to other side plus 3 times x minus 1 by x. So I'll get expression for x cube minus 1 by x cube in terms of x minus 1 by x. Correct? So I can express in terms of g of x. I mean f of x minus 1 by x in terms of x minus 1 by x. So this will become equal to what is x cube minus 1 by x cube. I started from a minus b the whole cube formula and put a as x, b as 1 by x. So from there you get x cube minus 1 by x cube, which is x minus 1 by x the whole cube plus 3 times x minus 1 by x. So I'll write it here. This is equal to x minus 1 by x the whole cube plus 3 times x minus 1 by x. Now f of x minus 1 by x is right hand side also contains x minus 1 by x. So I can replace x minus 1 by x by new x. Therefore I can write f of x as x cube plus 3x. New x is brought. In place of x minus 1 by x I put x. That x is new x. So that f dash of x will be equal to 3x square plus 3. Giving a replacement for x minus 1 by x. So answer is option B. 2 times the questions are asked, once in 2006 and 2023. It's an important question on composite function. Use of algebraic identities in composite function. Next we got the derivatives of odd and even function. You can note down the different given the important note of odd and even function. Odd function means f of minus x equal to minus f of x. Even function means f of minus x equal to f of x. Even function examples are x square, x power 4, cos x, because cos of minus x is cos x, even function. Secant of minus x is secant x. So in the power of x is even number, it's a even function. Whenever it's a polynomial function, it is given to you. And odd function means sin x, tan x, etc. They're all odd functions. There are many odd functions and even functions. I got a list of odd functions and in terms of log, exponential, inverse trigonometric, and many other radical functions. Also, I got different list of odd functions that will be discussing in integration. Integration, where definite integration is there. Property of odd and even function, property of definite integral. They will be discussing a variety of odd functions. Okay, in terms of log, exponential, in terms of algebraic or polynomial function, in terms of inverse trigonometry function, in terms of radical functions, many odd functions are there. I'll give a list of odd functions there, okay? But for time being, just understand what is an odd function, what is an even function, and quite a few examples. And derivative of a non-constant even function is an odd function. I am using the word non-constant even function because every constant function is even function, correct? So if you take a constant function, derivative of constant function is going to be 0. Correct? Zero function means it becomes an even function. So I am taking a non-constant even function. If you take a non-constant even function, its derivative is found to be odd function. Provided the function is differentiable, such a function you should take. Don't take a non-differentiable function. Take a function which is differentiable. And derivative of an odd function is even function. And if f of x is an even function, f dash of 0 is always 0. Take any even function and differentiate and put x equal to 0, answer is 0. If you want to take an example, cos x is an even function, correct? F of x equal to cos x. It is an even function. You can differentiate it and put x equal to 0. F dash of x. Derivative of cos x is minus sin x. Put x equal to 0. F dash of 0. Sin 0 how much? 0. Minus 0 same as 0. If you take f of x equal to x square, it's an even function, correct? You differentiate an even function. Derivative of x square is 2x. F dash of 0 is equal to 0. You take any even function and differentiate and then put x equal to 0, answer is 0. Derivative of even function at x equal to 0 is always 0. Remember this. Okay. And also function f of x plus f of minus x is an even function. F of x minus f of minus x is an odd function. Both f of x and f of minus x should be defined in the domain of f. Then only I am telling. Okay, don't take a function which is not defined. F of x and f of minus x both should be defined in the domain of the function f. So then you can tell f of x plus f of minus x is an even function. F of x minus f of minus x is an odd function. And any function can be expressed as sum of odd function and even function. F of x plus f of minus x by 2 is an even function. F of x minus f of minus x by 2 is an odd function. Even function plus odd function. Okay. So given various notes of odd function and even function, derivative of an odd function is even function, derivative of a non-constant even function is odd function. Those two things are important, and any function can be expressed as sum of an even function and odd function. Like every square matrix with real entries can be expressed as sum of a symmetric matrix and a skew symmetric matrix. I can tell a function f of x can be expressed as sum of even function and odd function. Even function is f of x plus f of minus x by 2, and odd function is f of x minus f of minus x by 2. F of x plus f of minus x by 2 is an even function. F of x minus f of minus x by 2 is an odd function. And moreover, I can take an even function and differentiate. If an even function is given to you, even function means what? F of minus x equal to f of x. Correct? If an even function is given to you, f of minus x is equal to f of x. If you differentiate this with respect to x, differentiate with respect to x on both sides, what I'm going to get? F dash of minus x into derivative of minus x is minus 1 is equal to f dash of x. So what I can write is minus f dash of minus x, take it to other side, becomes plus f dash of minus x. So what I'm getting is f dash of x plus f dash of minus x equal to 0. This is for even function. This is for even function. For even function, you can remember that f dash of x plus f dash of minus x will be equal to 0. For odd function, for odd differentiable function, what happens? Odd function is f of minus x will be equal to minus f of x for odd function. If you differentiate this with respect to x, what I am going to get is f dash of minus x, f dash of minus x into derivative of minus x is minus 1 is equal to minus f dash of x. So I can cancel minus minus here, both sides. So for an odd differentiable function, you can remember that f dash of x will be equal to f dash of minus x. For an odd differentiable function, what we have? F dash of x equal to f dash of minus x. For even differentiable function, we have this f dash of x plus f dash of minus x equal to 0. F dash is missing there. Okay. So this is for even function. For even differentiable function, f dash of x plus f dash of minus x equal to 0. For even differentiable function, f dash of x plus f dash of minus x is equal to 0. Dash was missing there, the correction. Hope I understand about the differentiability of odd function and even function. So the points to be remembered in this is derivative of a non-constant even function is odd function. Derivative of odd function is even function. How to differentiate odd function? You know, odd function means f of minus x equal to minus f of x. If you differentiate that, what we get is f dash of x equal to f dash of minus x. For an odd differentiable function, f dash of x will be same as f dash of minus x. For an even differentiable function, what satisfies is f dash of x plus f dash of minus x will be equal to 0. And any function f of x can be expressed as sum of odd function and even function. Odd function is f of x minus f of minus x by 2. Even function is f of x plus f of minus x by 2. F of x and f of minus x both should be well defined in the domain of the function f. Then only we can apply this. Okay, so learn all the important note about the odd and even function and its differentiability. There are questions asked based on this. F of x is an even function. F dash of x exists. What is f dash of e plus f dash of minus e? Answer is 0. Just now I told, for an even differentiable function, f dash of x plus f dash of minus x always equal to 0. See, I have given the proof already. For an even differentiable function, what we have? F dash of x plus f dash of minus x equal to 0. That's why I'm telling always, your synopsis should be very strong. If you have a very powerful synopsis, definitely you can crack the questions in lesser time. Otherwise, you have to spend more time in the exam. In that case, you won't be able to complete the paper. So, always you should have a powerful synopsis for competitive exams. Preparation level should be very strong. That's the answer. First one answer is 0 because an even differentiable function f dash of x plus f dash of minus x is 0. So f dash of e plus f dash of minus e equal to 0. Second one, see overall I can crack the question. F of x given to be equal to g of x plus g of minus x by 2. It is an even function. Correct? 2 by h of x plus h of minus x power minus 1. It is also even function. Sum of two even function is even function and derivative of even function at x equal to 0 is always 0. I told an example also. If you differentiate an even function and put x equal to 0, answer is 0. So remember that. G of x plus g of minus x by 2 is an even function. H of x plus h of minus x is also an even function. Correct? Even function plus even function is even function. And derivative of even function at x equal to 0 is 0. Question asked in the year 2009. And one more question is f of x is a non-constant even function, f dash of x is an odd function. Over. You can crack that question in lesser time. 10 seconds enough to crack each of these questions if you know the information about the differentiability of the odd and even function. Okay, please make a note of this. 3 questions were asked based on this topic. And also, now we got the question connected to this. One question was asked in the year 2009, sine power nx into cos nx. Of course, I can give the proof of all these 4 and also tell you the technique of how to write the answer at one stretch. No need to find the derivative actually. So, very beautiful 4 points are given here. Derivative of sine power nx into cos nx. See, the first term, the first factor here, sine power nx. Here cos power nx, sine power nx. How to write? If it is derivative of sine power nx, you write n into sine power n minus 1x. As you differentiate x power n, derivative of x power n is what? N into x power n minus 1. No, likewise you differentiate n into sine power n minus 1x. Because cos power nx is that, you write n into cos power n minus 1x. Cos power nx is that, write n into cos power n minus 1x. Sine power nx is that, no, n into sine power n minus 1x. What about these second factors present here? That how to write? See, both are same functions. In the last 2 cases, both are same, both are same, no? Both are sine, both are cos, both are same function. Means you write sine of n plus 1x. Sine of n plus 1x. If different functions are there, you write cos of n plus 1x. And only for both cos functions, negative sign is there. Hope you understand how to write. I'll illustrate it once again. See, don't look at that. I'll write here. D by dx of, suppose you want to find the derivative of sine power nx into sine nx. How will you write? Differentiate sine power nx as you differentiate x power n. N into sine power n minus 1x. N into sine power n minus 1x. Correct? Now the same functions are there. No, both of them are sine. If both of them are sine or both of them are cos, then you write sine of n plus 1x. Both are same, no? Same functions. Same function in sine. Sine of n plus 1x over. Suppose you want to find the derivative of sine power nx into cos nx. What is the answer? How to start? First differentiate sine power nx as you differentiate x power n. Derivative of x power n is what? N into x power n minus 1. Likewise you differentiate. Don't apply chain rule of those things. Just write n into sine power n minus 1x. Now different functions, no? Sine and cos. Different function means write cos of n plus 1x over cos of n plus 1x. Learn the technique of writing this. Okay. Derivative of cos power nx into cos nx. Both are same, no? Both are same functions. First you start writing as you differentiate cos power nx. How do you differentiate cos power nx? As you differentiate it as you differentiate x power n. So I'll write this as n into cos power n minus 1x into derivative minus sign should be there because both are cos. Only both are cos, no, their minus sign is there. Same function, no, both are cos. So answer is sine of n plus 1x. Of course, I can do the actual method also, but I'm teaching you the better way, a shortcut, writing way, how to write this answer in lesser time. Okay, d by dx of, suppose you want to differentiate. Not over cos power nx into sin x, not over cos power nx into sin nx. Here write this as n into cos power n minus 1x. Different functions cos of n plus 1x over. For different function, cos of n plus 1x. For same function, sine of n plus 1x. Okay, that is what I wrote. Sine power nx, cos nx is the area. Correct? N into sine power n minus 1x, cos of n plus 1x. Cos power nx, sine nx. N into cos power n minus 1x, cos of n plus 1x. Sine cos power nx into cos nx. That is found here. Correct? Minus n cos power n minus 1x, sine of n plus 1x. And this is found here. So for this, sine power nx into cos nx already given here. N into sine power n minus 1x. Different function is cos of n plus 1x. So answer is option A. Hope you understand how to write this. Move on to the next one. Functional equation is given. F of x plus y equal to f of x into f of y for all x comma y belongs to R. F dash of A is f dash of 0 into f of A, where f dash of 0 exists. Okay. Two questions are asked, and that too, this question is repeated 2 times, and this is recently asked in 2024. So answer is f dash of I is 3 into 2, 6 over. Direct question. F dash of, you want to find f dash of A, f dash of 0 into f of A. F dash of 5, f dash of 0 into f of 5. 3 into 2, 6. 3 into 2, 6. Answer is 6 over. Within 5 seconds you can answer. So functional equation type of question. F of x plus y is equal to f of x into f of y. Okay. So now f dash, if you want to do the actual method, I'll do the actual method if you're interested. See, f dash of 5 they asked to find. You have to use the differentiability definition. Limit h tends to 0. F of 5 plus h, correct? F of 5 plus h minus f of 5 divided by h, using the definition of the differentiability of the function. Limit h tends to 0. F of 5 plus h could be written as f of 5 into f of h, because I told f of x plus y is f of x into f of y. Correct? F of 5 plus h will become f of 5 into f of h minus f of 5 divided by h. Now take f of 5 common there. F of 5 is common, no, in the numerator, can be kept outside the limit because it is independent of the limit. Limit h tends to 0, what is left here? F of h minus 1 divided by h. Correct? Now, f of 5 into, here, limit h tends to 0. If you apply the limit, no, denominator is becoming 0. Denominator becomes 0, numerator should become 0 by L'Hopital's rule. LH rule I can call. Correct? So that it takes 0 by 0 form. Because it takes 0 by 0 form, I apply L'Hopital's rule or L'Hopital's rule. So limit h tends to 0. Differentiate the numerator and denominator separately. You have dash of h into derivative of h is 1. Derivative of 1 is 0. Derivative of h is 1. Apply limit now. H equal to 0. What I am getting is f of 5 into f dash of 0. F of 5 is given to be equal to 2. Correct? F dash of 0 is given to be equal to 3. So answer 2 into 3 equal to 6. The actual method is also shown to you, and the shortcut method is also given to you. So a question based on the functional equation. Okay. So as denominator is tending to 0, when you apply the limit, denominator is becoming 0, numerator also should become 0. Otherwise, limit does not exist. If denominator is becoming 0 and numerator is non-zero, non-zero by 0 means what? It does not exist. For limit to exist finitely, because denominator is becoming 0, numerator should become 0. So that takes 0 by 0 form. If it takes 0 by 0 form, I can apply L'Hopital's rule. Differentiate numerator and denominator separately and apply the limit and get the answer. Hope you understand. In both the case, answer is 6. Option D and option A respectively. 3 into 2, 6. 3 into 2, 6. Next one. Question asked on the derivative of invertible function. You must be knowing the definition of invertible function, which you learned in relations and functions chapter. Correct? If two functions are given to you, f and g, which are two differentiable functions, such that they are inverses of each other. Sin x and sin inverse x, or log x and e power x, like that. Tan x and tan inverse x, inverse functions of each other. Two functions are given to you, such that derivative exists. The two functions are such that they are inverses of each other. In that case, what satisfies is f of g of x equal to g of f of x equal to x. We tell f composition g and g composition f both are identity function, correct? If f and g is f is equal to g inverse, f is equal to g inverse, what we write? F composition g is an identity function, correct? As well as g composition f is an identity function. F composition g and g composition f are identity function, means f of g of x equal to x. f of g of x is equal to x, as well as g of f of x is equal to x. F composition g and g composition f both are identity function. How to differentiate this? Differentiating this is possible. F dash of g of x into derivative of g of x, g dash of x. Here derivative of x is 1. How to differentiate g of f of x? To differentiate g of f of x, we write this as g dash of f of x into derivative of f of x, f dash of x. Derivative of x is 1. Like this we can write. And here the question asks like this: g is the inverse function of f, given like this. G is equal to f inverse. G is equal to f inverse. G is the inverse function of f. That means inverse function of f is g. Okay. F dash of x is given. Find the value of g dash of x. Okay. So either you can use this or this. One of them I can use. Because the given f dash of x, the f dash of x is given, and I ask to find g dash of x, I'll use this. G dash of f of x into f dash of x equal to 1. F dash of x is given, no? F dash of x is given as 1 by 1 plus, no, I'll use this equation. I'll use this equation. G dash of x is required. F dash of x is 1 by 1 plus exponent. What is f dash of g of x from this? F dash of g of x will be equal to 1 by 1 plus g of x to the power n. Correct? You can replace x by g of x. So f dash of g of x what? 1 by 1 plus g of x whole power n into g dash of x is equal to 1. So g dash of x is equal to what? G dash of x, you cross multiply this, you get the answer. 1 plus g of x to the power n. Even in J exams also, these type of questions are asked many times. Okay. So if f and g are two functions such that the inverses of each other, f of g of x equal to x, even g of f of x equal to x, both are applicable, and we can use this in this problem. F of g of x equal to x, differentiated, I get like this: derivative of x with respect to x is 1. Okay, f dash of g of x into derivative of g of x is g dash of x. Now f dash of g of x. F dash of g of x, what to find out? F dash of x is given 1 by 1 plus exponent. So f dash of g of x 1 by 1 plus g of x exponent into g dash of x. Correct? Cross multiply so that they get g dash of x. G dash of x is 1 plus g of x whole power n. Option C is the answer. Question asked in the year 2000. Okay, please make a note of this. Infinite series expansions, as I told, this type of concept is very useful in limits chapter for J exams, but for for CET also they can ask questions in derivatives, in differentiation. One such question is asked in the year 1999, and also in 2003 one question is asked that are included in the second order derivatives, okay, on series expansion, infinite series expansion. You can learn all these series expansions, better to learn all these things. E power x 1 plus x square by 2 factorial plus x cube by 3 factorial, etc. up to infinity. E power minus x, alternate plus minus 1 minus x plus x square by 2 factorial minus x cube by 3 factorial, etc. up to infinity. Log 1 plus x minus x square by 2 plus x cube by 3 minus x power 4 by 4 plus etc. up to infinity. Log 1 minus x minus of, minus kept outside the bracket, inside the bracket x plus x square by 2 plus x cube by 3 plus x power 4 by 4 etc. up to infinity. Correct? Log 1 minus x. Sin x. Series expansion, infinite series expansion for sin x is x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial, etc. up to infinity. Cos x 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial plus etc. up to infinity. Tan x plus x cube by 3 plus 2 by 15 x power 5 plus etc. up to infinity. Sin inverse of x is x plus 1 square into x cube by 3 factorial plus 1 square into 3 square into x power 5 by 5 factorial plus 1 square into 3 square into 5 square into x power 7 by 7 factorial, etc. up to infinity. That is sin inverse of x. Tan inverse of x minus x cube by 3 plus x power 5 by 5 minus etc. up to infinity. And also we got 1 plus x power n, where n is a fraction or a negative integer. In that case, it has infinite series expansion, infinite number of terms are there. 1 plus nx plus n into n minus 1 by 2 x square plus n into n minus 1, n minus 2 by 6 into x cube, etc. up to infinity. All these things you must learn. Okay. One such question is asked. This is a series expansion for e power x. So y is nothing but e power x. Y is given to be equal to e power x. Okay. dy by dx is also e power x. Derivative of e power x is e power x. So e power x is nothing but y. So answer is y. Option B. Okay. Learn all these infinite series expansions. Useful for JEE exams also. Next we got derivatives of inverse trigonometry functions. Some of the important results I have mentioned here. Two tables are given here. It's better to remember all these things. Okay. At least quite a few of them, which is very familiar from the NCERT book. Okay. Sin inverse of 3x minus 4x cube is 3 sin inverse of x, and derivative is 3 by root of 1 minus x square, because you know derivative of sin inverse of x 1 by root of 1 minus x square. This equation is true for all x belongs to the closed interval minus half to plus half, but for differentiability we use only the open interval minus half plus half. Endpoints are excluded for differentiability. Cos inverse of 4x cube minus 3x will be equal to 3 cos inverse of x. For x belongs to the interval half to 1. Open interval is taken. Derivative is minus 3 by root of 1 minus x square. Tan inverse of 3x minus x cube by 1 minus 3x square will be equal to 3 tan inverse x, and derivative is 3 by 1 plus x square. For the open interval minus 1 by root 3 to 1 by root 3. Questions are found in the NCERT book of this time, and even in the NCERT exemplar book also the questions are found. Okay, please learn all these formulas. It's possible to remember. Sin inverse of 2x by 1 plus x square is 2 tan inverse of x. Derivative is 2 by 1 plus x square is valid for that equation is true for x belongs to the open interval minus 1 to plus 1. All these things, proof also is done in the inverse trigonometry function chapter, correct? This can be proved by putting x equal to sin theta. This is proved by putting x equal to cos theta. Also, principal branch matters. The story of the principal branch is required here, correct? Tan inverse, here you put x equal to tan theta and prove, correct? Some of them are very mechanical, but if it goes outside this interval, you should think properly and write the answer. Sometimes questions are asked in that case also. Such kind of questions are also asked. And this is most important. Sin inverse of 2x into root of 1 minus x square is equal to 2 sin inverse of x. I think there is a mistake in this here. This should be sin inverse only here. Sin inverse. Okay, both are sin inverse. Sin inverse of 2x into root of 1 minus x square is 2 sin inverse of x for open interval minus 1 by root 2 to 1 by root 2. And this is sin inverse of 2x into root of 1 minus x square equal to 2 cos inverse x. So these two are most important actually. Sin inverse of 2x into root of 1 minus x square. Sin inverse of 2x into root of 1 minus x square. This question is asked even in 2025. Okay. Sin inverse of 2x into root of 1 minus x square. This is equal to 2 sin inverse of x, and this is 2 cos inverse of x. This is x belongs to the open interval minus 1 by root 2 to 1 by root 2. Of course, it is valid for closed interval, but for differentiability, I am telling it's valid only for open interval. We don't take the closed interval. This is for x belongs to the interval 1 by root 2 to 1. I write only open interval. I am discussing the differentiability of the function. And this also you can remember. 2 cos inverse of x for 0 to 1 by root 2. That is, derivative is also given here. If possible, better remember all these things, frequently used. And this is the most important one. Tan inverse of root 1 plus x square minus 1 by x is half tan inverse x. It's also found in the NCERT book for 3 marks, right, in the simplest form. Half tan inverse x. Many times we are going to use this. Simplified form of tan inverse root 1 plus x square minus 1 by x is half tan inverse x. Here I wrote only open interval. It's actually possible, it's valid even for closed interval, but for differentiability I am using only the open interval, so I wrote only the open interval. Hope you understand. Here there is a small mistake here, okay, so I corrected it. It's not cos inverse, it should be sin inverse. Sin inverse of 2x into root of 1 minus x square. I wrote it again here for that reason, because there was a small typing error in this case. Learn all these things. Many times Frequently questions can be asked. And the substitutions are important here. Expression and substitution. Whenever there is root 1 minus x square, we put either sin theta or cos theta. Because root of 1 minus sin square is cos theta. Root of 1 minus cos square is root of sin square is sin theta. Assuming that sin theta is positive. Root 1 plus x square, we put tan theta or cot theta. Root x square minus 1, we put secant theta or cosec theta. If it is root 1 plus x or root 1 minus x, we put cos theta or cos 2 theta. Because 1 plus cos theta, we have half angle formula, 2 cos square theta by 2. 1 minus cos theta, 2 sin square theta by 2. Half angle formulas are there, correct? So we can use those formula. Root of x by 1 minus x or root of 1 minus x by x. There you put x equal to sin square theta or cos square theta. These kind of substitutions are very much useful even in integration chapter. That's why I've shown all these things. Root of x by 1 plus x or root of 1 plus x by x, we put x equal to tan square theta or cot square theta. If it is root of x by x minus 1 or root of x minus 1 by x, then we put x equal to secant square theta or cosecant square theta. And this is more general case in terms of a here. Here it was in terms of 1, no? Here it is in terms of a. Root of a square minus x square, a sin theta or a cos theta. Root of a square plus x square, a tan theta or a cot theta, depending upon the given conditions. Root of x square minus a square, put x equal to a secant theta or x equal to a cosec theta. Root of a plus x, root of a minus x, put x equal to a cos theta or a cos 2 theta. If it is root of x by a minus x or root of a minus x by x, in that case x equal to a sin square theta or a cos square theta. Root of x by a plus x or root of a plus x by x, in that case x equal to a tan square theta or a cot square theta. If it is root of x by x minus a or root of x minus a by x, in that case you can put x equal to a secant square theta or a cosecant square theta. In terms of a it is. And root of a minus x into x minus b or root of a minus x by x minus b, in that case we put x equal to a cos square theta plus b sin square theta. All these substitutions is better to memorize. Okay. In terms of a here, this is in terms of 1, particular number 1. Here in terms of a is given. And more important note is given. You can make a note of this. Cos inverse of a cos x plus or minus b sin x, the root of a square plus b square. In that case, dy by dx the whole square is equal to 1. Because dy by dx is plus or minus 1. Because the terms inside this bracket can be expressed in terms of cos a cos b plus or minus sin a sin b. So it becomes cos of a minus b or cos of a plus b. Okay. So cos inverse cos will cancel out, and one of the term is constant there. That derivative becomes 0. Derivative of x is 1. So dy, sometimes we get plus or minus 1. That is because cos theta is same as cos of minus theta. So dy by dx is plus or minus 1. So dy by dx the whole square is 1. Even this is also similar type. These terms inside the bracket can be expressed in terms of sin of a plus b or sin of a minus b. Hence, derivative is plus or minus 1. So dy by dx the whole square is 1. This takes the form tan inverse of x plus y by 1 minus x5, which is tan inverse x minus tan inverse y. Correct? So you can divide both numerator and denominator by b cos x here. If you divide both numerator and denominator by b cos x, we'll show one of them here. If you divide the numerator and denominator by b cos x, what I'm going to get is a by b, correct? I'm dividing by b cos x, dividing by b cos x. So this will become tan x if you divide by b cos x. You're dividing by b cos x, so it becomes 1 minus this becomes a by b tan x. I'm dividing both numerator and denominator by b cos x. Now it takes the form tan inverse of x plus y by 1 minus x5. Tan inverse of x plus y by 1 minus x5 is tan inverse x plus tan inverse y with condition x into y less than 1, correct? This formula we know in inverse trigonometry function we learned. This is equal to tan inverse x plus tan inverse y. So this will be equal to what? Tan inverse a by b plus tan inverse of tan x. Tan inverse a by b plus tan inverse of tan x. And tan inverse of tan x becomes x. When you differentiate this, derivative is 0. When you differentiate this, derivative is 1. 0 plus 1 is 1. Hence, dy by dx, derivative of this is 1. Similarly, derivative of this is going to be minus 1. Okay. This will simplify to tan inverse of a by b minus tan x by 1 plus a by b tan x. So it becomes tan inverse a by b minus tan inverse of tan x. Tan inverse of a by b is a constant, derivative of that is 0. Tan inverse of tan x will be x and derivative of x 1, 0 minus 1 minus 1. So these also you can remember. Okay, various things described on derivatives of inverse trigonometric functions. So next one, we got the problems connected to this. Cos inverse of 1 minus log x the whole square by 1 plus log x the whole square. Want to find f dash of e. So we know the formula cos inverse of 1 minus x square by 1 plus x square is equal to 2 tan inverse x. This formula we are aware of. 2 tan inverse x. This is for x is greater than or equal to 0. Correct? Cos inverse of 1 minus log x the whole square by 1 plus log x the whole square. In place of x we got log x. So this f of x will simplify to what? F of x will simplify to 2 into tan inverse of log x. 2 into tan inverse of log x. Cos inverse 1 minus x square by 1 plus x square is 2 tan inverse of x. In place of x we got log x. So simplifies to 2 tan inverse of log x. Now we can differentiate it. F dash of x. Of course, log, I want to find the derivative at x equal to e. No, log e is 1. Correct? So x equal to 1 is possible here. Correct? In place of x, we got log x. For x equal to e, log e is 1. So at 1 it is valid, this formula. Because the condition is x is greater than or equal to 0. Now differentiate 2 into derivative of tan inverse is 1 by 1 plus x square. 1 by 1 plus log x the whole square into derivative of log x is 1 by x. Correct? Constant into variable. Constant keep as it is. Differentiate the variable. Derivative of tan inverse x. 1 by 1 plus x square into derivative of log x is 1 by x. Want to find f dash of e. F dash of e is how much? 2 by 1 plus log e. Log e the whole square. Log e is 1. Log e base e is 1. Correct? Into 1 by e, and this becomes 2 by 1 plus log e is 1, 1 square is 1, 2 by 2 cancels, answer is 1 by e. 1 by e is answer, option A. Next one, tan inverse 2 tan x by 1 minus tan square x. Terms inside the bracket is nothing but tan 2x, correct? Tan inverse of 2 tan x by 1 minus tan square x is tan 2x. So tan inverse of tan 2x becomes equal to x. Assume that the tan inverse of tan 2x becomes 2x for 2x belonging to the principal branch. No condition is given, you're doing it mechanically. Question asked in 1984. And during that time, we're not considering any conditions, doing mechanically all these things. Nowadays, we consider all the domain, range, all those things. So much important, everything, correct? So derivative of 2x is 2. Answer is option B. Tan inverse of 3x, want to find dy by dx. Dy by dx it is. Dy by dx is equal to derivative of tan inverse x formula. 1 by 1 plus x square. 1 by 1 plus 3x the whole square into derivative of 3x is 3. So answer is 3 divided by 1 plus 9x square, which is option B. Very simple question. Next one, tan inverse 2x by 1 minus x square. We know tan inverse 2x by 1 minus x square is 2 tan inverse x. Condition is there actually for x belonging to the open interval, minus 1 to plus 1. So dy by dx is equal to what? Constant into variable. Constant keep as it is. Derivative of tan inverse x is 1 by 1 plus x square. So 2 by 1 plus x square. Option D is the answer. Move on to the next one. Y is equal to, question asked 2 times. See, one recently 2022 and 1990. So many years gap. The question is asked once again. Y is given like this. Want to find dy by dx. Here you can apply product rule because it's multiplication of two functions. Apply product rule here. Dy by dx is equal to, first function keep as it is. Differentiate tan inverse x. Derivative of tan inverse x is 1 by 1 plus x square. Plus second function keep as it is. Tan inverse x into derivative of 1 plus x square is 2x. First function keep as it is, differentiate the second function. Plus second function keep as it is, differentiate the first function. Minus derivative of x is 1. Here 1 plus x square is going to cancel. 1 plus, what is left? 2x into tan inverse x minus 1. Plus 1 minus 1 will add up to 0. So answer is 2x into tan inverse x. Option B is the answer. Very simple question. Just apply product rule and differentiate. First into derivative of second, plus second into derivative of first. Okay? And derivative of x is 1. These two will cancel out. Plus 1 minus 1 will add up to 0. Answer is 2x into tan inverse of x. Move on to the next one. Sin inverse of 2x by 1 plus x square f dash of root 3. Want to find the derivative of this function at x equal to root 3. So I told already sin inverse of 2x by 1 plus x square. Sin inverse of 2x by 1 plus x square is there, no? This becomes equal to 2 tan inverse x. 2 tan inverse x if x belongs to the closed interval, actually minus 1 to plus 1, but by discussing the differentiability, it's open interval. So x belongs to the open interval minus 1 plus 1 for differentiability, I'm telling. For differentiability. For differentiability is open interval. So we are discussing the derivative at root 3. Root 3 is not there in this interval, correct? Root 3 is roughly 1.732, which does not lie in the interval minus 1 to plus 1. So we can't use this formula directly. So I'll go by the actual method of substitution. Of course, you can remember the formula for x greater than 1 also. But everything we can't remember. We're learning for 2 years the PU course, PU mathematics for 2 years and writing the exam in 1 hour or 1 hour 20 minutes. So much to remember is not possible, correct? Everything will forget if you learn more. So I won't insist you to learn these formulas. I will insist you to learn the formulas which is frequently used and which is already there in the NCERT book only or it's repeatedly and it's possible to remember. Only such kind of things I will insist to remember. So you put x equal to tan theta. I'll go by actual method. Put x equal to tan theta. It should not take much time actually, even though if you're going by actual method. F of x becomes equal to what? Sin inverse of putting x equal to tan theta, right? So terms inside the bracket becomes 2 tan theta divided by 1 plus tan square theta. 2 tan theta by 1 plus tan square theta, terms inside the bracket will be equal to sin 2 theta. Sin inverse of sin 2 theta will become 2 theta only if 2 theta belongs to the principal branch. What is the principal branch of sin inverse? Closed interval minus pi by 2 to pi by 2. Whether it belongs to the principal branch or not, you should check. Because my value of x is root 3. Correct? X is root 3 given. Because you're finding derivative at root 3. X is tan theta, your substitution. The substitution is x equal to tan theta. Tan theta is root 3 means theta is equal to how much? Pi by 3. Tan pi by 3 is root 3. So 2 theta is the angle present there. 2 theta is equal to how much? 2 pi by 3. 2 pi by 3 does not lie in the principal branch of sin inverse, which is closed interval minus pi by 2 to pi by 2. So sin inverse of sin 2 theta is not equal to 2 theta. It doesn't become equal to 2 theta because 2 theta value for x equal to root 3 is 2 pi by 3, which does not lie in the principal branch of sin inverse. Hope I understand. So we know the sine of an angle is always equal to sine of its supplement angle. So sine inverse of sine 2 theta, I can write it as sine inverse of sine of pi minus 2 theta. Correct? I can write this as sine 2 theta sine of pi minus 2 theta. So what do you get? Pi minus 2 theta. Pi minus 2 theta is how much? Pi minus 2 theta is 2 pi by 3. Pi minus 2 pi by 3 is going to be equal to pi by 3. Now pi by 3 lies in the principal branch of sin inverse. So if 2 theta does not lie in the principal branch, pi minus 2 theta lies in the principal branch, correct? Because my 2 theta value is 2 pi by 3 for x equal to root 3 because I am finding the derivative at x equal to root 3. So pi minus 2 theta belongs to the principal branch. So now I can cancel out these two and write pi minus 2 theta. And substitute back for theta finally. Theta is equal to tan inverse of x. Pi minus 2 tan inverse of x. Pi minus 2 tan inverse of x. Now differentiate f dash of x. Derivative of constant is 0. Minus 2 into derivative of tan inverse x. 1 by 1 plus x square. Now you put x equal to root 3. F dash of root 3. F dash of root 3 is equal to minus 2 divided by 1 plus root 3 square is 3, correct? Minus 2 by 4, which is equal to minus half. Answer is minus half. Hope you understand. Don't write answer is half. Half is wrong. Minus half is the answer. Question asked in 2020. Move on to the next one. Sin inverse of 2 power x plus 1 by 1 plus 4 power x. Here we know sin inverse of 2x by 1 plus x square, as we did in the previous question. Same type of question is asked, but instead of x it's given 2 power x. This could be written as f of x is equal to sin inverse of 2 power 1 into 2 power x divided by 1 plus 4 is 2 square, correct? 2 square to the power x. So I can write this as sin inverse of 2 into 2 power x divided by 1 plus what you do is x you bring inside, 2 you take outside. x and 2 can be interchanged, correct? Like this. So 2x by 1 plus x square. Sin inverse of 2x by 1 plus x square is 2 tan inverse of x. For x belonging to the open interval minus 1 plus 1, we discussed the differentiability, correct? So in place of x, we got 2 power x. And you are finding derivative at x equal to 0. 2 power 0 is 1, correct? So what do you get here? This becomes sin inverse of 2x by 1 plus x square. Sin inverse of 2x by 1 plus x square is 2 tan inverse of x. So this becomes 2 tan inverse of 2 power x. 2 tan inverse of 2 power x. Correct? Divided by 5, I think this is missing small. Divided by 5, is that okay? Now can differentiate and put x equal to 0. F dash of 0. F dash of 0 is equal to 2 into f dash of x you need to find out first. You need to find f dash of x, then find f dash of 0. F dash of x is equal to 2 into derivative of tan inverse is 1 by 1 plus 2 power x square into derivative of 2 power x is 2 power x log 2, right? But the thing is, if you put directly x equal to 0, and if you're doing the actual method, no, I think there is some controversy in this question. F dash of x equal to, if you're differentiating this directly, derivative of sin inverse of x, you know, formula 1 by root of 1 minus x square. 1 by root of 1 minus this entire thing square into d by dx of, correct, 2 power x plus 1 divided by 1 plus 4 power x, correct? Here you are putting x equal to 0. This here what I am writing is 2 power x plus 1 divided by 1 plus 4 power x, correct? See, f dash of 0, I am putting x equal to 0, no? Here 1 by root of 1 minus, here 0 plus 1 is 1, correct? 2 power 1 is 2, correct? 4 power 0 is 1, 1 plus 1 2. Here it becomes 2 by 2 is 1, 1 square 1, 1 minus 1 0, 1 by 0, whatever this is becomes 1 by 0. F dash of 0 does not exist actually. Answer is does not exist, because I told you sin inverse of 2x by 1 plus x square equal to tan inverse of x. Differentiability is possible if x belongs to the open interval minus 1 to plus 1, correct? But in place of x, what is given is 2 power x, correct? Here by putting x equal to 0, for x equal to 0, 2 power x becomes 2 power 0, which is 1, correct? So 2 power x should belong to open interval minus 1 plus 1, but here it is becoming equal to plus 1, that means 1 is included. So differentiability is not possible actually. It's a faulty question actually. No options are found actually. Faulty question because no options are found in this. If you differentiate it directly or by using that formula, sin inverse of 2x by 1 plus x square is 2 tan inverse of x. Differentiability is possible if x belongs to the open interval minus 1 plus 1. That means 2 power x should belong to the open interval minus 1 plus 1. Because in place of x, no, what we have is 2 power x. 2 power x should belong to the open interval minus 1 plus 1. But for x equal to 0, 2 power x is becoming 1. So this point is not correct. At this point, the function is not differentiable. F is not differentiable. Question asked in the year 2019. The function is not differentiable. It becomes 1 by 0. It is not defined. Hope you understand. That's why we have to exclude the endpoints whenever we discuss the differentiability. Okay? Be careful. Don't blindly write the answer. If you do mechanically, you'll get the answer as f dash of 0 is equal to 2 into 2 power 0 is 1. 2 into log 2 divided by 1 plus 2 power 0 is 1, 1 square is 1, 1 plus 1, 2 cancels, log 2. Log 2 is the answer. That's wrong actually. The function is not differentiable. Don't do it directly, blindly, okay? Move on to the next one. 2002 and 2017, 2 times the questions are asked. So this is a quite simple question. No conditions are given. Whenever sine plus cos is same as cos plus sine, no? We can divide numerator and denominator by cos. This kind of expression is very familiar. Tan inverse of sine plus cos is same as cos plus sine. Cos x plus sine x divided by cos x minus sine x. Whenever you get expression of this type, what we do? You divide both numerator and denominator by cos x. Cos by cos is 1, cos by cos 1, sin by cos tan, correct? You divide both numerator and denominator by cos function. What we get? Tan inverse of this becomes 1 plus tan x divided by 1 minus tan x. 1 plus tan x by 1 minus tan x is tan of pi by 4 minus x. Tan inverse of tan of pi by 4 plus x. 1 plus tan x by 1 minus tan x is tan of pi by 4 plus x. Tan inverse of tan pi by 4 plus x is pi by 4 plus x. Differentiate. So far we are not differentiated. Now differentiated. Derivative of pi by 4 is 0. Derivative of x is 1. So dy by dx is 1. Option A is the answer. This type of question already told. F dash of 0.5 they ask. Answer is either plus 1 or minus 1. You note that 2 by root 13 and 3 by root 13 can be expressed in terms of sine and cos. They form the sides of a right angle triangle. If you take 2 by root 13, suppose you take this angle as alpha, this is 2 and this is 3. 2 square plus 3 square is 13. 2 square is 4, 3 square is 9. 9 plus 4, 13. So hypotenuse will be root 13. So if you define cos alpha as 2 by root 13, sin alpha becomes 3 by root 13, correct? Cos is adjacent side by hypotenuse, sin is opposite side by hypotenuse. So f of x will become cos inverse of here 2 by root 13 is there. No, 2 by root 13 is cos alpha into cos x minus 3 by root 13. 1 by root 13 has been multiplied, no, inside the bracket. 3 by root 13 is sin alpha into sin x. What is cos A cos B minus sin A sin, which is cos of A plus B. Cos A cos B minus sin A sin B is cos of A plus B. So what do you get? Cos inverse of x plus alpha. Correct? Cos inverse of x plus alpha is x plus alpha. So f dash of x is equal to 1. Alpha is a constant, no? So alpha is cos inverse of 2 by root 13 or alpha is sin inverse of 3 by root 13. Both are constant. Derivative constant is 0. Alpha is a constant. Derivative of constant is 0, right? So f dash of x is 1. F dash of 0.5 is also 1. No conditions are given. I can write cos theta is also same as cos of minus theta, right? So f of x also equal to cos inverse of, what I can write is cos of minus of x plus alpha. Correct? Cos theta is also same as cos of minus theta. So this becomes what? Cos inverse of minus of x plus alpha is minus of x plus alpha. Now you find f dash of x, it is going to be equal to minus 1. So f dash of 0.5 is going to be equal to minus 1. Cos theta is same as cos of minus theta. Plus 1 as well as minus 1. Both answers are correct here. At x equal to half we are discussing, correct? F dash of, that is cos theta is equal to cos of minus theta. Hence we get two different answers here. Okay. That's why I put square in that note because of plus or minus 1. Next one, given like this question, y is equal to tan inverse of, there is one small correction here, it is 3x, not 2x, okay, this should be 3x plus 3. Tan inverse of 1 by x square plus 3x plus 3 plus tan inverse of 1 by x square plus 5x plus up to n terms. Want to find y dash of 0. 2012 question asked in the year 2012. So here what we can do is here to simplify here, because there are up to n terms, so we need to simplify it. We are using this formula tan inverse of x plus y by 1 minus xy repeatedly. Tan inverse of x plus y divided by 1 minus xy, and many of the terms are going to cancel out. I think tan inverse of x minus y by 1 plus xy I am using. Tan inverse of x minus y by 1 plus xy. Tan inverse of x minus y divided by 1 plus xy is equal to tan inverse x minus tan inverse y. This formula I am going to use repeatedly, and many of the terms are going to cancel out. At last only two terms will survive. Okay, and then differentiate and put x equal to 0. Okay, that's the question. So what I can do is I can write this as tan inverse of denominator 1 plus, I'll take x common there, x square plus x, no x common, so x plus x into x plus 1, so then I get x square plus x. Numerator 1 I can write it as x plus 1 minus x, correct, plus tan inverse of denominator, no here, write 1 first, then what is left is x square plus 3x plus 2, x square plus 3x plus 3 is there, no, x square plus 3x plus 3 is actually 1 plus x square plus 3x plus 2. X square plus 3x plus 2 is x plus 1 into x plus 2. Correct? This is x plus 1 into x plus 2. Here I can write x plus 2 minus of x plus 1. So that difference will be 1. Correct? Like that you go on continue. Tan inverse of next term will be denominator x square plus 5x plus 7 is 1 plus x square plus 5x plus 6. 1 plus what is left out is x square plus 5x plus 6, which is x plus 2 into x plus 3. Correct? And numerator 1 can be expressed as x plus 3 minus of x plus 2. Correct? Writing the numerator in terms of denominator. Like this go on continue up to n terms. Up to n terms. So this is tan inverse of x minus y by 1 plus x y is tan inverse x minus tan inverse y. This is tan inverse of x minus y by 1 plus xy. Repeatedly using this formula. Okay. Everywhere you apply this formula. So what it simplifies to is the first term will become tan inverse of x plus 1 minus tan inverse of x. Next term will be tan inverse of x plus 2 minus tan inverse of x plus 1. Tan inverse of x plus 2 minus tan inverse of x plus 1. Like this it go on continue. Next term will be tan inverse of x plus 3 minus tan inverse of x plus 2. Like this it goes on. Now nth term will be tan inverse of x plus n minus tan inverse of x plus n minus 1. Many of the terms are going to cancel. See, tan inverse of x plus 1 is going to cancel here. If I want to change the ink here, tan inverse of x plus 2 will cancel. Tan inverse of x plus 3 will cancel the next term. Next term will be tan inverse x plus 4 minus tan inverse x plus 3. Correct? Tan inverse of x plus 3 will cancel the next term. Last but one term will be tan inverse x plus n minus 1 minus tan inverse x plus n minus 2. So tan inverse x plus n minus 1 will cancel. What will not cancel is only two terms. Tan inverse of x plus n minus tan inverse of x. Second and second last will not cancel. So then you can differentiate that. So what is left out is tan inverse of x plus n minus tan inverse of x. At this stage we can differentiate it. Okay, dy by dx. Want to find the derivative, y dash of 0 they ask. That means you differentiate and put x equal to 0. 1 by 1 plus x plus n the whole square into derivative of x plus 1 is 1 minus derivative of tan inverse x is 1 by 1 plus x square. Now put x equal to 0. Therefore, dy by dx at x equal to 0. After differentiating, put x equal to 0. What do you get? 1 by 1 plus 0 plus n square. 1 by 1 plus n square minus 1 by 1 plus 0, that is 1. Take LCM, 1 plus n square. Here 1 minus of 1 plus n square. Here plus 1 minus 1 cancels. We get minus n square divided by 1 plus n square. So answer is option D, minus n square divided by 1 plus n square. Hope you understand. Just repeatedly apply this formula. Tan inverse of x minus y by 1 plus xy. Tan inverse x minus tan inverse y. And many of the terms are going to cancel. At last, only two terms are going to remain. Differentiate that and put x equal to 0. Next one. This question appeared two times. Once in 2011 and recently in the year 2024. So, you want to find the derivative of this cos square cot inverse root of 2 plus x by 2 minus x. Well, there are two methods of doing this problem. One is by method of substitution. Because there is root 2 plus x and root 2 minus x, we put x equal to 2 cos theta. As I told, root of a plus x and root of a minus x is, that means you put x equal to a cos theta. Correct? That is one way of finding the simplified form and then differentiating. Another way is we can convert this cot inverse to cos inverse. Cot inverse means it is adjacent by opposite. You can draw the triangle like this and mark the angle as theta. Say this angle is theta. Cot inverse means it is adjacent side by opposite. Root of 2 plus x by root of 2 minus x. Correct? So root of 2 plus x square is 2 plus x. Root of 2 minus x square is 2 minus x. Square of this plus square of this, how much? Root of 2 plus x the whole square. Applying the Pythagoras theorem, root of 2 minus x the whole square will be equal to how much? Root of 2 plus x whole square is 2 plus x. Root of 2 minus x whole square is 2 minus x. Becomes 4. Square root of that is 2. So I can convert this cot inverse of root of 2 plus x by 2 minus x. If you want to convert it to cos inverse, it becomes adjacent by hypotenuse. So d by dx of cos square of cot inverse, or I'll convert cot inverse to cos inverse and write cos inverse. I'll write this is cos inverse of adjacent by hypotenuse, root of 2 plus x divided by 2. Correct? Cot inverse adjacent by opposite is cos inverse adjacent by hypotenuse. So this becomes d by dx of cos square theta means cos theta the whole square, right? So this is cos of cos inverse root of 2 plus x by 2 the whole square. Correct? Cos square theta means what? Cos square theta means cos theta the whole square. Cos of cos inverse root 2 plus x by 2 is root of 2 plus x by 2. Root of 2 plus x by 2 the whole square. Root of 2 plus x square is 2 plus x. And root 2 square is 4. 2 by 4 is half plus x by 4. Now we can differentiate this. D by dx is there. Need to differentiate this. D by dx of. Correct? Need to differentiate this. D by dx of. Derivative of half is 0. Derivative of x by 4 is 1 by 4. Answer is 1 by 4 over. That's it. Option A is the answer. Another way of doing this problem is by putting x equal to 2 cos theta. Go on, simplify it and then differentiate. If you are doing by another method, put x equal to 2 cos theta. So that cos theta will be equal to x by 2. Cos theta is equal to x by 2. So this becomes what? D by dx of, this becomes cos square of cot inverse of root of 2 plus, putting x as 2 cos theta, because root of a plus x means you are putting x equal to a cos theta. Correct? Like this. Go on, simplify. That's equal to d by dx of cos square of cot inverse of, what is left? Take 2 common, 1 plus cos theta. Correct? Here 2 common, 1 minus cos theta. 2 cancels. 1 plus cos theta is 2 cos square theta by 2. 1 minus cos theta is 2 sin square theta by 2. Half angle formula. 2 cancels. Cos square by sin square is cot square. Root of cot square is cot. Cot inverse of cot theta by 2 becomes theta by 2. So it becomes d by dx of cos square of cot inverse of cot theta by 2. That is theta by 2. So this becomes d by dx of cos square theta by 2 is 1 plus cos theta divided by 2. And cos theta is x by 2, substitute back, then differentiate. D by dx of, this will be 1 by 2, correct? Cos theta is x by 2, x by 2 by 2 is x by 4, same answer I am getting. D by dx of 1 by 2 plus x by 4. Derivative of 1 by 2 is 0, derivative of x by 4 is 1 by 4. Any method you can do. This method is much easier, or you can do it in lesser time. So answer is option A. Many times questions do repeat. See 2011, 2024. Earlier we saw 2009, 2023, 2006, 2023. Questions are repeating. Okay. So don't think that previous set questions will not repeat. Of course, lesser number of questions will repeat, but we'll get the idea what kind of questions will be asked and what is the extent, what is the level of questions, and you also are exposed to a variety of questions. Whenever you want to attend any competitive exams, if you're writing CET exams, you should be thorough with all the PYQs. If you're writing JEE exams, first you should be thorough with all the PYQs of JEE exams. Synopsis, strong synopsis should be there, and also all the PYQs should be known. That is the first basic thing anyone should do if you are attending any competitive exams. Then if you finish that, then you can go for other books. Okay. Here also, this is very simple question, NCERT book level question. Sin x by 1 plus cos x. Sin x, we know half angle formula, 2 sin x by 2 cos x by 2, correct? Go on, simplify it. Tan inverse of sin x is what? 2 sin x by 2 cos x by 2. 1 plus cos x is 2 cos square x by 2. 2 cancels. 1 cos will cancel. 1 cos remains. Sin by cos is tan. Tan inverse of tan x by 2 is equal to x by 2. Tan inverse of tan x by 2 is equal to x by 2. Differentiate this. Dy by dx equal to half. Very simple question. Dy by dx equal to half. So this question also appeared in the year 1993. Okay, I forgot to mention it. 1998 as well as 1993. 2 times same question is asked. Just simplify using half angle formula. Sin x is 2 sin x by 2 cos x by 2. 1 plus cos x is 2 cos square x by 2. Move on to the next one. Tan inverse of root 1 plus x square minus root 1 minus x square by root 1 plus x square plus root 1 minus x square. Want to find dy by dx. Here, because there is root 1 plus x square and root 1 minus x square, we make a substitution that x square equal to cos theta. Put x square equal to cos theta and simplify it. Put x square equal to cos theta. In the same problem, we can't put two different substitutions. Whenever there is root 1 plus x square, we put tan theta. X equal tan theta or cot theta. If it is root 1 minus x square, we put either sin theta or cos theta. But here both root 1 plus x square and root 1 minus x square are present. So we don't put here x square equal tan theta and here put x square equal sin theta. That becomes meaningless. We can't put here this term x square equal to tan theta, this x square equal to sin theta, here tan theta, here sin theta, tan theta equal to sin theta. Is it possible for all values? No, correct? So we don't put such kind of substitution. What we do is, instead of putting x equal to tan theta or sin theta, we put x square equal to cos theta. So then we can use half angle formula. Because we are putting x square equal to cos theta, 1 plus cos theta, I can use 2 cos square theta by 2. 1 minus cos theta, 2 sin square theta by 2. I can use those formula, correct? So I'll use the substitution that x square equal to cos theta and simplify. Putting x square equal to cos theta, this simplifies to what? Y is equal to tan inverse of root of 1 plus, putting x square as cos theta minus root of 1 minus cos theta divided by root of 1 plus, putting x square as cos theta, correct? Putting x square as cos theta, use half angle formula and simplify it. 1 plus cos theta is 2 cos square theta by 2, correct? 1 plus cos theta is 2 cos square theta by 2. 1 minus cos theta is 2 sin square theta by 2. Simplifying it becomes root 2 cos theta by 2. This is root 2 into sin theta by 2. Root 2 into cos theta by 2 plus root 2 into sin theta by 2. Root 2 can be cancelled from numerator and denominator. Cos minus sin by cos plus sin you get. Whenever you get cos minus sin by cos plus sin, what we do? You divide numerator and denominator by cos. Root 2 cancels from the numerator and denominator. Simultaneously divide numerator and denominator by cos. Cos by cos will be 1. Sin by cos is tan. Correct? Tan inverse of what we get? 1 minus tan theta by 2 divided by 1 plus tan theta by 2. Dividing numerator and denominator by cos theta by 2. 1 minus tan by 1 plus tan is tan of pi by 4 minus theta by 2, correct? So this becomes tan inverse of tan of pi by 4 minus theta by 2. So what you get is pi by 4 minus theta by 2. So theta is equal to what? Cos inverse of x square. Theta is equal to cos inverse of x square. So we get pi by 4 minus theta by 2 means half into theta. Half into theta is cos inverse of x square. Now you differentiate. So far we are not differentiated. At this stage I am going to differentiate it. dy by dx I'm going to find, correct? So far only simplification part we did. Dy by dx equal to derivative of constant is 0, pi by 4 is constant, constant into variable, constant keep as it is. Derivative of cos inverse is minus 1 by root of 1 minus x square x power 4 into derivative of x square is 2x, correct? Minus of minus is going to be plus, 2 is going to cancel. What I'm going to get is x by root of 1 minus x power 4. Option D is the answer. Hope you understand this. Such kind of questions are found in the NCERT exam book, also in the miscellaneous exercise. We can't neglect these type of questions. Okay, question asked in the year 2005. Derivative of constant is 0, constant into variable, constant keep as it is. Derivative cos inverse is minus 1 by root of 1 minus x square x power 4 into derivative of x square is 2x, 2 cancels, minus of minus plus x by root of 1 minus x power 4. Option D is the answer. On to the next one, question number 14, question asked in the year 2004. Write secant x as 1 by cos, tan as sin by cos, go on simplify. What we get? Y equal to tan inverse of secant x we can write 1 by cos x. Tan we can write sin x by cos x. This is equal to, taking common denominator, what I am getting is 1 minus sin x divided by cos x. Already told, remember that cos x by 1 minus sin x. Cos x by 1 minus sin x is tan of pi by 4 plus x by 2. Simplified form. Already one such kind of simplification I did earlier. Remember this. And cos x by 1 plus sin x is tan of pi by 4 minus x by 2. Remember these two. Okay. Quite useful. Many times questions can be asked based on this. So tan of pi by 4 plus x by 2. This is cos x by 1 minus sin x. What is present here is reciprocal of this. Reciprocal of this is present here. Reciprocal of tan is going to be cot, correct? So this becomes tan inverse of, correct? What is there? Cos x by 1 minus sin x. Reciprocal is present here. 1 minus sin x by cos x. So take the reciprocal of tan, which is cot. Cot of pi by 4 plus x by 2. Cot of pi by 4 plus x by 2. And cot theta is tan of pi by 4 minus theta, right? So tan inverse of cot of pi by 4 plus x by 2 will be tan of pi by 4 minus x by 2. Because cot theta is tan of pi by 2 minus cot theta. It's tan of pi by 2 minus theta. Correct? So this becomes pi by 2 minus pi by 4 is pi by 4. Minus into plus will be minus x by 2. Now you can differentiate it. Dy by dx. Derivative of pi by 4 is 0. Derivative of x by 2 is half. So answer is minus half. Cot theta is tan of pi by 2 minus theta. This is acting as theta here. Hope you understand. So answer is minus half. Similar type of question is present in the NCERT exam that book. It is tan inverse of secant x plus tan x. There you'll get the answer as half. Move on to the next one. This is quite simple question. Tan inverse of x plus a by 1 minus xa. Of course, a is a constant here. It takes the form tan inverse x plus y by 1 minus xy. We know the formula. Tan inverse of x plus y by 1 minus xy is tan inverse x plus tan inverse y. No? So this is simplified to tan inverse x plus tan inverse a. Tan inverse x plus tan inverse a. Then differentiate this. Dy by dx. Derivative of tan inverse x is 1 by 1 plus x square. And derivative of tan inverse a is constant. Correct? No, derivative is 0. A is a constant. So tan inverse a is a constant. Derivative of constant is 0. Tan inverse of a is a constant. So answer is 1 by 1 plus x square. Option B. Move on to the next one. Y equal to sin inverse of cos x. Cos x we can write it as sin of pi by 2 minus x using aligned angles. Correct? Cos x could be written as sin of pi by 2 minus x. Sin inverse of sin of pi by 2 minus x is pi by 2 minus x, assuming that it lies in the principal branch. So dy by dx equal to derivative of constant is 0. Pi by 2 is a constant. Derivative of x is 1. So 0 minus 1 is minus 1. Option C is the answer. Move on to the next one. Now we got implicit function differentiation. Type 1 I mentioned here, based on dy by dx equal to minus fx by fy, means differentiating f partially with respect to x. Fx means what? Differentiating the given function f partially with respect to x, keeping y as constant. Fy means differentiating the function y with respect to y, keeping x as constant. So this is a shortcut method. Whenever an implicit function is given, you can apply this shortcut and get the answer. This is an implicit function, no? So I can find out dy by dx is equal to, first question I am doing, minus fx by fy, correct? That means y equal to x into sin y, could be written as y minus x into sin y equal to 0. Right, like this. Writing all the terms to one side. Shift all the terms to one side. Now write minus sign first, referring to this function as f of x comma y. You can differentiate this left hand side with respect to x partially, means keep y as constant. If y is treated as constant, derivative of y with respect to x will be 0, because y is acting as a constant now. Sin y is constant, because y is constant, sin y is constant. Constant keep as it is, derivative of x is 1. Sin y into minus 1, that is minus sin y. So minus already there according to the formula. Fx means derivative of y with respect to x 0. Sin y is constant, constant keep as derivative of minus x minus 1. Sin y into minus 1. So minus sin y, correct, divided by fy. Fy means I am differentiating with respect to y partially. Derivative of y with respect to y is 1. Okay, and minus x is constant, derivative of sin y with respect to y is cos y, minus x into cos y, minus x into cos y. So one line answer, we get the answer as sin y divided by 1 minus x cos y. Option D is the answer. Question asked 2 times already, 1984 and 1985, 2 times the questions were asked. Similarly, we can do the second one, dy by dx. Write this as y minus x cos y equal to 0. Second question. Writing all the terms to one side. Differentiate this with respect to x partially, keeping y as constant. Dy by dx is minus fx by fy. Correct? Directly also we can differentiate. Minus I wrote according to the formula. Fx means I am differentiating the given function f partially with respect to x. Y is constant, derivative of constant 0. Correct? And cos y is constant, derivative of x 1. Cos y into minus 1. Minus cos y. Minus cos y divided by, differentiate this partially with respect to y, derivative of y is 1. Here cos y is x is constant, derivative of cos y is minus sin y, minus into minus plus x into sin y. Differentiating with respect to y partially, so cos y divided by 1 plus x into sin y. Answer is cos y divided by 1 plus x into sin y. Option B is the answer. Hope you understand this. Differentiating partially with respect to x, that is fx. Differentiating partially with respect to y, that is fy. Next one, y square minus 2x square equal to y. Here also we can write all the terms to one side. Then differentiate partially. Y square minus 2x square minus y equal to 0. This will take it as f of x comma y equal to 0. F of x comma y equal to 0. Now I want to find dy by dx. Dy by dx is equal to minus fx by fy. Correct? Minus fx by fy. Minus you keep as it is. Differentiate partially with respect to x. Derivative of y square 0, because y is constant. Derivative of 2x square, that is 4x. Derivative of y, that is 0. Differentiate partially with respect to y, keeping x as constant. Derivative of y square is 2y. Derivative of 2x square is 0, because 2x square is constant. Derivative of y with respect to y is 1. Now find dy by dx at 1 comma minus 1. At 1 comma minus 1. Correct? Minus into minus plus 4 into x is 1 by 2 into y is minus 1. Correct? Minus 1. 4 by minus 2 minus 1 minus 3. So minus 4 by 3. Option A is the answer. Hope you understand. Differentiating partially with respect to x. Derivative of y square 0. Derivative of y 0. Derivative of 2x square 4x. Minus of minus plus 4x. X equal to 1. Substitute. Derivative of y square 2y. Derivative of 2x square is 0. Derivative of y is 1. 2 into minus 1. Because y is minus 1. At the point 1 comma minus 1 means you are putting x equal to 1, y equal to minus 1. Correct? 2 into minus 1, minus 2, minus 2, minus 1, minus 3. So minus 4 by 3. Option A is the answer. Next one also. Y is equal to x into tan y. Want to find dy by dx. We can rewrite this as y minus x into tan y equal to 0. Correct? Want to find dy by dx. I'm using the formula minus fx by fy. Dy by dx is equal to minus fx divided by fy is equal to minus fx means you differentiate partially with respect to x. Derivative of y is 0 minus tan y into derivative of x1 minus tan y into derivative of x is 1 divided by fy means differentiate with respect to y partially. Derivative of y is 1 minus x into derivative of tan y is secant square y. Correct? Derivative of y with respect to y is 1. X into tan y. X is constant. Derivative of tan y with respect to y is secant square y. I want to get the answer in terms of like this. Of course, numerator tan y is that. Minus of minus becomes plus tan y divided by 1 minus x into secant square y. I can write 1 plus tan square y. Correct? 1 plus tan square y using the trigonometric identity. Numerator is tan y divided by 1 minus x into 1x minus into plus minus x into tan square y. What is tan y from this? Tan y is y by x. Tan square y will be y square by x square. Correct? So 1x will cancel there. What I am going to get? Tan y divided by 1 minus x minus 1x will cancel. I am getting y square divided by x. You can take x as common denominator and simplify it. What I'm going to get there in that case, 1x has been cancelled, correct? No, tan y is y by x. Tan y is y by x. Is simplified. Take LCM as x. That x will go up. X into tan y. X into tan y divided by x minus x square minus y square. And x into tan y is nothing but y, correct? X into tan y is nothing but y. So I'm getting this as y by x minus x square minus y square. Option B is the answer. Next one, the value of dy by dx. Value of dy by dx at the point minus 1 comma 3 on this curve. So this is an implicit function. X and y are mixed up on the same side of the equation. So we can differentiate it first by using the shortcut method minus fx by fy and substitute the point x equal to minus 1, y equal to 3. Sometimes whether the point lies on this curve or not, you can verify it. Sometimes the given question might be wrong also. In that case, just you try by putting x equal to minus 1 and y equal to 3. 3 into minus 1 square, 3. 4 into minus 1. Minus 4 into 3, minus 12. Correct, no? 2 into 3 square. 3 square is 9. 9 2s are 18. Correct? X equal to minus 1 plus 8. Whether it satisfies, you see. 18 plus 8, that is 26. 26 plus 3. I think this question is not correct. Correct? By putting x equal to minus 1 and y equal to 3, the point does not lie on the curve. Point does not lie on the curve. When you put x equal to minus 1 square 1, 1 into 3, 3, 4 into minus 1, minus 4 into 3, minus 12, 3 square is 9, 9 2s are 18, x is minus 1 and 8, correct? This point 18 plus 3, 21 plus 8, 29, 29 minus 13 is not equal to 0. So the point does not lie on the curve. It's a faulty question actually, correct? It's not a proper question. If you put x equal to minus 1 and y equal to 3, you should get left hand side equal to right hand side, which is not so. I'm not getting it. So I will not do this problem. You can take it as none of this because the point does not lie on the curve. It does not satisfy the equation. Move on to the next one. Here we shall verify whether the point lies on the curve or not by putting x equal to 1 and y equal to 3. 2 into 1 square plus 3 into 1 into 2 plus 4 into 2 square. Does it become 24? We shall check. 1 square is 1. 1 into 2, 2. 3 into 2, 6. 2 square, 4. 4 into 4, 16. 16 plus 8 becomes equal to 24. This point satisfies. So I can tell that the point lies on the curve, correct? So we can differentiate it. Writing all the terms to one side, what I'm getting, 2x square plus 3xy plus 4y square minus 24 equal to 0. Correct? Want to find dy by dx. Dy by dx formula is minus fx by fy minus fx divided by fy. That is minus of fx means what? Differentiate this partially with respect to x. Derivative of 2x square is 4x. Derivative of 3xy, differentiating with respect to x, keeping y as constant. 3y is constant. 3y is constant. Derivative of x 1. Derivative of 4y square is 0 because 4y square is constant. Derivative of 24 is 0. Now fy, differentiate with respect to y partially, keeping x as constant. 3x is constant. Derivative of y is 1. 3x. Derivative of 4y square is 8y. Derivative of 24 is 0. Now substitute x equal to 1, y equal to 2. Dy by dx at x equal to 1, y is equal to 2. Put x equal to 1. 4 into 1, 4. 3 into 2, 6. Divided by 3 into 1, 3. Plus 8 into 2, 16. So what you get is minus 10 divided by 19. Option A is the answer. Very simple question. Hope you understand the method of finding dy by dx using the shortcut method minus fx by fy. Fx means differentiating f partially with respect to x. Fy means differentiating partially the given function with respect to y, keeping x as constant. Okay. Derivative of 2x square is 4x. Derivative of 3xy is 3y is constant. Derivative of x1, 3y into 1. 3y into 1 is 3y. Derivative of 4y square is 0 because 4y square is constant. 24 is constant, 0. And fy means differentiating the given function f with respect to y, partially keeping x as constant. So derivative of 2x square is 0. Here 3x is constant, derivative of y is 1, 3x I'm getting. Derivative of 4y square is 8y. Derivative of 24 is 0. Then put x equal to 1, y is equal to, get the answer. Hope you understand. Next one, based on the shortcuts. These are all very important shortcuts. This is already found in the NCERT examiner book. Just go through it. Already 2 questions have appeared in the PYQs. A power x plus a power y equal to a power x plus y. Dy by dx is minus a power y minus x. E power x plus e power y equal to e power x plus y. Dy by dx is minus e power y minus x. Have to remember these results. Very important. Look at this question. 2 power x plus 2 power y equal to 2 power x plus y. Dy by dx how much? Minus 2 power y minus x over. Question asked in the year 2020. Directly you can answer based on the shortcut. Okay. Minus a power y minus x. In place of a is given as 2. And one more question asked in the year 2000. 20 years gap. The question is asked. So 2 power x plus 2 power y equal to 2 power x plus y. Same question. But they asked to find derivative at x equal to y equal to 1. So what is the derivative for this equation? We know. Dy by dx equal to minus 2 power y minus x. Correct? They asked to find the derivative at x equal to 1, y equal to 1. So after differentiating, you put x equal to 1, y equal to 1. What we get? Minus 2 power 1 minus 1, which is minus 2 power 0, which is equal to minus 1. So answer is minus 1. Option D is the answer. Move on to the next one. More results are there on the implicit function. You can remember, have to remember this. Very important. X power m into y power n equal to x plus y power m plus n. Dy by dx is y by x. X power m y power n equal to a power m plus n. A is a constant there. Dy by dx is minus my by nx. X power m into y power n equal to x minus y power m plus n. In that case also dy by dx is y by x. And one more we have x power m into y power n equal to x square plus y square whole to the power m plus n by 2, then dy by dx is y by x. In 3 of the cases we got dy by dx equal to y by x. The first one is the most important one, okay, and the base is always positive and base is not equal to 1. That condition is given here. M and n are real numbers. And this question asked in the year 1991 and 2016. The first question itself is asked. Dy by dx is y by x. Option C. Sum of the powers of x and y is same as the power of x plus y. Dy by dx is y by x. Here also the question asked in the year 2019. Cube root of y. Cube root of y means it is y power 1 by 3. Square root of x means x power 1 by 2. Sixth root means raised to the power 1 by 6. Already there is x plus y to the power 5 to the power 1 by 6. So what we'll get is x plus y to the power 5 whole to the power 1 by 6. Correct? The powers gets multiplied there. X plus y to the power, how much you get? 5 by 6. And if you add the powers of x and y, we'll get the power of x plus y. Of course, if you add 1 by 3 plus 1 by 2, we'll take LCM of 3 and 2, that is 6. 3 2s are, 2 3s are, 3 plus 2, 5, 5 by 6. Sum of the powers of x and y is the power of x plus y. In that case, dy by dx is y by x. Option E is answer. So, important results on implicit function. Please learn all these results, memorize it. Next one, the interesting question. Already we have seen this question in the NCERT miscellaneous exercise. Cos y is equal to x into cos of a plus y. Dy by dx is cos square a plus y by sin a. Already we proved this. This easily I can tell you how to remember. The writing way I'll teach you. Okay. See, sin of a plus y is means actually we prove these problems by using the quotient rule, correct? So by using quotient rule, denominator square will be there, that will be shifted to numerator on cross multiplication after rewriting this as x as function of y. So whenever we got sin y is equal to x into sin of a plus y, the dy by dx answer is C. Sin, whatever they know, sin of a plus y or cos of a plus y. Okay, in these type of problems, dy by dx answer I'm telling you. Sin, suppose the given sin y is equal to x into sin of a plus y. How will you write dy by dx? Sin of a plus y is there, no? So write in the numerator sin square of a plus y. Sin square of a plus y divided by, what you should write in the denominator is both same function, no? Left hand side and right hand side, both the sides there is sine function only. So I'll write sin a. Sin square a plus y divided by sin a. Suppose it is cos y is equal to x into cos of a plus y. How to write dy by dx? Cos of a plus y is there, no? So square of that you should write. Whichever there is compound angle, that square you write. Compound angle is a plus y, correct? So dy by dx is equal to cos square of a plus y, square of the compound angle present, trigonometry function. That function you write, divided by same function, no? Left hand side and right hand side, both the sides cos function is there, but means same function. Same function means sine of a, sine of difference of these two, a plus y minus y, a. Hope you understand. Suppose they give cos y is equal to x into sine of a plus y. Cos y is equal to x into sine of a plus y. Because left hand side is cos function, no? Only in this case we get negative sign, okay? Dy by dx is minus. Sine of a plus y is there, no? Compound angle is for sine function. So take the square of that in the numerator, not in denominator, numerator. Minus sine square of a plus y divided by different functions are there on left hand side and right hand side. Left hand side cos function, right hand side sine function. So what you write in the denominator is cos a. Different function cos. Same function sine. Same function sine. Understood? Writing way you should learn. Suppose they give sin y is equal to x into cos of a plus y. Sin y is equal to x into cos of a plus y. What is dy by dx in this case? Which is the compound angle present a plus y. Which function cos? Take the square of that. Cos square of a plus y divided by different functions are there on left hand side and right hand side. Left hand side sine function, right hand side cos function. Different function means cos, same function means sine. So denominator is cos a over. Simple way of writing. So here cos y equal to x into cos of a plus y. Question asked in the year 2018. So dy by dx. Take the square of this cos square of a plus y divided by same function. So sine a over. Here sin y is equal to x into sine of a plus y. Dy by dx is sine square a plus y divided by same functions. So sine a. Same function means sine. Different function means cos over. Take the square of the compound angle function present. Compound angle is a plus y. For the which function sine? So sine square a plus y. Don't write in the denominator. Square should be present in the numerator in this case. Okay. Hope you understand the writing way for this. Only for left hand side cos y, right hand side sine function, there we get a negative sign. Rest all plus. Hope you understand how to write the dy by dx for these kind of equations. Next one is the most interesting one. Y equal to root of f of x plus root of f of x plus root of f of x up to infinity. up to infinity. dy by dx equal to f dash of x by 2I minus 1. Very important result. 3 times, 3 or 4 times the question have been asked. This question is repeated 2 times. Y equal to root of x plus root of x plus root of x plus up to infinity. What is dy by dx? You compare f of x is x. If you compare, what is your f of x? F of x x. So referring to this, dy by dx equal to f dash of x by 2I minus 1. No, my answer is for the function of this type. Y equal to root of f of x plus root of f of x up to infinity. What is my answer? Dy by dx is f dash of x by 2I minus 1. If we compare, my f of x is x. F of x is x. So f dash of x is 1, correct? F of x is equal to x. So f dash of x is equal to 1, correct? For the first one, I'm telling. So dy by dx is what? F dash of x is 1. 1 by 2y minus 1. 1 by 2y minus 1. Option D for this. And for this, already the given. Y equal root of sin x plus y. That is same as this. Both are same, correct? If you compare this with this, f of x is sin x. For the third one, f of x is sin x. Derivative of sin x is cos x. F dash of x. Derivative of sin x is cos x. So dy by dx is equal to what? Cos x divided by 2I minus 1 over f dash of x by 2I minus 1, correct? Dy by dx is f dash of x by 2I minus 1. So derivative of sin x is cos x by 2I minus 1 over. Even this question is same as the third one. If you want, you can do directly also by squaring on both sides. If you square this equation, what I'm going to get is y square is equal to sin of x plus y. Squaring on both sides, correct? Squaring on both sides, y square is equal to sin x plus y. Differentiate with respect to x. You'll get the answer. Differentiate with respect to x. Derivative of y square is 2y y dash. Derivative of sin x is cos x. Derivative of y is y dash. So y dash common. So what you get is 2y minus 1 is equal to cos x. So what do you get? Y dash is equal to cos x divided by 2y minus 1 over. Same answer. Cos x by 2y minus 1. For second one, option D. For third one, it is option C. Cos x by 2y minus 1. And for the first one, answer is option D. 1 by 2y minus 1. The proof of this also can be given. We can take this, neglecting this one root, the remaining terms, no, root of f of x plus root of f of x plus root of f of x up to infinity. This itself can be taken as y, and it takes the equation of this type. And you can do squaring on both sides and then differentiate, you'll get the answer. Remember this, quite important result. Many questions can be asked, many examples can be given of this type. I'll be doing a detailed synopsis of this. In that synopsis, I'll give the proof of all these things. Now I'm discussing only PYQs of this. Okay, move on to the next one. Some of the important shortcuts are given here. Function takes the form f of x plus y equal to 1. What is dy by dx? Minus 1. Okay. If you want, I can give the proof for this. F of x plus y equal to 1 means I can write x plus y is equal to f inverse. I think it should be k actually, not 1. K here, okay. F of x plus y equal to k. K is a constant. So x plus y equal to f inverse of k. 1 is also possible. X plus y equal to f inverse of k. F of x plus y is constant. Then x plus y is f inverse of k. Okay. F inverse of k is some constant. Is some constant. Differentiate with respect to x. Differentiate with respect to x on both sides. Derivative of x 1. Derivative of y is y dash. Derivative of constant is 0. So what you get is y dash is equal to minus 1. So dy by dx is minus 1. Same way you can prove the others. F of xy is constant means xy is equal to f inverse of k. F inverse of k is a constant, right? Given x into y is equal to f inverse of k. F inverse of k is a constant. So derivative constant will be 0. Differentiate with respect to x. What I'm going to get? To differentiate xy, we can apply product rule. X into y dash plus y into 1. Derivative of constant 0. So from this x into y dash is equal to minus y. So y dash is equal to what? Minus y by x. y dash equal to minus y of x. Similarly, others you can prove. X by y equal to f inverse of k. F inverse of k is a constant. So derivative constant will be 0. Apply quotient rule, get the answer. In both the case, dy by dx by x, even in the last case also, we can use component over and dividend. Property of ratio can be used there. And this question, sine of x plus y equal to cos of x plus y, want to find dy by dx. Question asked in the year 1993. What we can do is we can write this as sine of x plus y minus cos of x plus y equal to 0. Sine of x plus y minus cos of x plus y equal to 0. That means it takes f of x plus y equal to 0. F of x plus y is equal to constant. F of x plus y equal to constant means dy by dx is minus 1. So answer is option B. It takes the form f of x plus y equal to constant. So derivative of that function taking the form f of x plus y equal to constant is dy by dx equal to minus 1. Some questions are there. Direct differentiation. We'll take a break for 2 minutes. Water break. These are questions based on the direct differentiation. Here alpha is a constant, you must understand. Tan inverse of x square plus y square equal to alpha. Want to find dy by dx. So given equation could be written as x square plus y square is equal to tan alpha. Okay. Because alpha is a constant, tan alpha is also constant. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of x square is 2x. Derivative of y square is 2y y dash. And derivative of constant is 0. So from this we can write 2x equal to minus 2y y dash. 2 cancels. So we get y dash is equal to minus x by y. Y dash equal to minus x by y. Option B is the answer. On to the next one. Given like this. Secant inverse of 1 plus x by 1 minus y equal to find dy by dx. Because a is a constant, secant a is also constant. We can rewrite this as 1 plus x by 1 minus y is equal to secant a. A is a constant, so secant a is a constant. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. What do you get? Here you can apply quotient rule, denominator square. Denominator square. Denominator into, differentiate the numerator, d by dx of 1 plus x, that is 1, minus numerator into, differentiate the denominator, derivative of 1 minus y is minus y dash. Derivative of constant is 0. Correct? Now you can cross multiply this. 1 minus y the whole square into 0. This becomes 0. Correct? What we get? 1 minus y into 1. 1 minus y. Minus 1 into minus y dash becomes plus y dash. Minus into minus becomes plus x y dash. Numerator by denominator is 0 means numerator should be 0. I cross multiply it. Correct? Derivative of constant is 0. This is cross multiply. Don't ask where this term went. Or I can take numerator by denominator is 0 means numerator should be 0. So take y dash common from this. Y dash if you take common, what you get is 1 plus x. Between these two terms, y dash is common. These two terms shifted to RHS, we get y minus 1. So what do you get? Y dash is equal to y minus 1 divided by 1 plus x. Y minus 1 divided by x plus 1. That is option B. Applying quotient rule. Rewriting the equation as 1 plus x by 1 minus y equal to secant a. Differentiate on both sides with respect to x. Apply quotient rule. A is a constant, so secant a is a constant. Derivative of constant is 0. Here denominator square, denominator into derivative of numerator minus numerator into derivative of denominator. Minus into minus plus. 1 minus y into 1, that is here 1 into y dash, minus into minus plus x y dash, take y dash common, get the answer. Y minus 1 by 1 plus x or x plus 1, option B. On to the next one, simple one, question asked in the year 1992, given xy is equal to x plus y. Here what we can do is we can take x common between these two, or else we can take y common between these two. Any method I can do, but I'll take y common because I want to find dy by dx. No, I'll take y common between these two. Y common. If you take y common, what I'm going to get is x minus 1 is equal to x. Correct? So from this, y is equal to x by x minus 1. Y is equal to x by x minus 1. Take y common. Y into x minus 1. Y equal to x by x minus 1. Differentiate with respect to x. dy by dx. Denominator square. Apply quotient rule. Denominator square. Denominator into derivative of numerator. Derivative of x1 minus numerator into derivative of denominator 1. Correct? Derivative of x minus 1 is 1. So this will be what? X minus 1 minus x divided by x minus 1 the whole square. Plus x minus x will add up to 0. So what I am getting is minus 1 by x minus 1 the whole square. Option D is the answer. Hope you understand why I took y common, not x common, because I want to express y as a function of x. Then I can apply quotient rule, get the answer. On to the next one. Simple question is asked. Root x plus root y equal to 1. Want to find dy by dx at 1 by 4, 1 by 4. Question asked in the year 1993. Differentiate with respect to x. Given root x plus root y is equal to 1. Differentiate with respect to x on both sides. Derivative of root x 1 by 2 root x. Derivative of root y 1 by 2 root y into y dash. Derivative of 1, that is 0. Now substitute x equal to 1 by 4, y equal to 1 by 4. You'll get the answer. Or I can rewrite this as 1 by 2 root x is equal to minus 1 by 2 root y into y dash. 2 cancels. Y dash is equal to how much? From this, on cross multiplication you get minus root of y by x. Correct? Minus root y by root x or minus root of y by x. Therefore, dy by dx at 1 by 4, 1 by 4. Substitute x equal to 1 by 4, y is equal to 1 by 4. What I am going to get is minus root of 1 by 4 divided by 1 by 4. Which is equal to 1 by 4 cancels, root 1 is 1, so dy by dx is minus 1. Option C is the answer. Move on to the next one. Y square into 2a minus x equal to x cube. Want to find dy by dx at a comma a. Question asked in the year 1995. We shall differentiate this directly and substitute x equal to a, y equal to a. Given y square into 2a minus x. Correct? I shall apply product rule on the left hand side. Differentiate with respect to x. Differentiate with respect to x on both sides. Apply product rule. First function keep as it is. Differentiate the second function. Derivative of 2a 0. Derivative of x 1 plus second function into derivative of first function. Derivative of y square 2y y dash. 2y y dash. Derivative of x cube is 3x square. Correct? Applying product rule on the left hand side. First function keep as it is, differentiate the second function. Plus second function keep as it is, differentiate the first function. Now you have to put x equal to a, y equal to a. At a comma a means you have to put x equal to a, y equal to a. Minus 1 into y square, minus y square. So minus a square, putting y equal to a. 2a minus a, correct? 2a minus a into 2, putting y as a into y dash is equal to 3a square. So what I get here? 2a minus a is a into 2a, 2a square into y dash. 3a square plus a square becomes 4a square. A square cancels. 2 ones are 2, 2s are. So y dash is equal to 2. 2 ones are 2, 2s are. dy by dx is 2. Simple question. Just apply product rule and get the answer. Go on to the next one. Question asked in the year 2011. Cos inverse y by b equal to n into log of x by n. Want to form the differential equation where only first derivative is present, second derivative is not there. So need to differentiate only once. So differentiating with respect to x directly, what I am getting? Derivative cos inverse x. Derivative cos inverse x what? Minus 1 by root of 1 minus x square. So differentiate with respect to x. Differentiate with respect to x on both sides. Minus 1 by root of 1 minus y by b the whole square into derivative of y by b. Derivative of y by b is 1 by b into derivative of y, that is y dash. Constant into variable. N is a constant. Constant into variable. Constant keep as it is. Derivative of log is 1 by. Derivative of log x by n is 1 by x by n into derivative of x by n, that is 1 by n. Here n cancels. 1 by x by n becomes n by x. Correct? Here you take LCM b square. Then root of b square becomes b. Correct? So what I am going to get is minus 1 by, take LCM inside the root as b square LCM. So I am getting b square minus y square divided by b square into 1 by b into y dash is equal to 1 by x by n becomes n by x, and root of b square is b cancels. So what I get is minus y dash divided by root of b square minus y square is equal to n by x. Correct? Cross multiply it, you'll get x into y dash is equal to, minus to take that side, minus n into root of b square minus y square. So what I am getting from this? X into y dash plus n into root of b square minus y square equal to 0. X into y dash or y1, whatever the symbol can be used. So I use the symbol as y dash. In the options they use the symbol as y1. So answer is option B. X into y1 plus n into root of b square minus y square equal to 0. Hope you understand. Question asked in the year 2011. Next we got logarithmic differentiation. Whenever there is variable power variable, we take log on both sides, use the property of log and then differentiate to find dy by dx. The variable power variable, u power v, where u and v both are variables or functions of x I can tell. So you can remember this formula, derivative of u power v are given here. Derivative of u power v is equal to u power v into derivative of v log u. Correct? Can remember this as a result or a shortcut. Derivative of u power v is u power v into derivative of v log u. Quite useful. Okay? Please learn this formula. I'll be using this in working out the problem. Question asked in the year 2024, last year. 2 into x power 3x. Want to find dy by dx at x equal to 1. So we can apply that formula. So 2 is a constant. Keep as it is first. Y is equal to given 2 into x power 3x. Correct? So dy by dx is equal to, what I can write is 2 is constant. Keep as it is. I am differentiating x power 3x. It's a variable power variable. Variable power variables, or to differentiate derivative of u power v. Derivative of u power v is what? U power v into derivative of v log u. Write the same thing first. X power 3x into d by dx of 3x log x. 3x log x. Correct? Derivative of u power v. Derivative of u power v is u power v into derivative of v log u. D by dx of v log u. Derivative of u power v is u power v into derivative of v log u. Correct? Derivative of x power 3x is x power 3x into derivative of 3x log x. I need to differentiate by using this by product rule. Then put x equal to 1 and get the answer. This is 2 into x power 3x. Here 3x keep as it is. Derivative of log x is 1 by x plus log x into derivative of 3x is 3. Correct? Log x into derivative of 3x is 3. 3x into derivative of log x is 1 by x. Taking 3x as first function, log x as second function. X cancels. Now put x equal to 1. dy by dx at x equal to 1 we want to find out. At x equal to 1. So what do you get? 2 into 1 power 3. Here 3 into 1, 3. Here log 1 is 0. Correct? Log 1 into 3. Log 1 is 0. 0 into 3 is 0. 0 plus 3, 3. 2 into 3. Answer is 6. Option B. Learn this formula, quite useful. Derivative of u power v. U power v into derivative of v log u. Here also I'll be using the same formula. X power sin x plus sin x power x. Want to find the derivative at x equal to pi by 2. Question asked in the year 2022. So dy by dx. Directly I shall apply the formula. X power sin x into derivative of sin x log x. D by dx of v log u. Sin x into log x. For differentiating sin x power x, what you can do? Sin x power x into derivative of x log sin x. X log of sin x. Okay. Need to differentiate by using the product rule. X power sin x. Here apply product rule. Sin x into derivative of log x 1 by x. So sin x by x plus log x into derivative of sin x is cos x plus sin x power x into here x into derivative of log of sin x 1 by sin x into cos x. 1 by sin into cos by sin cot becomes cot x plus log of sin x into derivative of x is 1. Now put x equal to pi by 2. They asked to find dy by dx at x equal to pi by 2. Dy by dx at x equal to pi by 2. So put x equal to pi by 2. Pi by 2 to the power sin pi by 2 is 1. Sin pi by 2 is 1 divided by pi by 2 plus here cos pi by 2 is 0. 0 into log pi by 2 is 0. Correct? Sin pi by 2 is 1. 1 to the power pi by 2, that is 1 only. Cot pi by 2 is 0. 0 into pi by 2 is 0. Here sin pi by 2 is 1. Log 1 is 0. Correct? Note that sin pi by 2 is 1. Log 1 is 0. Cot pi by 2 is 0. Correct? Cot pi by 2 is equal to 0. Even there cos pi by 2 is 0. All these values are used. Putting x equal to pi by 2. Sin pi by 2 is 1. Log 1 is 0. This part is 0. Cot pi by 2 is 0. 0 plus 0 is 0. 0 into 1 0. Pi by 2 into 1 by pi by 2 is 1. So answer is 1. Option D. For constant a, you have to find d by dx of this. It's better to remember derivative of x power x. Derivative of x power x is x power x into 1 plus log x. Okay. So very standard. Remember it. Derivative of x power x is x power x into 1 plus log x. And derivative of x power a is like x power n only, because x is variable, a is a constant. Derivative of x power a is a into x power a minus 1. A into x power a minus 1. It is like x power n. And derivative of a power x we know. A power x into log a. And a power a is a constant. The 0. Derivative of a power a is 0. So answer is option B. X power x into 1 plus log x plus a into x power a minus 1 plus a power x log a. X power x derivative is so important. Please learn it. Derivative of x power x is x power x into 1 plus log x. Even in once common key exam, the question was asked to integrate x power x into 1 plus log x. Answer is x power x plus c. Because derivative of x power x is x power x into 1 plus log x. Integral of x power x into 1 plus log x will be x power x plus c. Because integration is the reverse process or the inverse process of differentiation. On to the next one. I already given here derivative of x power x, very important, please learn it. Already asked in CET exam once in 1992, derivative of x power x is x power x into 1 plus log x, option C. Also 1 could be written as log e, no? So see, x power x into 1 plus log x can also be simplified further. How to simplify this? X power x into 1 could be written as log e plus log x. What is log e plus log x? Log of xc. Log e, log of Log A plus log B is log of A. The sum of the log is log of the product. So it also can be written like this: x power x into log of xc or log of ex. Both one and the same. Please learn all those things. And this can be taken as a standard result, okay? Because already appeared 2 times this type of question. X power y equal to e power x minus y, dy by dx is log x by 1 plus log x the whole square. So better to learn that as a standard result. Or else you can take log on both sides and differentiate and get the answer in much lesser time. Doesn't take much time. Of course, you can use quotient rule there. Once or twice the question has been asked in the exams, you can take it as a standard result for further exams. Okay, so that's another thing to be noted. Derivative of x power x is what? Here x power x equal y power y is given. You differentiate on both sides. See, x power x equal to y power y. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. With respect to x, I'm differentiating. So what is derivative of x power x? X power x into 1 plus log x. Derivative of y power y is what? Derivative of y power y is y power y into 1 plus log y into y dash, because I'm differentiating with respect to x. Correct? Derivative of x power x is x power x into 1 plus log x. Likewise, derivative of y power y is y power y into 1 plus log y into y dash, because I'm differentiating y with respect to x. Already according to the question, they told x power x equal to y power y. No? So I can cancel this. X power x is same as y power y, cancels out. So what I'm getting? Y dash from this. Y dash is equal to what? Y dash is equal to 1 plus log x divided by 1 plus log y. 1 plus log x divided by 1 plus log y. Y dash is equal to 1 plus log x by 1 plus log y. Option C. Here there are 2 questions. Already told this as a to be taken as a standard result, can be taken as a standard result because already asked 2 times, once in the year 1992 and 2016. Once in 24 years the question has been asked. So with a 24 years gap, 2 times the questions have been asked already. So can be taken as a standard result. Given that x power y equal to e power x minus y, if you are doing it as an actual method, I can show the steps. But because there is variable power variable here, what we'll do is take log on both sides. Okay, x power y equal to e power x minus y. Given x power y equal to e power x minus y. Take log on both sides. Log of x power y is equal to log of e power x minus y. According to the property, no, log x power y means it becomes y log x. Power comes down. This is x minus y into log e. Power comes down. Correct? This is the property of log. And the value of log e is 1. Log e is 1. Log e means log e base e, which is 1. So x minus y into 1. That is x minus y here. X minus y. So what we get? Y log x plus y is equal to x. Rearrange the terms. Take y common from the left hand side. What do you get? Y into 1 plus log x is equal to x. So what is y? Y is x by 1 plus log x. I can express it as quotient of 2 functions. Y is equal to x divided by 1 plus log x. Now we find dy by dx using quotient rule. Dy by dx is equal to, use quotient rule, denominator square. Denominator square. Denominator into derivative of numerator, derivative of x 1 minus numerator into derivative of denominator, derivative of 1 plus log x is 1 by x. X cancels. So what do you get? 1 plus log x minus 1 divided by 1 plus log x the whole square. Plus 1 minus 1 cancels. So I am getting dy by dx as log x divided by 1 plus log x the whole square. Okay. Once you see that the question is asked for 2 times, it can be taken as a standard result. That's another thing to be noted always. So x power y equal to e power x minus y. Take log on both sides. Simplified. Express it as y as a quotient of two functions. We get y as log x by 1 plus y is equal to x by 1 plus log x. So that dy by dx is log x by 1 plus log x the whole square. Okay. And the question which is asked in the 2020, okay, this question is almost same as this. Answer is same, okay. It looks different, but both are same actually. By taking log on both sides and simplifying, after 2 or 3 steps, you realize that both the functions are same. If you want to show this part, take log on both sides, consider this equation, x e power y equal to e power x. If you take log on both sides, what do you get? Log of x e power y is equal to log of e power x. Correct? Taking log on both sides. The power comes down. Y log of xc, y log of xc is equal to x log e. And log e is 1. 1 into x becomes x. Here y into log of xc becomes what? Log x plus log e. Correct? And log e is 1. Log of the product is sum of the log. Log e is 1. So what I am getting, y into 1 plus log x equal to x. Same thing I got here. Correct? Same thing what I got here. Y into 1 plus log x equal to x. Then you can continue from here. Y is equal to x by 1 plus log x. Then apply quotient rule. So that answer is same. So both the questions are looks to be in a different form, but answer is same. After 2 or 3 steps, you realize that both the equations are equivalent. By taking log on both sides, it simplifies to y is equal to x by 1 plus log x. So it's an important question. Same type of question asked, but it looks different. Properties of logarithms. You must be knowing the properties is very important. Log of AB is log A plus log B. Log of xy, log x plus log y is called as product rule. Log of x by y, log x minus log y. Log x power y is y log x. Log x base y is log x by log y. It's called as change of base rule. And log x base y is 1 by log y base x. If you interchange the number and the base, no, it becomes reciprocal. And there's a formulas connecting the derivatives of exponential and logarithmic functions. Already we know all those things. Move on to the next question. Consider the following statements. Question asked in the year 2021. Y is equal to log x base 10 plus log x base z dy by dx. Whether you get that answer or not to check. Y is equal to log x base 10. Statement 1 I'm doing now. Y is equal to log x base 10 could be written as log x divided by log 10. Or directly you can differentiate also. Because derivative of log x base a formula we know 1 by x into log e base a. Correct? That's a formula. So if you are differentiating it directly using the formula dy by dx, why to use change of base rule? Directly we know the formula, correct? Derivative of log x base a d by dx of log x base a is equal to, which was given in the earlier slide, log x base a is equal to what? 1 by x into log e base a. Derivative of log x base is 1 by x into log e base a. Correct? So statement 1, I am differentiating that equation. Dy by dx is equal to derivative of log x base 10 is 1 by x into log e base 10 plus derivative of log x base e is 1 by x. So what is given is correct. Log e base 10 by x plus 1 by x. That is correct. Statement 1 is true. What about statement 2? Derivative of log x base 10 is log x by log 10, which is not true. Derivative of log x is log x by log. That is not true. That's a change of base rule they applied there. Change of base rule is applied, but it's not derivative. Derivative of log x base 10 can't be equal to log x by log 10. Statement 2 is false. Statement 1 is true. Statement 2 is false. Hope you understand. The statement 2 is absolutely false. Second and third question based on the property of log and the formula connected to derivative of log. Here I can use log a by b. This question asked 3 times. Once in the year 1987, 1994 and recently 10 years back in the year 2015. So log of a by b formula, log a minus log b I can use. Using the property of log a by b is log a minus log b, correct? So this becomes log of 1 minus x square minus log of 1 plus x square. Now differentiate this using the property. I simplified. Now at this stage I can differentiate. Log of the quotient is difference of the log. Dy by dx. Derivative of log x we know 1 by x. 1 by 1 minus x square into derivative of 1 minus x square, which is minus 2x. Derivative of log 1 plus x square. 1 by 1 plus x square into derivative of 1 plus x square, 2x. Take common denominator and simplify it. What we get? This is 1 minus x square into 1 plus x square. 1 minus x square into 1 plus x square. Taking common denominator. So what do you get? Minus 2x into 1 plus 2x square. Minus 2x into 1 plus x square minus 2x into 1 minus x square. What do we get? Therefore, minus 2x minus 2x cube minus 2x plus 2x cube divided by here. What do you get? A minus b into a plus b, a square minus b square. This will cancel. Minus 2x minus 2x minus 4x divided by 1 minus x power 4. Answer is option A. Simple question, just by using the property of log, simplified and then differentiate it. Next one, y equal log x. Find dy by dx. Question asked in the year 1996. So dy by dx equal to what from this? Dy by dx equal to derivative of log is 1 by x. So 1 by log x. 1 by log x into derivative of log, that is 1 by log x, into derivative of log x, that is 1 by x. So answer is 1 by x log x into log x. Option C is answer. Derivative of log of something is 1 by something. Further differentiate. Derivative of log is 1 by log x into derivative of log x, 1 by x. Option C is answer. Move on to the next one. Here there is one interesting result, actually shortcut. So f of x given in the form of log x to the base x power n. In that case, f dash of e is 1 by n. Okay, n should be a natural number, I think, not given any condition. Normally, n takes the values 2, 3, 4, etc. 1 also possible, I think. I'll give you the conditions later. In synopsis, I'll be doing in detail all these things. Now I'm just discussing the PYQs from 1984 to 2025. So not given completely. In complete synopsis, I'll be doing everything. Also, I'll give a proof of that. So you observe that n is 2 here if you compare these two equations. So f dash of x at x equal to 1 by 2e over. Okay. So learn this as a standard result. F of x equal log x to the base x power n. F dash of e is 1 by ne. Of course, we can prove independently also without using this result. If this question is asked like this, now we can use change of base rule and differentiate. I'll show the steps if you want. Using change of base rule. You know, change of base rule is what? Log x base y is log x divided by log y. Log x base y is what? Log x divided by log y. Correct? So using change of base rule, I can simplify this. Log of log x to the base x square will be log of log x divided by log x square. Divided by log x square. And this power comes down. This is by using change of base rule. How I got this step? By using change of base rule. Log x base y is log x divided by log y. Correct? The power comes down according to the power rule. Then we can use quotient rule and get the answer. Log of log x divided by 2 log x. So far I simplified it. Now I am differentiating it. F dash of x. Use quotient rule. Denominator square. 2 log x the whole square. 2 log x into derivative of log x 1 by log x into derivative of log x 1 by x minus log of log x into derivative of 2 log x is 2 into 1 by x. Here log x will cancel. 2 by x is common. 2 by x is common. So what remains is 1 minus log of log x divided by 2 square is 4 into log x the whole square. Now want to find derivative at x equal to e. So f dash of e. F dash of e is required. F dash of e is 2 by e into 1 minus log of log e, correct, divided by 4 into log e the whole square. Log e is 1, log 1 is 0, this part is gone. 1 minus 0 is 1, 1 into 2 by e is 2 by e, divided by 4 into log e is 1 square is 1. So what I am getting is 2 by 4e, that e comes down, that is equal to 1 by 2e. That is how I get this. 1 by 2 is answer. If you are doing the actual method, you should be very quick in applying the change of base rule and then quotient rule and then differentiating it. Okay, then putting x equal to e. Otherwise, remember this as a standard result. Log of log x to the base x power n, f dash of e is 1 by ne. Here log of log x to the base x square is given. That means power of x is 2 in the base. So 1 by 2e. Putting n as 2. Compare 1 by 2e is answer. That is what I got. If they give log of log x to the base x cube, f dash of e will be 1 by 3. Like that. If they give log of log x to the base x power 10, f dash of e will be 1 by 10e. On to the next one. This is the second type of whenever they give product and quotient of many functions, no, we can take log and use the properties of log and then differentiate. Becomes easy to find dy by dx. And this is extended product rule, which can be proved by using taking log on both sides. Derivative of product of three functions is that u, v, w. Take u, v as it is, keep the first and second function as it is, differentiate the third. Plus first and third keep as it is, differentiate the second. Plus second and third keep as it is, differentiate the first. Can be extended for even n functions. If they give product of n functions, we can take log and differentiate, because log of the product will be sum of the log, no? So differentiating sum is much easier than differentiating the product. So that's the advantage of taking log. There are some questions based on this. I can use the extended product rule here and differentiate, or else I can use log and differentiate. Any method will do. I'll use the extended product rule because there is product of three brackets here. I want to find derivative at x equal to 4. I'll use the extended product rule. Okay, extended product rule is helpful here. dy by dx equal to first and second function keep as it is, x minus 1 the whole square into x minus 2 the whole cube. First bracket and second bracket you keep as it is. Differentiate the third bracket. Derivative of x minus 3 power 5 is 5 into x minus 3 to the power 4 into derivative of x minus 3 1, plus first and third keep as it is, x minus 1 the whole square into x minus 3 power 5 into derivative of x minus 2 the whole cube is 3 into x minus 2 the whole square, plus second and third keep as it is, x minus 2 the whole cube into x minus 3 power 5 into derivative of x minus 1 the whole square is 2 times x minus 1. Hope you understand. Keeping two functions at a time fixed, differentiate the third one. Now put x equal to 4. dy by dx at x equal to 4 they ask. dy by dx at x equal to 4. Putting x equal to 4. 4 minus 1, 3 becomes 3 square. 4 minus 2, 2 cube into 5. Here 4 minus 3 is 1 power 4 1, plus 4 minus 1 3 square. Here 4 minus 3 is 1 power 5 into 3. 4 minus 2 is 2 square, plus 4 minus 2 is 2 cube. 4 minus 3 is 1 power 5 into 2 into 4 minus 1 3. Correct? 3 square is 9, 2 cube is 8 into 5, plus 3 square 9, 1 power 5 is 1 only, into 3, 2 square 4, plus 2 cube is 8, 1 power 5 is 1 into 2 into 3. Simplify this. 8 into 5, 40, 40 into 9, 360. 3 into 4, 12, 12 into 9, 108. 8 2s are 16, 16 3s are 48. 360 plus 108, 468 plus 48, 516 is the answer. Option D is the answer, 560. This is use of extended product rule. Whenever there is product of three functions, keep two functions at a time fixed, differentiate the third. First and second kept as it is, differentiate the third. Plus first and third keep as it is, differentiate the second. Plus second and third keep as it is, differentiate the first. Get the answer. Substitute x equal to 4, get the answer. Similar type of question asked in the year 2014. Here also there is product of three brackets. Want to find the derivative at x equal to 1. So here dy by dx equal to first bracket and second bracket keep as it is. First and second keep as it is. Differentiate the third one. Derivative of 1 is 0. Derivative of x power 4 is 4x cube. Plus first and third keep as it is. Differentiate the second. 1 plus x into 1 plus x power 4 into derivative of 1 plus x square is 2x. Plus 1 plus x square into 1 plus x power 4 into derivative of the first bracket. Derivative of 1 plus x is 1. Now put x equal to 1. dy by dx at x equal to 1 we want to find. Put x equal to 1. 1 plus 1 2. 1 plus 1 square 2. 4 into 1 cube 4. Plus 1 plus 1 2. 1 plus 1 power 4 2 only. 2 into 1 2. Plus 1 plus 1 2. 1 plus 1 2 into 1. So what we get answer? 4 into 4. This is 16. Here 2 into 2. 4 into 2 8. Here 2 into 2. 4 into 1 4. Answer is 28. Option B. Next one, the product of n functions are there here, n signed functions. Want to find y dash is given in terms of summation here. Question asked in the year 2011. Similar type of question can be asked as cos function. Instead of sine, we can take cos and give the question also. Okay. Here, because they expressed in terms of summation and they're not asking derivative at any particular point, because it's a product of n function, I'll definitely take log and differentiate. Okay. So taking log on both sides, what I get? Using properties, I can simplify and then differentiate. Log y is equal to log of sin x into sin 2x into sin 3x, etc. sin nx. Sin x, sin 2x, sin 3x, etc. sin nx. Like this I get. So I can use the property now. Log of the product is sum of the log. Log AB is log A plus log B, correct? So this becomes log of sin x plus log of sin 2x, log of sin 2x plus log of sin 3x lastly we got log of sin nx, correct? At this stage, I shall differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of log y is 1 by y into y dash. Correct? Derivative of log y, 1 by y into derivative of y is y dash. Derivative of log of sin x, 1 by sin x into derivative of sin x is cos x. Derivative of log of sin 2x, 1 by sin 2x into derivative of sin 2x, cos 2x into 2. Correct? Derivative of log of sin 3x, 1 by sin 3x into derivative of sin 3x, cos 3x into derivative of 3x is 3. Correct? Like this it goes on. Derivative of log of sin nx, 1 by sin nx into derivative of sin nx, cos nx into derivative of nx n. And you know, cos by sin is cot everywhere. So I cross multiply this. Y will cross multiply. Y in the denominator of LHS, send this to numerator of RHS. Y into, open a bracket, cos by sin is cot x. This is 2 times cot 2x. 2 you keep as it is. Cos by sin is cot. 2 times cot 2x. Plus this is 3 times cot 3x. Like this it goes on. Last term will be n into cot nx. N into cot nx. I can generalize this. Cot x means 1 cot 1x. Here 2 cot 2x, 3 cot 3x, n cot nx. I can express this in terms of summation, correct? So answer is y into summation k is equal to 1 to n k cot kx. K cot kx. Y into summation k equal to 1 to n k cot kx. Option B is the answer. Hope you understand. Converting converting the product to sum by using log. Log of the product is sum of the log. That becomes easy to differentiate using chain rule. Derivative log of sin x. 1 by sin x into derivative of sin x cos x. Derivative log of sin 2x. 1 by sin 2x into derivative of sin 2x cos 2x into 2. 2 cot 2x it becomes. Likewise, go on, continue and cross multiply this to left hand side denominator. Left hand side denominator is cross multiplied to numerator of RHS, and option B is the answer. Expressed in terms of summation. Questions are asked based on the characteristic features of the logarithmic and exponential function. Graph is also shown here, correct? Both log x and exponential function, for the base b to be greater than 1, they are strictly increasing function. Log x, it passes through the point 1, 0 because log 1 is 0, and exponential function, it passes through the point 0, 1. Okay, log x, base e and log e power x are drawn the graph. They are mirror images or the reflections about the line y is equal to x. Log x, it passes through the point 1, 0, and e power x passes through the point 0, 1 because e power 0 is 1. When you put x equal to 0, y is 1. And the graph of log function, it never touches the y-axis as x tends to minus infinity. As x tends to 0 plus, y tends to minus infinity. Correct? X is approaching to 0, close to 0, some positive value. I can tell as x is approaching to 0 plus means 0.000001, such a value. In that case, y is approaching to minus infinity. That is, the graph of log function never touches the y-axis, and graph of exponential function never touches the x-axis. As x tends to minus infinity, y tends to 0. For log function, for exponential function, as x tends to minus infinity, y tends to 0. That is 0 plus, slightly greater than 0 only. Okay. So exponential function, domain for exponential function is R. Here e power x or b power x, whatever they give, x can take all real numbers, positive values, negative values, zeros. So domain for exponential function is R, the set of real numbers. Whereas the range for the exponential function is only positive real numbers. Exponential function can't give answer as 0, can't give the answer as negative. So always positive. So range of the exponential function is positive real numbers, and the domain for logarithmic function is the positive real numbers, because log 0 is not defined, log negative number is not defined, log of only positive number is defined. So domain of log function is nothing but the range of the exponential function, and the range of the exponential function is the domain of the log function, and range of the log function is the domain of the exponential function. Range of log function is all real numbers. It can log x can be positive, log x can be 0, log x can be negative also. So range of the logarithmic function is the domain of the exponential function. Okay, so domain and range are interchanged for these two, and it passes, log function passes through the point 1, 0, exponential function always passes through the point 0, 1. Log function never touches the y-axis, exponential function never touches the x-axis. Both are strictly increasing function if the base is greater than 1, and both are going to be strictly decreasing function if the base lies between 0 and 1. Okay, are given for base b greater than 1, both are strictly increasing function. That's the nature of the function. Increasing function and decreasing function are going to study in detail in application of derivatives, correct? So the domain, range, and it never touches which axis, and nature, and it passes through the point. All those things are given here in this table. And also graphs of exponential and log function is shown here. Based on this also questions are asked in 2014 and 2024. Which one of the following is not correct for the features of exponential function b power x, where b is greater than 1? So they ask for exponential function, this is not correct. So first option, for very large negative values of x, the function is very close to 0. As I told, as x tends to minus infinity, as x tends to minus infinity, y tends to 0 plus. This is for exponential function, correct? That statement is true. The function is very close to 0. Domain of the function is R, the set of real numbers. For exponential function, I can give positive values, negative values, 0. So statement option B is also true. The point 1 comma 0 is always on the graph of the function. No, it is not true. The point which lies for exponential function is 0 comma 1 as given in the table. See, 0 comma 1 is a point on the exponential function. 1 comma 0 is not the point, correct? So option C is incorrect. The range of the function is set of all positive real numbers. That is true. Range of exponential function is all positive real numbers. So answer is option C, which is not correct for exponential function. That was in the year 2014, the question. And in the year 2024, they ask a question which is correct for logarithmic function for the base greater than 1. Base is greater than 1. The domain of log function is R, the set of real numbers. Domain of log function, which is correct, they are asking. Here it was not correct. Here they are asking which is correct. Domain of log function is R is false, because if you give x as negative value, log x is not defined. Even for x equal to 0, log 0 is not defined. So option A is not correct. Range of the logarithmic function is R plus. No, that is not correct. Range, I just now I told, log function can be positive, log function can be 0, log function can be negative also. So range is R plus, the set of all positive real numbers is not true. The point 1 comma 0 is always in the graph of the logarithmic function is true. Log x always passes through the point 1 comma 0 is true. So option C is correct. Graph of logarithmic function is decreasing as we move from left to right. That is false. It's an increasing function. For the base greater than 1, it's an increasing function. It's not decreasing function. So it is decreasing is false. So option C is correct. In both the questions, option C is correct. And as I told, log x and b power x are inverse functions of each other. And if two functions are inverse of each other, it satisfies this condition. B power log x base b is equal to x. And the base b is positive, base b is not equal to 1 for x greater than 0. And log b power x to the base b is x. Because log and exponential are inverse function, these conditions are satisfied. Base is positive and base is not equal to 1. Here x belongs to R, because domain of exponential function is all real numbers. Here domain of log function is only positive real numbers. So x should be positive. Here x can take any real number. So hope you understand. And also more generally, given e power log of f of x is f of x, for f of x to be positive. Okay. There are some questions, and here e power log of f of x is f of x. This question based on this property, as I told, e power log of f of x, f of x. Then we can use sum to infinity of geometric series here. E power log of something is something, because exponential log and inverse functions cancels out. I can simplify this as y is equal to 1 plus x square, etc. up to infinity. Correct? This forms sum to infinity of geometric series, which is a by 1 minus r. Sum to infinity of geometric series. What is the formula? S infinity. S infinity is equal to a by 1 minus r. A is the first term. Common ratio is x. So 1 by 1 minus x. Differentiate this. As you differentiate 1 by x, derivative of 1 by x is minus 1 by x square. So minus 1 by 1 minus x the whole square into derivative of 1 minus x is minus 1. Minus of minus plus. So we get 1 by 1 minus x the whole square, which is nothing but the square of this, correct? No, dy by dx is given in this form only. 1 by 1 minus x square, correct? So answer is option B. First simplify it. 1 by 1 minus x. Differentiate as a differentiate 1 by x. Derivative of 1 by x is minus 1 by x square. But this is not x. So for the differentiate 1 minus x minus 1. Minus of minus plus 1. So answer is 1 by 1 minus x the whole square. Parametric differentiation. X equal to f of t, y equal to g of t, where t is a parameter. In that case, we find dx by dt, dy by dt, then find dy by dx. dy by dx is defined as dy by dt by dx by dt for dx by dt not equal to 0. This method of finding dy by dx is called as parametric differentiation. And various parametric equations are given for different curves. We studied the equations of parabola, ellipse, hyperbola, circle, all those things. X equal to 80 square, y equal to 80 is the parametric equations for parabola. Slope of the tangent is dy by dx. Dy by dx 1 by t you will get. Okay, these are the parametric equations of circle. X equal to a cos theta, y equal to a sin theta. It satisfies x square plus y square equal to a square. And these are the parametric equations of ellipse. And this is for hyperbola, and this is for rectangular hyperbola or equilateral hyperbola we call. So different parametric equations are given for different curves, and the slope of the tangent nothing but dy by dx. Dy by dx is dy by dt by dx by dt, or you can use if theta is a parameter, then dy by d theta by dx by d theta can be used. It depends upon the parameter. In the first case the parameter is t. In the second, third and fourth parameter is theta. In the last case the parameter is t. Okay, depending upon the parameter we can find dy by dx as dy by dt by dx by dt, or dy by dx as dy by d theta by dx by d theta. And some of the important results I mentioned here from NCERT book, because many times questions are asked, no, we can remember and write the answer directly. This is very familiar results, all these things. X equal to a into theta plus sin theta, y equal to a into 1 minus cos theta, dy by dx is tan theta by 2. Of course, dy by d theta will be a into sin theta. Here dx by d theta is a into 1 plus cos theta. Then find dy by dx. Use half angle formula and get the answer. Next one is x equal to a into cos t plus log of tan t by 2. Y equal to a sin t. dy by dx is tan t. It's a very familiar question. For 3 marks, board exam level question, but it has to be remembered for CET, because we can't do all the steps in the CET exam like board exams. It will kill your time, correct? So we have to be very fast. So it's better to remember all these things as a standard result. X equal to a into cos theta plus theta sin theta, y equal to a into sin theta minus theta cos theta, dy by dx is tan theta. Even that is a very familiar one. Many times questions are asked. X equal to a cos cube theta, y equal to a sin cube theta, dy by dx is minus cube root of y by x, or minus tan theta. Both you can remember, okay, in the form of theta or in the form of y by x. And the 5-mark question, actually this is won't be asked for any board exams, but a very lengthy one. Actually you can see this question in the NCERT book exercise problem itself. In the parametric differentiation, x equal to sin cube t by root of cos 2t, y equal to cos cube t by root of cos 2t, dy by dx equal to minus cot 3t. They can ask this question. Say they ask to find dy by dx at t equal to pi by 4. Then directly you can remember this and put t equal to pi by 4 and get the answer. Using allied angles one can find the value. So it's better to remember this as a standard result. Okay. So I'll take the problems on parametric differentiation. Given x as a function of t, y also as a function of t. Want to find dy by dx at t equal to pi by 4. Question asked in year 2002. Find out dx by dt by parametric differentiation. Find out dx by dt. Derivative of 2 cos t is minus 2 sin t. Derivative of cos 2t is minus sin 2t into derivative of 2t is 2. So I'll write minus 2 sin 2t. Similarly, find dy by dt. Dy by dt is equal to constant into variable. Constant keep as it is. Derivative of sin t is cos t. Minus derivative of sin 2t is 2 times cos 2t. Want to find dy by dx at t equal to pi by 4. So dy by dx is defined as dy by dt by dx by dt, correct? So dy by dx. Dy by dx is equal to dy by dt divided by dx by dt. Substitute the value of dy by dt here. 2 cos t. 2 is common, correct? Cos t minus cos 2t. Dx by dt. You can take minus 2 common there, correct? Minus 2 common. What remains? Sin t plus sin 2t. 2 cancels. Substitute t equal to pi by 4. Correct? We want to find dy by dx at t equal to pi by 4. So now you can put the value of t equal to pi by 4 at this stage. Cos pi by 4 is 1 by root 2 minus 2 into pi by 4 is pi by 2. Cos pi by 2 is 0. Here minus of what I get? Sin pi by 4, that is 1 by root 2. 2 into pi by 4 pi by 2. Sin pi by 2 is 1. Correct? I can take LCM inside the bracket there, the denominator. Minus of LCM is root 2 here. Get 1 plus root 2 by root 2. Root 2 cancels. Minus 1 by 1 plus root 2. Correct? Therefore, I'll write the answer here. Therefore, dy by dx is equal to minus sign is there. Minus 1 divided by 1 plus root 2. Same as root 2 plus 1. Here I shall multiply and divide by root 2 minus 1. Denominator I can use the formula a plus b into a minus b, which is a square minus b square. Correct? So this becomes minus of root 2 minus 1 divided by a plus b into a minus b is a square minus b square. Root 2 square minus 1 square. Correct? That's equal to minus of root 2 minus 1, that is 1 minus root 2. Correct? Minus of root 2 minus 1 is multiply minus inside, minus into minus plus 1, 1 minus root 2. Denominator is root 2 square, 2 minus 1 is 1. So 1 minus root 2. Answer is option B. Simple question on parametric differentiation. Finding dx by dt, dy by dt, then find dy by dx. It's defined as dy by dt by dx by dt. Move on to the next one. X is given as e power theta sin theta, y equal to e power theta cos theta. Theta is a parameter. Want to find dy by dx at 1, 1. That means x is 1, y is 1. So find out dx by d theta first. Dx by d theta is equal to, here you can apply product rule. First function keep as it is. Derivative of sin theta is cos theta plus sin theta into derivative of e power theta is e power theta. With respect to theta I am differentiating. Correct? So dy by d theta, same way you can find out. Dy by d theta is equal to, first into derivative of second function. Derivative of cos theta is minus sin theta plus second function into derivative of e power theta is e power theta. With respect to theta I am differentiating. So that e power theta is common here. E power theta common. What remains is cos theta plus sin theta. Here e power theta is common. What remains is cos theta minus sin theta. Therefore, dy by dx is equal to dy by d theta by dx by d theta. Take the ratio dy by d theta by dx by d theta. Here e power theta will cancel. Correct? Cos theta minus sin theta by cos theta plus sin theta remains. E power theta will cancel out. So what remains is cos theta minus sin theta divided by cos theta plus sin theta. Want to find the derivative at 1, 1. That means x is 1, y is 1. Correct? X is 1, y is 1. If x is 1, I get 1 is equal to e power theta into sin theta. If y is 1, I'll get 1 is equal to e power theta into cos theta. Which value of theta satisfies? Here I can put theta equal to 0. Correct? E power 0 is 1, cos 0 is 1. Correct? If you put theta equal to 0, second equation is satisfied. What about the first equation? Sin 0 is 0. E power 0 is 1. 1 into 0 is 0. 0 equal to 1 is not possible. Correct? This equation is not possible. This is not possible for any value of theta. For all theta belongs to R. So the point what is given now is not correct. At 1, 1, no value of theta is possible for this. For this theta is equal to 0 is possible. But that theta equal to 0 does not satisfy this equation. So no value of theta is possible. Again, it's a wrong question asked. None of the option is going to match here. Okay. Dy by dx at 1 comma 1 is not possible to find. Anyway, I have done the method so that if they ask you to find dy by dx only, not at the point 1 comma 1, just if they ask you to find dy by dx, you can find out. Of course, I can divide both numerator and denominator by cos. If you divide numerator and denominator by cos, now I get 1 minus tan theta by 1 plus tan theta, which is tan of pi by 4 minus theta. Okay, 40 question where no option is going to match. We can't find derivative at 1 comma 1. No value of theta is going to satisfy both the equations. Move on to the next one. X equal to sin t into cos 2t, y equal to cos t into sin 2t. Want to find dy by dx at t equal to pi by 4. Question asked in the year 1988. So we can use the product rule here to find dx by dt. Even for finding dy by dt, we can apply the product rule and find the derivative. Very simple question, not a difficult one. Dx by dt I shall find out. Dx by dt is equal to, here I should apply the product rule. First function keep as it is. Differentiate derivative of cos 2t minus 2 sin 2t. Correct? Plus cos 2t into derivative of sin t is cos t. Dy by dt. Cos t into derivative of sin 2t is 2 times cos 2t plus sin 2t into derivative of cos t is minus sin t. Correct? First function keep as is. Differentiate the second function plus second function derivative of first function. Want to find dy by dx at t equal to pi by 4. Dy by dx. Dy by dt divided by dx by dt. Correct? Parametric differentiation. We know how to find the derivative using parametric differentiation. So write down this dy by dt value. Simultaneously we can put here t equal to pi by 4 and write. Correct? That we can do at t equal to pi by 4. I'll write like this. Putting the value of t equal to pi by 4. Write dy by dt by dx by dt. 2 into pi by 4 is pi by 2. Cos pi by 2 is 0. 0 into this becomes 0. Plus into minus is minus. 2 into pi by 4 pi by 2. Sin pi by 2 is 1. Here sin pi by 4 is 1 by root 2. Dy by dt is over. Dx by dt. 2 into pi by 4 is pi by 2. Sin pi by 2 is 1. Correct? This is 1 by root 2. Sin pi by 4. 1 by root 2. 1 by root 2 into minus 2 into sin of 2 into pi by 4 pi by 2. Sin pi by 2 is 1. Here cos pi by 2 is 0. Correct? Numerator is minus 1 by root 2. Denominator is minus 2 by root 2. Minus minus will cancel. Root 2 cancels. Answer is 1 by 2. Fourth option. Just use the product rule and get the answer. First into derivative of second. The second into derivative of first. Here also. First function keep as it is. Differentiate sin 2t. 2 into cos 2t. Plus sin 2t into derivative of cos t is minus sin t. Put t equal to pi by 4 and write. Simultaneously I am writing. Not substituting and then putting the value of t. Directly I will substitute. T equal to pi by 4. Cos pi by 2 is 0. This part is gone. This part is gone. Sin pi by 2 is 1. 1 into minus 1 by root 2. Here minus 2 into 1 by root 2. Correct? So dy by dt by dx by dt simplifies to half. Answer is option D. Move on to the next one. Question number 4. Here also x is given as product of two functions. Y also given as the product of two functions. Want to find the derivative at theta equal to pi by 4. Question asked in the year 1986. Find out dx by d theta. Dx by d theta is equal to, first function keep as it is. Derivative of sin 2 theta is 2 times cos 2 theta plus sin 2 theta into derivative of theta is 1. Dy by d theta is, dy by d theta is equal to theta into derivative of cos 2 theta is minus 2 sin 2 theta plus cos 2 theta into derivative of theta is 1. First into derivative of second plus second into derivative of first, correct? Applying product rule. Here also, first function keep as it is, derivative of cos 2 theta is minus 2 sin 2 theta plus cos 2 theta into derivative of theta is 1. Want to find derivative at theta equal to pi by 4. I'll substitute the value of theta equal to pi by 4 and simultaneously write the ratio dy by d theta by dx by d theta. When you put theta equal to pi by 4 here, 2 into pi by 4 is pi by 2, cos pi by 2 is 0, sin pi by 2 is 1. So I'll write minus 2, theta is pi by 4 into 2 into pi by 4, pi by 2, sin pi by 2 is 1. Here 2 into pi by 4, pi by 2, cos pi by 2 is 0. Divided by dx by d theta. This part will be 0 here. 2 into pi by 4, pi by 2, cos pi by 2 is 0. And 2 into pi by 4 is pi by 2, sin pi by 2 is 1. And 2 ones are 2 2s are cancels. So answer is minus pi by 2 divided by 1 minus pi by 2. Dy by d theta by dx by d theta. I substitute the value of theta equal to pi by 4 and then write. Okay. Minus pi by 2 is the answer. Fourth option. Move on to the next one. Again, x is given as function of theta, y is also function of theta. Want to find dy by dx at theta equal to pi by 2. Find out dx by d theta here. Dx by d theta is equal to, can apply product rule here. First into derivative of second plus second into derivative of first. Theta into derivative of cos is minus sin theta plus cos theta into derivative of theta is 1. Derivative of sin theta is cos theta. Coming to second part, dy by d theta is equal to derivative of cos theta is minus sin theta. Here can apply product rule for this. Open a bracket. First function keep as it is. Derivative of sin theta is cos theta plus second function into derivative of theta is 1. So what do you get? Minus sin theta minus theta cos theta minus into plus minus sin theta. Now write dy by dx and simultaneously put theta equal to pi by 2. Dy by dx at theta is equal to pi by 2 we want. At theta is equal to pi by 2. I am writing dy by d theta minus sin pi by 2. Sin pi by 2 is 1, so minus 1. Here cos pi by 2 is 0. Sin pi by 2 is 1, minus 1, minus 1, minus 2 it becomes. Dx by d theta, cos pi by 2 is 0, cos pi by 2 is 0. Here pi by 2 into minus sin pi by 2. Pi by 2 into minus sin pi by 2, which is minus 1. So numerator is minus 2, denominator is minus pi by 2. Minus minus will cancel, this 2 goes up, 2 gets multiplied to numerator, 2 into 2 becomes 4. 4 by pi is the answer. 4 by pi, option D. Next one, a simple question asked in the year 2015. X equal to a cos cube theta, y equal to a sin cube theta. It's a very standard question. You can remember the answer and write dy by dx is minus tan theta. Minus tan theta square is tan square theta. 1 plus tan square theta is secant square theta. Directly you can tell the answer. So a very familiar question from NCERT book itself, correct? Still I'll do it. The method dx by d theta is equal to constant into variable. Constant keep as it is. Derivative of cos cube theta is 3 cos square theta into derivative of cos theta is minus sin theta. Differentiate, as you differentiate x cube, derivative of x cube 3x square, 3 cos square theta into derivative of cos theta is minus sin theta. Dy by d theta is constant keep as it is. Derivative of sin cube theta is 3 sin square theta into derivative of sin theta is cos theta. Now we can find dy by dx. We will simplify to minus tan theta. Dy by d theta divided by dx by d theta. Dy by d theta is here 3a sin square theta cos theta divided by dx by d theta is minus 3a cos square theta into sin theta. 3a cancels, one sin will cancel, one cos will cancel, sin by cos tan, so minus tan theta. Want to find 1 plus dy by dx the whole square. Already I told the answer, but still I am doing the method properly so that for the sake of completeness, if anybody wants to understand, you can understand from this. Those are not understood. Minus tan theta the whole square is same as tan square theta, and 1 plus tan square theta is equal to secant square theta. Option C is the answer. Question asked in the year 2015. Simple one. Move on to the next one. Question number 7. It's the same question actually. Dy by dx equal to minus tan theta. This question is almost same as the previous one. Here also we got dy by dx equal to minus tan theta. Correct? So directly I'll write dy by dx, we got it as minus tan theta. From the previous question it follows. Even otherwise it's a very standard question. I told many times. I can find y by x ratio. Y by x is equal to what? Y is a sin cube theta. X is a cos cube theta. A cancels. We get tan cube theta. Dy by dx equal to tan cube theta. So if you take cube root on both sides, you get cube root of y by x. Raising to the power 1 by 3 is cube root, correct? So tan cube theta power 1 by 3 becomes tan theta. So here dy by dx is minus tan theta becomes minus. Tan theta is cube root of y by x. So answer is minus cube root of y by x. Option B. Question asked in the year 2010. On to the next one. Again, x is given as function of theta, y is function of theta. I want to find dy by dx. It's a very familiar board exam level question asked in the year 2003. dx by d theta is equal to constant into variable. Constant keep as it is. Derivative of theta with respect to theta is 1. Derivative of sin theta is cos theta. dy by d theta is equal to constant into variable. Constant keep as it is. To differentiate terms inside the bracket, derivative of 1 is 0. Derivative of minus cos theta is plus sin theta. Therefore, dy by dx is equal to dy by d theta divided by dx by d theta. Dy by d theta is a sin theta. Dx by d theta is a into 1 minus cos theta. A cancels. Can use half angle formulas. Sin theta is 2 sin theta by 2 cos theta by 2. 1 minus cos theta is 2 sin square theta by 2. 2 cancels. 1 sin will cancel. 1 sin remains. Cos by sin is cot. Cot theta by 2. Dy by dx is cot theta by 2. Option A. Next one. X is a cos theta, y equal to a sin theta. NCERT level question. All simple questions were asked earlier in the 1984. Still we shall complete this. Dx by d theta is equal to derivative of a cos theta is minus a sin theta. Dy by d theta is equal to a into derivative of sin theta is cos theta. Therefore, dy by dx. Dy by d theta divided by dx by d theta. Dy by d theta is a cos theta. Dx by d theta is minus a sin theta. A cancels. Cos by sin is cot. Minus cot theta. Simple question asked on parametric differentiation. Next one, x equal to e power cos t, y equal to e power sin t. Want to find dy by dx. Derivative of e power x, we know e power x. Further differentiate the power because it's not exactly x. Using parametric form, dx by dt equal to derivative of e power cos t is e power cos t into derivative of cos t minus sin t. Dy by dt is equal to derivative of e power sin t is e power sin t into derivative of sin t, that is cos t. Now find dy by dx. Dy by dx is equal to dy by dt divided by dx by dt. It is e power sin t into cos t divided by minus e power cos t into sin t. Cos by sin is cot minus cot t. Cos by sin simplifies to cot, correct? So minus cot t I shall write, and e power sin t by e power cos t we can write it as e power sin t minus cos t. Because bases are same, we can subtract the powers because of division, correct? Cos by sin is cot minus cot t into e power sin t minus cos t. Option A is the answer. Next one. This is also a simple question on parametric. Find dx by d theta. Theta is a parameter. Dx by d theta is equal to constant into variable. Constant keep as it is. Derivative of theta is 1. Derivative of sin theta is cos theta. Dy by d theta is equal to constant into variable. Constant keep as it is. Derivative of 1 0. Derivative of minus cos is plus sin. Want to find derivative at theta equal to pi by 2. Dy by dx at theta equal to pi by 2 they ask. So write the value of dy by d theta by dx by d theta at theta equal to pi by 2. A into sin pi by 2, correct? Putting theta equal to pi by 2 and writing the value. A into 1 minus cos pi by 2. A cancels. Sin pi by 2 is 1. Cos pi by 2 is 0. 1 by 1. Answer is 1. Option A. Move on to the next one. This is very standard question. Dy by dx equal to tan t is the answer. Option E. Very standard NCERT level question. I won't do this. Simple, very straightforward question from NCERT book itself. 3 marks standard question for final exam. Okay. Dx by dt, dy by dt will get the answer as tan t. It's better to remember these kind of questions. Anyway, no need to do this. Next one. X equal to a sin square t, y equal to a cos square t. Find dy by dx. Dx by dt equal to constant into variable. Constant keep as it is. Derivative of sin square t is 2 sin t into derivative of sin t is cos t. Dy by dt. Dy by dt is equal to a into derivative of cos square t is 2 cos t into derivative of cos t is minus sin t. Correct? By chain rule. Derivative of x bar is 2x. Derivative of cos square t, 2 cos t into derivative of cos t is minus sin t. Now take the ratio 1 by the other. Dy by dx equal to dy by dt divided by dx by dt. Dy by dt we got like this. 2a minus 2a cos t into sin t. Dx by dt is 2a sin t cos t. Sin t cos t cancels, 2a cancels, both are same. Answer is minus 1. Numerator same as denominator except the negative sign. So dy by dx is minus 1. Next one. Dy by dx at t equal to pi by 4. Here for this question we know dy by dx is minus tan t. Put t equal to pi by 4. Tan pi by 4 is 1 minus 1. Straightforward. No need to do again and again. Correct? X equal to a cos cube t, y equal to a sin cube t. For this, we'll get the answer dy by dx equal to minus tan t. We know. Put t equal to pi by 4. Dy by dx at t equal to pi by 4 they asked. This put t equal to pi by 4. We get minus tan pi by 4. Tan pi by 4 is 1. So answer is minus 1. Option A. Very simple question. Next one. Again, this question also is very familiar. Already we done this type of question. Dx by dt equal to constant into variable. Constant keep as the derivative of 1 is 0. Derivative of minus causes plus sin t. Dy by dt equal to a into derivative of t is 1. Derivative of sin t is cos t. Therefore, dy by dx at t equal to pi by 2 they ask. Put the value of t equal to pi by 2 and write a into 1 minus cos pi by 2. Correct? Dy by dt divided by dx by dt. A into sin pi by 2. A cancels. 1 minus cos pi by 2 0. Sin pi by 2 is 1. 1 by 1 is 1. Answer is option C. Move on to the next one. X equal to is missing here. X equal to dx by dt equal to how much? Constant into variable. Constant keep as it is. Derivative of cos cube t is 3 cos square t into derivative of cos t is minus sin t. Dy by dt equal to dy by dt is equal to constant into variable. Constant keep as it is. Derivative of sin cube t is 3 sin square t into derivative of sin t is cos t. Want to find dy by dx at t equal to pi by 4. Dy by dx at t equal to pi by 4. Correct? 2 into 3 is 6. I am writing the value of dy by dt by putting t equal to pi by 4. Sin pi by 4 is 1 by root 2. 1 by root 2 square. Cos pi by 4 is also 1 by root 2. Dy by dt I wrote. Now I am writing the value of dx by dt minus 6 into cos pi by 4 is 1 by root 2 square into sin pi by 4 is also 1 by root 2. 6 1 by root 2 cancels. 1 by root 2 square cancels. 6 cancels. Answer is minus 1. Option C. Move on to the next one. This is also a very standard question or the NCERT level question. We know the result for this. Dy by dx is tan theta. Already 2 times question is asked. 92 and 94. Next one. U is given and V is given. Want to find du by dv. So this U is nothing but sin inverse of 2x by 1 plus x square is 2 tan inverse x. Correct? By inverse trigonometric function formula. Tan inverse of 2x by 1 minus x square is also 2 tan inverse x. Du by dv they ask. So from these two I can conclude that u is equal to v. U is equal to v. Therefore du by dv is 1. Differentiate u with respect to v. Differentiate v with respect to v. Derivative of v with respect to v is 1. Answer is option C. Cos inverse 1 minus x square by 1 plus x square is nothing but 2 tan inverse x by inverse trigonometry function formula. And v is equal to tan inverse of 2x by 1 minus x square. That is also 2 tan inverse x. So from these two equations I can conclude that u is equal to v. So differentiate with respect to v on both sides. Differentiate with respect to v. So what do you get? Du by dv is equal to derivative of v with respect to v 1 over. Answer is option B. Next one. X is given as t square plus t plus 1. So find out dx by dt here. Dx by dt equal to, it's a polynomial function of degree 2. Differentiated. Derivative of t square is 2t. Derivative of t is 1. Derivative of 1 is 0. dy by dt. Dy by dt is derivative of sin is cos. Cos of pi by 2t into derivative of pi by 2t is pi by 2. Here derivative of cos is minus sin of pi by 2t into derivative of pi by 2t, that is pi by 2. Correct? Want to find the derivative at t equal to 1. dy by dx. Dy by dx at t equal to 1. dy by dx is dy by dt divided by dx by dt. Substitute the value and also simultaneously put the value of t as 1. Put t equal to 1 and write simultaneously. That will save your time. Correct? When you put t equal to 1 here, pi by 2 into 1 is pi by 2, cos pi by 2 is 0. Here, when you put t equal to 1, pi by 2 into 1 is pi by 2, sin pi by 2 is 1. So this is 1 into pi by 2. dy by dt I wrote. dx by dt, put t equal to 1 and write. What do you get? 2 into 1 plus 1. So numerator is minus pi by 2. Denominator is 3. So what we get is minus pi by 6. Option B. This 2 comes to denominator. 2 into 3 becomes 6. This I told many times to remember. Very standard question. Tan inverse of root 1 plus x square minus 1 by x is half tan inverse x. So S will simplify to half tan inverse x. And t is given as tan inverse of x. One can find ds by dt by relating s with t, half into what is tan inverse x from the second equation? T. Correct? S is half t. I want to find ds by dt. No, so differentiate with respect to t. Differentiate with respect to t. So I'll get ds by dt half into derivative of t with respect to t is 1. Half into 1, half. Oh, answer is option A. So very standard one. Remember it, don't forget. Tan inverse of root 1 plus x square minus 1 by x is half tan inverse x. S is half tan inverse x. T is tan inverse x. So S is half t. Because tan inverse of x is t. Substitute second equation in the first equation. Then differentiate with respect to t over. Otherwise, if you're not understanding this method, you differentiate with respect to x for s as well as for t. Differentiate both the equations with respect to x. Then find ds by dt as ds by dx by dt by dx. You'll get the answer. Same answer. Half only. Because derivative of this is half into 1 by 1 plus x square. This is derivative will be 1 by 1 plus x square. When you take the ratio of this by this, you will get half. 1 by 1 plus x square is going to cancel. Understood? Next one. X equal to ct, y equal to c by t. Find dy by dx at t equal to 2. Question asked in the 2015. So dx by dt find out. Dx by dt is equal to constant into variable. Constant keep as it is. Differentiate t 1. dy by dt. C by t means what? C by t means c into 1 by t. Constant into variable. Constant keep as it is. Differentiate the variable. Constant keep as it is. Derivative of 1 by t is minus 1 by t square. Therefore, dy by dx. dy by dx is equal to dy by dt divided by dx by dt. dy by dt we got minus c by t square. Dx by dt is c cancels. We get minus 1 by t square. Want to find at t equal to 2. Therefore, dy by dx at t is equal to 2 is minus 1 by 2 square, which is minus 1 by 4. Option A is the answer. This is so familiar, times already asked many times. Still I'll do it because the interchange the value of x is a cos cube t. Yeah, same question actually. Dy by dx will get dy by dt by dx by dt. Dy by dt is equal to how much? Here constant into variable. Constant keep as it is. This year question asked this year. 3 sin square t cos t. Correct? Differentiate as you differentiate x cube. 3x square. 3 sin square t into derivative of sin t is cos t. Dx by dt is equal to constant into variable. Constant keep as it is. Derivative of cos cube t is 3 cos square t into derivative of cos t is minus sin t. Derivative of x cube 3x square 3 cos square t into derivative of cos t is minus sin t. Therefore dy by dx equal to dy by dt by dx by dt. 3a sin square t into cos t dy by dt divided by dx by dt is here minus 3a cos square t into sin t Correct? 3a is going to cancel. One sine will cancel. One cos will cancel. Sine by cos is tan minus tan t. Want to find the derivative at t equal to 3 pi by 4. So dy by dx at t equal to 3 pi by 4. Substitute t equal to 3 pi by 4 minus tan of 3 pi by 4. Tan 3 pi by 4 is minus 1. Minus of minus 1 becomes plus 1. Tan 3 pi by 4 is calculated by using allied angles. 3 pi by 4 is 135 degree, correct? Tan 135 is tan of 180 minus 45 minus tan 45, which is minus 1. So answer is option C, which is minus of minus 1 plus 1. Elimination of parameter. This is type 2 in parametric differentiation. Sometimes it is possible to convert the parametric form to implicit form. Parametric form is x is function of t, y is function of t, correct? That t is a parameter, or they give in terms of parameter theta sometimes. It is possible to convert this parametric form to implicit form. It depends upon the given question and also it depends upon the given options. Sometimes the options will be set so that it will express in terms of x and y only. In that case, what we do is we convert the parametric form to implicit form. Implicit form means f of x comma y equal to 0. Function of both x and y where the parameter t is absent. We are eliminating the parameter by using algebraic identities like a plus b the whole square minus a minus b the whole square is 4ab, or like properties of inverse trigonometry functions, sin inverse x plus cos inverse x pi by 2, like that. Such kind of properties are useful. Or sometimes even trigonometric identities, secant square t minus tan square t is equal to 1, or using the properties of logarithms, correct? Log x base y into log y base x, if you multiply them it becomes 1. Such kind of things are useful so that you can convert the parametric form to implicit form and then differentiating it to get the answer in terms of x and y. Such kind of problems will work out now in this. This is appeared already. Say x is given as a into t minus 1 by t, y equal to a into t plus 1 by t. You want to find dy by dx. This kind of question is also present in NCERT exemplar book. Okay. So look at the options. All the options are given in terms of x and y. So what we'll do is we'll convert this parametric form to implicit form. So we know a plus b whole square minus a minus b whole square is 4ab. I'll be using this formula. A plus b the whole square minus a minus b the whole square is equal to how much? Is equal to 4ab. Correct? I want to use this. So I'll write y square minus x square from this. What is y square minus x square? Y square will be a square into t plus 1 by t the whole square minus x square will be a square into t minus 1 by t the whole square. Correct? A square is common now. A square is common. So what remains? T plus 1 by t the whole square minus t minus 1 by t the whole square. A plus b whole square minus a minus b whole square is 4ab, correct? This takes that form. A plus b whole square minus a minus b whole square. This is 4ab. If you simplify this, what I am going to get is 4 into t into 1 by t, which is t cancels 4. So 4a square. So right hand side is a constant, right? Because a square is constant, 4 is constant. Right hand side is constant, derivative of constant is 0. Differentiate this. I have converted the parametric form to implicit form. Differentiate with respect to x at this stage. On both sides, derivative of y square 2y y dash, derivative of x square 2x, derivative of constant is 0. So from this, what I am going to get 2y y dash is equal to 2x. 2 cancels, we get y dash is equal to x by y. Y dash is nothing but derivative of the function. Derivative is x by y over. Answer is option C. Next one, given mod t less than 1, sin x is 2t by 1 plus t square, tan y is equal to 2t by 1 minus t square. I want to find dy by dx. From this first equation, I can write x is equal to sin inverse of 2t by 1 plus t square. It's a familiar formula in inverse trigonometry function chapter. Sin inverse of 2t by 1 plus t square is 2 tan inverse of t. And I can write from the second equation as y is equal to tan inverse of 2t by 1 minus t square. Tan inverse of 2t by 1 minus t square is equal to what? 2 tan inverse of t. X and y both are same, right? X is 2 tan inverse t, y also 2 tan inverse t. From this I can conclude that x equal to y or y is equal to x. If y is equal to x, I can write dy by dx equal to 1. Differentiate with respect to x on both sides. Dy by dx is equal to 1. Answer is option D. Next one. Y is given as e power sin inverse of t square minus 1. X equal to e power secant inverse of 1 by t square minus 1. You should know the property of ITF actually here. Some properties are deleted from NCERT book, but still I insist the students to study those properties because here and there it's required. Okay, so don't neglect it. Properties of ITF, there are 12 properties actually. Sin inverse plus cos inverse pi by 2, tan inverse plus cot inverse equal to pi by 2, all those things. Secant inverse of 1 by x is cos inverse of x. I'll multiply the two equations because I can use the properties of ITF. If you multiply the two equations, x into y, x is e power secant inverse of 1 by t square minus 1. Secant inverse of 1 by t square minus 1 becomes cos inverse of t square minus 1. Correct? Secant inverse of 1 by x is cos inverse of x. Secant inverse of 1 by t square minus 1 written as cos inverse of t square minus 1. Y is what? E power sin inverse of t square minus 1. Sin inverse of t square minus 1. E power sin inverse. Bases are same, so that because of multiplication we can add the powers. This becomes e power cos inverse of t square minus 1 plus sin inverse of t square minus 1. Correct? Because the values are same, no? Cos inverse plus sin inverse becomes pi by 2. This simplifies to e power pi by 2. E power pi by 2 is a constant. This is a property of ITF. Cos inverse x plus sin inverse x equal to pi by 2. Means the terms inside the bracket is same, no? The values are same. Cos inverse plus sin inverse is pi by 2. Because t square minus 1 is found in both the brackets, the terms inside the bracket is same. Cos inverse plus sin inverse will add up to pi by 2. So e power pi by 2 is constant. We converted the parametric form to implicit form at this stage. Now differentiate with respect to x. To differentiate x into y, apply the product rule. X into y dash plus y into 1. And derivative of constant is 0. From this, y dash is equal to how much? Minus y by x. dy by dx is minus y by x. Answer is option D. Next one, differential coefficient of log x base 10 with respect to log 10 base x, how much? Question asked in the year 2016. Take the first function as u. Okay, take u is equal to log x base 10. Want to find the derivative of first function with respect to second function. We take the first function as u and second function as v. By change of base rule, we observe that these two are reciprocals. The first one is u is log x base 10 is log x divided by log 10. And v is log 10 base x, which is equal to log 10 divided by log x. We observe that u and v are reciprocals, right? If you multiply them, the product is going to be 1. We observe that u into v is equal to 1, or u is 1 by v. So you differentiate with respect to v on both sides. Differentiate with respect to v on both sides. What do you get? Du by dv. Du by dv is derivative of 1 by v is minus 1 by v square. Correct? Differentiate with respect to v. What is v? V is log 10 by log x. Therefore, du by dv is minus 1 by, what is v? Substitute back, log 10 by log x. Log 10 divided by log x the whole square. Minus you keep as it is. This goes up. Log x will go to numerator. So it becomes log x the whole square divided by log 10 the whole square. And the whole square is there for both, no? Numerator, denominator. I can write it as minus log x base 10 the whole square, which is nothing but option D. That's it, correct? That's the answer required. Minus log x base 10 the whole square. Log x by log 10 is log x base 10. Whole square is there, so I write whole square. Answer is option D. So, we are using the properties of logarithms. It is possible to differentiate by converting the parametric form to implicit form. Correct? We are relating u and v here. Next one, question number 5. X and y are given like this. Want to find dy by dx. Here also it is possible to convert the parametric form to implicit form by looking at the options. See, options are given in terms of x and y, correct? Question was x as a function of t and y as a function of t. So what we can do is, we can find out x square minus y square here. X square plus y square you can find out. X square plus y square is how much? X is 1 minus t square by 1 plus t square. Square of that. 1 minus t square, the whole square, divided by 1 plus t square, the whole square. X square plus y square. Y square is 2t, the whole square is 4t square. Divided by 1 plus t square, the whole square. So 1 plus t square, the whole square is common denominator. 1 plus t square, the whole square, common denominator. This is 1 minus t square, the whole square, plus 4t square. Correct? This takes the form a minus b whole square plus 4ab, which is a plus b whole square. If you are not familiar, I can expand it. Actually, I am using this formula. A minus b the whole square plus 4ab is equal to a plus b the whole square. Can you identify? A minus b whole square plus 4 into t square into 1. Correct? A minus b whole square. A is 1. A minus b the whole square plus 4 into 1 into t square. It's that 1 plus t square the whole square. Correct? Which is same as denominator. 1 plus t square the whole square divided by 1 plus t square the whole square. Numerator is same as denominator. So ratio is 1. This is x square plus y square. X square plus y square is equal to 1. Differentiate with respect to x. Differentiate with respect to x. Derivative of x square is 2x. Derivative of y square 2y y dash. Derivative of 1 0. So x plus y into y dash equal to 0. So y dash is equal to how much? Minus x by y. Correct? Y dash equal to minus x by y. Option D is the answer. So it's an equation of circle actually. These are the parametric equations for circle also I can tell. Because it satisfies the equation x square plus y square equal to 1. This is a unit circle having center at origin. Correct? I am converting the parametric form to implicit form and then finding dy by dx. So dy by dx is minus x by y. Option D is the answer. Move on to the next one. Here we are finding derivative of one function with respect to another function. Whenever they ask you to find the derivative of one function with respect to another function, take the first function as u, second function as v, find du by dx, dv by dx, then find du by dv. Du by dv is defined as du by dx by dv by dx. Okay? Such kind of questions are there. Work out those kind of questions in this. Here, want to find the derivative of cos inverse 2x square minus 1 with respect to cos inverse x. So take the first function as u. U equal to cos inverse of 2x square minus 1. V equal to cos inverse x. Take the first function as u, second function as v. Okay. We know that cos inverse of 2x square minus 1 is nothing but 2 cos inverse x by inverse trigonometric functions. And cos inverse of x is v. So u is equal to 2v. Using the second equation in the first equation, v is cos inverse x. So this becomes 2 into cos inverse x becomes 2v. Now I want to find derivative of u with respect to v. Derivative of the first function with respect to second function means du by dv. Correct? So differentiate with respect to v. Differentiate with respect to v. What I get? Du by dv. Du by dv is 2 into derivative of v with respect to v, that is 1. 2 into 1 is equal to 2. Option C. Next one. Derivative of tan inverse sin x by 1 plus cos x with respect to tan inverse of cos x by 1 plus sin x. Want to find the derivative of the one function with respect to another function. Take the first function as u, second function as v. Take that u is equal to tan inverse of. U is equal to tan inverse of sin x by 1 plus cos x. Sin x we know, half angle formula, 2 sin x by 2 cos x by 2. 1 plus cos x is 2 cos square x by 2. 2 sin x by 2 cos x by 2. This is 2 cos square x by 2. 2 cancels. 1 cos will cancel. Sin by cos tan. So it becomes tan inverse of tan x by 2. Directly I shall write tan inverse of tan x by 2. Tan inverse of tan x by 2 is x by 2, assuming that it lies in the principal branch. So du by dx is half. Du by dx. So differentiate with respect to x on both sides. Derivative of x by 2 is 1 by 2. Same way, take the second function as v. V is equal to tan inverse of cos x by 1 plus sin x. Already I told to remember, cos x by 1 plus sin x is tan of pi by 4 minus x by 2. Cos x by 1 minus sin x is tan of pi by 4 plus x by 2. Cos x by 1 plus sin x is tan of pi by 4 minus x by 2. All these things you have to remember, otherwise it takes more time in the exam to solve. So better to learn all these things. Your synopsis part should be very strong. Then only it's possible to crack that question in lesser time. Tan inverse of tan will cancel out, assuming that it lies in the principal branch. dv by dx. dv by dx. Derivative of pi by 4 is 0. Derivative of x by 2 is 1 by 2. So minus half. Therefore, want to find du by dv. Take the ratio of 1 by the other. Du by dv is equal to du by dx by dv by dx. Du by dx divided by dv by dx. Du by dx is half. dv by dx is minus half. So answer is minus 1. Option B. Question asked in the year 2011. Next one. Derivative of a power secant x with respect to a power tan x for a greater than 0. So take the first function as u. Let u is equal to a power secant x. V is equal to a power tan x. Find out du by dx from here. Du by dx. Use the formula derivative of a power x. What is derivative of a power x? A power x into log a, correct? A power secant x log a into derivative of secant x. Derivative of secant x is secant x tan x. Further you need to differentiate secant x. dv by dx. Derivative of a power tan x. A power tan x into log a into further derivative of tan x, which is secant square x. Next find du by dv after this. Du by dv is equal to du by dx divided by dv by dx. Du by dx is here a power secant x log a into secant x into tan x. dv by dx is here a power tan x into log a into derivative of, that is tan x secant square x. Already I wrote it. Log a cancels. 1 secant x will cancel. 1 secant x will remain. Correct? A power secant x by a power tan x. That will be a power secant x minus tan x. Tan by secant x. Tan is sin by cos. Sec is 1 by cos. So 1 cos will cancel. Sin x will remain. Tan by sec is sin. Because tan is sin by cos. Sec is 1 by cos. 1 by cos will cancel. Sin x remains. Sin x into a power secant x minus tan x. Option B. Next one. Derivative of cos inverse 1 minus x square by 1 plus x square with respect to cot inverse 1 minus 3x square by 3 minus x cube. Take the first function as u. U is equal to cos inverse of 1 minus x square divided by 1 plus x square. Cos inverse 1 minus x square by 1 plus x square is 2 tan inverse x. V is equal to cot inverse of 1 minus 3x square, cot inverse of 1 minus 3x square divided by 3x minus x cube. Cot inverse of x is tan inverse of 1 by x. So if you take reciprocal, cot inverse will become tan inverse. Tan inverse of reciprocal I should write. 3x minus x cube divided by 1 minus 3x square. We know that property. Cot inverse of x is tan inverse of 1 by x. So cot inverse of something is tan inverse of 1 by something. So I wrote the reciprocal. And tan inverse of 3x minus x cube by 1 minus 3x square is 3 tan inverse x. U and V we can relate, no? Or you differentiate directly from this. Du by dx. Du by dx is what? Constant into variable. Constant keep as it is. Derivative of tan inverse x 1 by 1 plus x square. Here dv by dx. dv by dx. Constant into variable. Constant keep as it is. Derivative of tan inverse x 1 by 1 plus x square. Now you can find du by dv. Answer is 2 by 3. Option D. Correct. Du by dv. Du by dv is equal to du by dx divided by dv by dx. Du by dx is here 2 divided by 1 plus x square. dv by dx 3 by 1 plus x square. 1 plus x square is going to cancel. Answer is 2 by 3. Option D. Move on to the next one. Want to find the derivative of sin inverse 2x by 1 plus x square with respect to sin inverse 1 minus x square by 1 plus x square. Take the first function as u. Let u is equal to sin inverse of 2x by 1 plus x square. We know by inverse trigonometric function formula, sin inverse of 2x by 1 plus x square is 2 tan inverse x. V is equal to sin inverse of 1 minus x square by 1 plus x square. I can write sin inverse of x as pi by 2 minus cos inverse of x. So this becomes pi by 2 minus cos inverse of 1 minus x square by 1 plus x square. Cos inverse 1 minus x square by 1 plus x square is 2 tan inverse x. So this will be pi by 2 minus 2 tan inverse x. Want to find du by dv. So find out du by dx from here. Du by dx is equal to what? Constant into variable. Constant keep as it is. Derivative of tan inverse x 1 by 1 plus x square. Here you find dv by dx. Pi by 2 constant. Derivative of constant is 0. 2 into derivative of tan inverse x 1 by 1 plus x square. Now find du by dv. The ratio will be minus 1. Du by dv is equal to du by dx divided by dv by dx. Du by dx is 2 by 1 plus x square. dv by dx is minus 2 by 1 plus x square. Will cancel. Answer is minus 1. Option C. On to the next one. The differential coefficient of e power x cube with respect to log x is how much? Take the first function as u, second function as v. Take u equal to e power x cube. V equal to log x. Find out du by dx. du by dx equal derivative of e power x cube. E power x cube into derivative of x cube 3x square. Here dv by dx. Derivative of log x is 1 by x. Now find du by dv. du by dv is equal to du by dx divided by dv by dx. du by dx is 3x square into e power x cube. dv by dx is 1 by x. This x will go up. So what you get is 3x cube into e power x cube. Correct? This x will go up, get multiplied. Answer is option C. On to the next one. Derivative of tan inverse root 1 plus x square minus 1 by x with respect to tan inverse x. This is a very familiar, already I told. Take this first function as u, second function as v. And the simplified form of this is half tan inverse x. Already there in NCERT book, exercise 2.1, 2.2, inverse trigonometry functions. By putting x equal tan theta, we simplified. This is half tan inverse x, the simplified form. U is equal to tan inverse of root of 1 plus x square minus 1 divided by x. Simplified form of this is half tan inverse x. Here v is tan inverse x. Take the second function as v. From these two equations I can write u is equal to half v. Correct? V is tan inverse x. So u is half v. Differentiate with respect to v. Du by dv. Du by dv is half into derivative of v with respect to v is 1. Half into 1 is half. Answer is option B. Derivative of sine of x cube with respect to cos of x cube. Take the first function as u, second function as v. Then find du by dx, dv by dx. Then find du by dv. Quite simple questions are asked. Let u equal to sine of x cube du by dx. Derivative of sine of x cube is cos of x cube into derivative of x cube 3x square. V equal to cos of x cube. Derivative of cos of x cube is minus sine of x cube into derivative of x cube 3x square. Derivative of cos is minus sine. Minus sine of x cube into derivative of x cube 3x square. Now find du by dv. Du by dv is equal to du by dx divided by dv by dx. Du by dx is here 3x square into cos of x cube. dv by dx is here minus 3x square into sine of x cube. 3x square is going to cancel. Minus cos by sine is cot. Minus cot of x cube. Just option C. Derivative of sin x with respect to log x. Question asked this year 2025. Take the first function as u. Let u equal to sin x. Very simple question. V equal to log x. Differentiate this. Du by dx. Derivative of sin x is cos x. dv by dx. Derivative of log x is 1 by x. Therefore, du by dv. du by dv is equal to du by dx divided by dv by dx. du by dx is cos x. dv by dx is 1 by x. This x will go up. Answer is x into cos x. Option A. Next we got second order derivatives. There are different types here: explicit function, implicit function, parametric form, and finally we discuss about the formation of differential equations. ಇದು ಕಾರ್ಡ್ ಸಾಕಾ? ಕಾರ್ಡ್ ಎರಡನೇದು ಇಟ್ಟಿದ್ದೀರಾ? ಎರಡು ತಗೊಳ್ತದೆ ಅದು ಒಟ್ಟಿಗೆ. Second order derivatives. The first one, y equal to f of x. Explicit form is given to you. How to find the second order derivative? First find the derivative of the given function and we get dy by dx equal to f dash of x. Again differentiate the first derivative, we're going to get the second order derivative. Okay, second order derivative is denoted by y2 or y double dash f double dash of x or d square y by dx square, all those things. Take the problems. Some simple questions are asked in the previous years. Y equal to 3 power x, the first one, dy by dx equal to derivative of 3 power x Derivative of 3 power x is 3 power x into log 3. Derivative of a power x formula, a power x into log a. Correct? Again differentiate this. D square y by dx square. D square y by dx square is equal to log 3 is constant, keep as it is. Derivative of 3 power x is 3 power x into log 3. So 3 power x into log 3 the whole square. 3 power x is nothing but y. 3 power x nothing but y. This is your y. So y into log 3 becomes log 3 the whole square. Second one, y equal to tan inverse of root of, what is 1 minus cos x by 1 plus cos, simplified. 1 minus cos x is 2 sin square x by 2. 1 plus cos x is 2 cos square x by 2. 2 cancels. Sin square by cos square is tan square. Root of tan square x by 2. This becomes tan inverse of root of tan square is strictly speaking mod of tan, but no conditions are given, correct? 2000 question asked in the year 1997. During that time we are not considering any much conditions at all. So blindly or simply we can accept that tan x is assume that tan x by 2 is positive. So root of tan square is tan l, right? Assuming that it is positive. Tan inverse of tan x by 2 is x by 2. So dy by dx is half. Correct? Derivative of x by 2 is 1 by 2. Again you differentiate this further. D square y by dx square, derivative of constant is going to be equal to 0. So answer is 0. Second order derivative is asked. D square y by dx square which is equal to 0. dy by dx is half. D square y by dx square is 0. Correct? Answer is option C. We assume that tan function is positive. So write root of tan square as tan. Tan inverse of tan x by 2 is x by 2. Assume that it lies in the principal branch. Third one, y equal to e power root of x into root of x into root of x up to infinity. Want to find d square y by dx square and x equal to log 3. I can simplify this as y equal to, because there are infinitely many square roots, first we will simplify this. E power, square root means what? Raised to the power half. So outermost square root I'll simplify it first. The outermost square root is to the power half, correct? X into root of x into root of x into dot whole to the power half. That is equal to e power. This becomes x power half. Now this root, no, raise it to the power half. Root means to the power half. This entire thing to the power half is there, correct? So x into root of x dot to the power half. This is raised to the power half further. This half is there. This root means it is raised to the power half power half. So this x not to the power half to the power half into half becomes 1 by 4. This will become e power x power half. Here x power half into half becomes 1 by 4. Likewise, this root is there, not to the power half is there. X power half becomes x power 1 by 8. X power 1 by 8. Like this it goes on. So this you can write it as e power x power. Here bases are same, no? So we can add the powers. So what we get is 1 by 2 plus 1 by 4 plus 1 by 8 plus etc. up to infinity. This forms sum to infinity of geometric series. S infinity formula. S infinity is a by 1 minus r, correct? The first term is half here. First term is half. Even common ratio is half. Common ratio is second term by first term. Simplifies to 1 by 4 by 1 by 2, which is 1 by 2. First term is half divided by 1 minus. Common ratio is half. Correct? Half divided by 1 minus half is half. Half by half is 1. So what you get is e power x power 1. Y is e power x. Y is e power x. So dy by dx is also e power x only. From this again differentiate. D square y by dx square is also e power x only. Derivative of e power x is e power x itself, correct? This part is simplified to 1. That is shown here using sum to infinity of geometric series. A by 1 minus r. A is the first term, half. Common ratio also half. Half by 1 minus half. Half by half equal to 1. So e power x power 1, that is e power x. dy by dx e power x. d square y by dx will also e power x only. And we need to find the second derivative at x equal to log 3. Therefore, d square y by dx square at x equal to log 3 I have to find out. At x equal to log 3 base e. That means you have to put x equal to log 3 base e. E power log 3 base e. Exponential and log will cancel out, becomes equal to 3. Answer is option B. E power log of f of x, f of x. Exponential and log are inverse functions. We know that e power log x is x. E power log f of x is f of x. E power log 3 is 3. Answer is option B. This gone simplified first. Simplifies to y equal to e power x using sum to infinity of geometric series and then differentiate. Question asked recently in the year 2022. Next one. This is a NCERT level question, straightforward. Log of log x. You can find this question in the NCERT exercise itself in the second order derivatives topic. Y equal to log of log x dy by dx. What is dy by dx? Derivative of log x is 1 by log x into derivative of log x is 1 by x. So what I am going to get is 1 by x log x. Correct? That is dy by dx. Derivative of log x is 1 by x. Derivative of log x is 1 by log x into derivative of log x 1 by x. So 1 by x log x. Want to find d square y by dx square. So again differentiate this. When you want to find the second order derivative, differentiate the first derivative. When you differentiate the first derivative, what we get the second derivative. Differentiate this as you differentiate 1 by x. Derivative of 1 by x is minus 1 by x square. So I'm going to get minus 1 by x log x the whole square into further differentiate x log x by using chain rule. Differentiate as you differentiate 1 by x. Derivative of 1 by x is minus 1 by x square. Minus 1 by x log x the whole square into derivative of x log x by using product rule x into derivative of log x 1 by x plus log x into derivative of x is 1. By using product rule differentiate this. Here x is going to cancel. What I am going to get is minus of 1 plus log x divided by x log x the whole square. So answer is option D. Minus of 1 plus log x divided by x log x the whole square. Next one, f of x given as b into e power x plus a into e power bx. Want to find f double dash of 0. Question asked in the year 2008. A and b are constants here, of course. F dash of x. Constant keep as it is. Derivative of e power x into a plus a into derivative of e power bx into b. Correct? So what I am going to get is a b e power x plus a b e power bx. Again differentiate f double dash of x. A b is constant, derivative of e power x into derivative of x a. Here a b into derivative of e power bx into b. So now put x equal to 0. F double dash of 0 we want. A b into e power a into 0 into a plus a b e power b into 0 into b. E power 0 is 1 into a is a. Correct? A b into a. Here a b into e power 0 is 1 into b is b. Correct? So a b is common. A b is common. So what remains is a plus b. A b into a plus b. Option C is the answer. Simple question on second order derivative. Double differentiate and put x equal to 0. Constant into variable. Constant keep as it is. Differentiate the variable. Derivative of e power x into derivative of x a. Derivative of e power bx into derivative of bx b. Next one. This is a question on binomial theorem, binomial coefficients, the expansion of binomial theorem actually. Nothing but the expansion of 1 plus x whole power n. Earlier I mentioned about this. I told that I am going to discuss on binomial in second order derivatives. Question asked 2 times already in the year 2009 and 2023. So f of x is nothing but 1 plus x whole power n. because N1 could be written as NC naught. Correct? N is NC1 into X. N into N minus 1 by 2 is NC2 into X square. N into N minus 1, N minus 2 by 6, NC3 into X cube, etc. Goes on. I can write X power N as NCN into X power N because NCN value is 1. This is nothing but the expansion of 1 plus X whole power N. We need to double differentiate and put X equal to 1. Correct? You have dash of X's. You have dash of X. Differentiate. As you differentiate X power N, derivative of X power N is N into X power N minus 1. Likewise, differentiate N into 1 plus X to the power N minus 1, derivative of 1 plus X1. You have double dash of X. You have double dash of X is N into derivative of 1 plus X power N minus 1 is N minus 1 into 1 plus X to the power N minus 2 into derivative of 1 plus X1. Now, at this stage, you can put X equal to 1. You have double dash of 1 is N into N minus 1 into 1 plus 1, 2 to the power N minus 2. So, answer is N into N minus 1, 2 power N minus 2, option C. Already asked 2 times in the year 2009 and 2023. Questions do repeat many times from earlier previous year questions. F, G and H are 3 functions given like this. H of X is equal to F of X into G of X. You have dash of X into G dash of X equal to C, where C is a constant. Want to find the value of this expression equal to how much? Question from 2010 CET paper, one of the most difficult question paper in the entire history of the CET exams, Karnataka CET exams. Okay, so H of X is given to be equal to F of X into G of X. You have dash of X into G dash of X is C. How to start the problem? That's the most important thing. When the question is difficult, if it is straightforward, we know how to start the problem, how to crack the problem, we know. If it's difficult, then how to start the problem is the most important question to be asked, correct? So, the right approach is required. For that, you should be exposed to a variety of questions, then only get the idea how to start the problem, okay? So, what we'll do is, I'll differentiate this H. H is given to be equal to F into G, right? So, from this, H dash will be equal to, by product rule, F into G dash plus G into F dash by using product rule. F into G dash plus G into F dash. Now, again, double differentiate this. H double dash. H double dash will be what? F into derivative of G dash is G double dash plus G dash into derivative of F is F dash. Applying product rule for this. Applying product rule for this. Coming to this part. G into F dash. Differentiate this. G into derivative of F dash is F double dash plus F dash into derivative of G is G dash. So what you get is F into G double dash plus, here we can add the like terms, G dash F dash plus F dash G dash, that becomes 2 times F dash G dash plus G into F double dash. Already is given in the question that F dash into G dash is a constant. So I can replace this by, use this equation. F dash into G dash is equal to C. So this becomes equal to F into G double dash plus 2C plus G into F double dash. Okay, keep it aside. I differentiate this equation 2 times and use this equation. Now I want to find the value of this expression. I'll take common denominator for this. What is required is F double dash divided by F plus G double dash divided by G plus 2C divided by F into G. Here we shall take common denominator F into G. F I have to multiply by G to get this. So that G I have to multiply to that F double dash. So F double dash into G. G I have to multiply by F to get this. That F into G double dash. So F into G double dash. F G I have to multiply by 1 to get this. That 1 into 2C is 2C. Correct? So from this I can see that F into G double dash plus G into F double dash plus 2C is nothing but H double dash. This numerator is from this equation H double dash. Correct? So H double dash divided by F into G. F into G is nothing but H from this equation. So answer is H double dash divided by H, option C. X is not written everywhere. H of x, f of x, why to write everywhere? It's understood that it's function of x. It's understood that it's a function of x. So no need to waste time. So I wrote directly. Instead of writing h of x, f of x, g of x, I wrote h, f, g directly and do it. It's understood that it's function of x. Answer is option C. A nice question asked in the year 2010. Next one. Y equal to tan inverse of root x square minus 1. Want to find the ratio d square y by dx square is to dy by dx. Because there is root of x square minus 1, we make a substitution x equal to secant theta and simplify the given function and differentiate once as well as twice. Put x equal to secant theta here. Put x is equal to secant theta. Y is equal to tan inverse of, what do you get, root of secant square theta minus 1. Put x equal to secant theta. Secant square minus 1 is tan square theta. This becomes tan inverse of secant square theta minus 1 is tan square theta. Secant square minus 1 is tan square theta. Root of tan square theta is tan theta. Tan inverse of tan theta is theta. Assume that tan square is positive here. Because there is root of x square minus 1, we put x equal to secant theta. Secant square minus 1, tan square theta. Root of tan square theta is tan theta, assuming that it is positive. Substitute back for theta from this. Theta is equal to secant inverse of x. Theta is secant inverse of x. So y is equal to secant inverse of x. Now I want to find dy by dx as well as d square y by dx square. Derivative of secant inverse of x we know. 1 by mod x into root of x square minus 1. But I'll assume that x is positive and right. During that time, we didn't have all those conditions and modulus and all. We are directly taking dy by dx of derivative secant inverse of x as 1 by x into root x square minus 1. I assume that x is greater than 1 and write that derivative of secant inverse of x as 1 by x into root of x square minus 1. Okay. Assuming that x is greater than 1, because secant inverse of x means x is either greater than or equal to 1, x is less than or equal to minus 1. X equal to 1 is not possible. Whenever you discuss the differentiability, you should take the open interval. So I can take x greater than 1 or x less than minus 1. At x equal to 1, it's not differentiable. Correct? Secant inverse of x, when you take x is greater than 1 or less than minus 1, I assume that x is greater than 1, so that x is positive, mod x is x. I wrote only x instead of writing mod x. So I can find the second derivative for this, d square y by dx square. To find the second derivative for this, you take this in the form of 1 by x. Derivative of 1 by x is minus 1 by x square. So d square y by dx square. Differentiate, as you differentiate 1 by x. Derivative of 1 by x is minus 1 by x square. Minus 1 by, what again, x square into root of x square minus 1 square will be x square minus 1 into, further differentiate terms, that is further differentiate this denominator, apply product rule to differentiate that, x into derivative of root is 1 by 2 root, 1 by 2 root of x square minus 1 into derivative of x square minus 1 2x plus second function root of x square minus 1 into derivative of x is 1. Correct? This 2 is going to cancel. So what we get is minus 1 by x square into x square minus 1. Here 2 has been cancelled. Correct? 1 x into x becomes x square by root of x square minus 1 plus root of x square minus 1. Correct? Take common denominator. What we get? Minus 1 by x square into x square minus 1. Here root of x square minus 1 is common denominator. So x square into 1 x square. Root x square minus 1 into root x square minus 1 is x square minus 1. Correct? So now take the ratio between these two. If you want, you can simplify this. Minus I can multiply inside. So minus 1 into minus 1 becomes plus 1. X square add up to 2x square, so we get minus 2x square, correct, divided by x square into x square minus 1 into root of x square minus 1. Now take the ratio d square y by dx square is to dy by dx. d square y by dx square by dy by dx. If you find the ratio of this, what I'm going to get? 1 minus 2x square divided by x square into x square minus 1 into root of x square minus 1 divided by 1 by x into root of x square minus 1. 1x will cancel here. Root x square minus 1 will cancel. So what is left is 1 minus 2x square by x into x square minus 1. Option D is the answer. Correct? Root x square minus 1 got cancelled. 1x got cancelled. 1x remains there. 1 minus 2x square by x into x square minus 1. Option D. Question asked in the year 2010. Whenever there is root of x square minus 1, we put x equal to secant theta. And first simplify it and then double differentiate. And take the ratio between the second order derivative and the first order derivative as asked in the question. Move on to the next one. F of x is a function such that f double dash plus f equal to 0. G of x is given as f of x square plus f dash of x square. G of 3 is 8. Want to find g of 8 equal to how much? Question asked 2 times already in the year 2006 and 2013. So we should simplify this equation. We should differentiate this equation and use that condition. F double dash plus f equal to 0. Okay. Differentiating this equation because g of 3 is given to be equal to 8 and asking to find g of 8. Various options are given like this. So we should differentiate this equation and use this condition. G dash of x is what? G dash of x is equal to, what is derivative of f of x is square? 2f of x into derivative of f of x, f dash of x. 2f of x into derivative of f of x, f dash of x. Derivative of f dash of x square is 2 times f dash of x into derivative of f dash of x, f double dash of x. Correct? Derivative of x square is 2x. 2f of x into derivative of f of x, f dash of x. Derivative of f dash of x square is 2 times f dash of x into derivative of f dash of x, f double dash of x. What is common here? You can see that 2 into f dash of x is common. So what remains inside the bracket is f of x plus f double dash of x. See that f of x plus f double dash of x is given to be equal to 0. This is given to be equal to 0. So 0 into this becomes equal to 0. So derivative is 0 means what? The function should be constant, right? Derivative is 0 means that function should be constant. Since g dash of x is equal to 0, what I can write is g of x is equal to constant. G of x is constant. That means already the given g of 3 is 8. G of 3 is 8 means g of 8 also should be 8 only, right? So answer is option D. Since g of 3 is given to be equal to 8, implies g of 8 is also equal to 8. G of any value is 8 because the function itself is constant. Because when you put x equal to 3, I got the constant as 8. So the function, any value assigned for x value, the function is constant and constant is found to be 8. So g of 8 is 8. Okay. In other words, we got the constant value as 8. We are using the condition that g of 3 equal to 8. G of 8 is also 8. Okay. So answer is option D. Move on to the next one. Y equal to tan inverse of log e by x square divided by log of e into x square plus tan inverse of 3 plus 2 log x by 1 minus 6 log x. Want to find d square y by dx square. Simplify this using the properties of log a by b, log a minus log b, log a b, log a plus log b. Go on, simplify it. Y equal to tan inverse of log of e by x square. I can write this as log e minus log x square. Log of e x square. Log of e x square is log e plus log x square. Log of a by b. Log a minus log b. Log of a b. Log a plus log b. Correct? And the value of log e is 1. You must know that. Here I can write this as 3 plus 2 log x divided by 1 minus 6. I can write 3 into 2. correct? 3 into 2, 6. This takes the form tan inverse of x plus y by 1 minus xy, where x is 3 and y is 2 log x. X plus y divided by 1 minus xy. What is x? 3. What is y? 2 log x. Here the value of log e is 1. This becomes tan inverse of the value of log e is 1. Where log x square is 2 log x. Log e is 1. Log x square is 2 log x. Correct, using property. 2 log x is 2 log x into 1 I can write. This takes the form tan inverse of x minus y divided by 1 plus xy, where x is 1 and y is 2 log x. Correct? This is x. X minus y divided by 1 plus x into y. Correct? X means 1, y means 2 log x. So what is tan inverse of x minus y by 1 plus xy? Tan inverse x minus tan inverse y. This will be tan inverse of 1 minus tan inverse of 2 log x. Here I can write this as x plus y divided by 1 minus xy, which is tan inverse x plus tan inverse y. This is simplified to tan inverse 3 plus tan inverse of 2 log x. Correct? This is tan inverse 3 plus tan inverse of 2 log x. Tan inverse of 2 log x will cancel out. They are of opposite sign. Tan inverse 3 plus tan inverse 1, this is constant. dy by dx is 0, correct? So far we are not differentiated. At this stage I am differentiating. So far I simplified it. dy by dx is 0 because the given function becomes constant. If dy by dx is 0, d square y by dx square is also 0. So answer is 0, option A. 11th one, question asked in the year 2013. F of x given as f dash of x plus f double dash of x plus f triple dash of x, etc. up to infinity. F of 0 is 1. Want to find f of x. All the options are given in terms of exponential. So what we can do is f of x is given to be f dash of x plus f double dash plus f triple dash, etc. What I'll do is, because the given function every options are in terms of e power x, we'll take f of x as e power kx, and e power 0 is 1 is satisfied for all the options, correct? E power 0 is 1. Every option satisfies this condition, f of 0 equal to 1. So we are not aware of the function exactly. We know it takes the form e power kx. Let f of x be equal to e power kx, where k is some real number. Okay. So now use this condition. What is f dash of x? Let f of x be equal to this form. By using options I can tell. F dash of x, derivative of e power kx, k into e power kx. What is f double dash of x? F double dash of x is k into derivative of e power kx, e power kx into derivative of kx, k. So k into k becomes k square into e power kx. Likewise we continue. F triple dash of x, k square into derivative of e power kx into k. So I'll get k square into k becomes k cube into e power kx. Like this it goes on. So the given function, what do you have here? F of x is equal to f dash of x plus f double dash of x plus f triple dash of x. Like this it goes on up to the infinity. Correct? I want to find the value of k. That is my aim. I'll substitute f of x as e power kx on left hand side. Right hand side, f dash of x, k into e power kx. F double dash is k square into e power kx. Correct? F triple dash, k cube into e power kx, etc. up to infinity. Now we can take e power kx common. Correct? Even k into e power kx is common. Correct? K into e power k is common. So what remains? 1 plus k square, etc. up to infinity. E power kx will cancel. So 1 is equal to k into, this forms sum to infinity of geometric series a by 1 minus r. That formula I'll use. Okay. First term is 1 and divided by 1 minus common ratio is k. Correct? Applying sum to infinity of geometric series. Sum to infinity of geometric series is a by 1 minus r. A is 1, divided by 1 minus common ratio is k. Cross multiply. So what I get? 1 minus k is equal to k, or I get 1 is equal to 2k. This implies k is equal to 1 by 2. K is equal to 1 by 2. That means my function f of x is e power kx I took. No, k is half. It's e power half x. Therefore, my function f of x becomes equal to what? E power half x, or e power x by 2, which is option A. Half x is same as x by 2. E power x by 2. Option A is the answer. Move on to the next one. Y equal to sine square x. Want to find d square y by dx square. Question asked in the year 1985. Simple question. Differentiate as a differentiate x square. Derivative of x square is 2x. This becomes 2 sine x into derivative of sine x, which is cos x. This is sine 2x. 2 sine x cos x is sine 2x. Again differentiate. D square y by dx square. Derivative of sine 2x is cos 2x into 2. That is 2 times cos 2x. Option C. Next one, y equal to cube root of x. Want to find d square y by dx square. Cube root of x means it is x power 1 by 3. Differentiate dy by dx. Derivative of x power n formula. N into x power n minus 1. Correct? N into x power n minus 1. This is 1 by 3 into x power 1 by 3 minus 1 is minus 2 by 3. Again differentiate d square y by dx square. D square y by dx square is constant into wave, constant keep as differentiate x power minus 2 by 3. What do you get? Minus 2 by 3 into x power minus 2 by 3 minus 1. That is equal to minus 2 by 9 x power minus 2 by 3 minus 1 minus 5 by 3. Or I can write this as minus 2 by 9 minus 2 by 9 into x power 5 by 3. Correct? X power 5 by 3 is, I can write this x power 1 by 3 power 5, or x power 5 power 1 by 3. Correct? Minus 2 by 9, I can write x power 5 by 3 as x power 5 power 1 by 3 we can write. So that becomes cube root. You can write this as x power 5 to the power 1 by 3, which is minus 2 by 9. Cube root means 1 by power 1 by 3 means cube root, correct? So cube root of x power 5. So answer is option A, minus 2 by 9 cube root of x power 5. Move on to the next one. This is the infinite series expansion for e power minus x. Already explained the infinite series expansion using Maclaurin series. I given the list of formulae. Correct? So this is nothing but alternate plus minus is there. This is the series expansion for e power minus x. Want to find the second order derivative. Dy by dx equal to derivative of e power minus x. E power minus x into minus 1. Correct? Again differentiate. D square y by dx square is equal to minus you keep as it is. Derivative of e power minus x. E power minus x into minus 1. Minus of minus plus e power minus x. What is e power minus x? Nothing but y. So d square y by dx square is equal to y. Option C is the answer. Y equal to 2 power x. This is a very simple question. D square y by dx square is asked. That is 2 power x log 2. That is first derivative. We'll get the answer as y into log 2 the whole square. Correct? dy by dx. Derivative of 2 power x is 2 power x into log 2. Again differentiate. D square y by dx square. Derivative of 2 power x log 2. Log 2 is constant. Keep as it is. Derivative of 2 power x is 2 power x log 2. Correct? So what you get is 2 power x into log 2 is log 2 the whole square. So 2 power x is nothing but y. So answer is y into log 2 the whole square. 16th one. X is given like this, e power t into cos 2t. You want to find the second order derivative at t equal to pi by 2. Apply product rule and differentiate 2 times. D square x by dt square is asked. So dx by dt I'll find first. Applying product rule. First function keep as it is. Derivative of cos 2t is minus 2 sin 2t. Correct? Plus second function cos 2t into derivative of e power t is e power t. First into derivative of second plus second into derivative of first. Now again differentiate this. D square x by dt square we want. Second order derivative. Minus 2 keep outside the bracket. Here differentiate by using the product rule. E power t into derivative of sin 2t is 2 times cos 2t plus sin 2t into derivative of e power t is e power t. First into derivative of second plus second into derivative of first. Here also apply the product rule. E power t into derivative of sin 2t is minus derivative of cos 2t is minus 2 sin 2t plus e power t, derivative of e power t is e power t into cos 2t. Applying product rule for this also, correct? First function keep as it is. Derivative of cos 2t is minus 2 sin 2t plus cos 2t into derivative of e power t is e power t. We can add the like terms. Otherwise directly you can put the value of t equal to pi by 2. When you put t equal to pi by 2, 2 into pi by 2 is pi, sin pi is 0. Sin term will vanish, becomes 0. Because when you put t equal to pi by 2, 2 into pi by 2 is pi, sin pi is 0. Here also this part becomes 0, correct? So d square x by dt square, d square x by dt square, when you put t equal to pi by 2, what I am going to get is minus 2 into 2, minus 4 e power pi by 2. Here 2 into pi by 2 pi, cos pi is minus 1, sin pi becomes 0, sin pi becomes 0. Here I am going to get e power pi by 2 into 2 into pi by 2 is pi, cos pi is minus 1. Correct? This becomes 4 e power pi by 2 minus e power pi by 2, which is equal to 3 into e power pi by 2. Option B. Hope it's clear. Just go on differentiate by using the product rule and get the answer. Even the next question also, same type of question is asked in the year 1988. Differentiate 2 times, apply the product rule and get the answer. Dx by dt first function keep as it is. Derivative of cos 3t is minus 3 sin 3t plus cos 3t into derivative of e power 2t is e power 2t into 2. Correct? First into derivative of second plus second into derivative of first. Now again differentiate. D square x by dt square is equal to minus 3 constant, keep outside. Apply product rule to differentiate this. E power 2t into derivative of sin 3t is 3 times cos 3t plus sin 3t into derivative of e power 2t, e power 2t into 2. Minus 3 keep outside. First into derivative of second plus second into derivative of first. Come into this. 2 you keep outside, constant. Here apply product rule. Cos 3t into derivative of e power 2t is e power 2t into 2 plus e power 2t into derivative of cos 3t minus 3 sin 3t. Now we can put t equal to pi by 2. Cos 3 pi by 2 is 0, sin 3 pi by 2 is minus 1. Note down the values if you don't know. Cos 3 pi by 2, cos of odd multiple pi by 2 is 0. Sin 3 pi by 2 simplifies to minus 1. Sin pi by 2 is 1. Sin 3 pi by 2 is minus 1. When you put t equal to pi by 2, d square x by dt square at t equal to pi by 2. Here cos 3 pi by 2 is going to vanish. Sin 3 pi by 2 is minus 1. Correct? Minus 3 into minus 1 becomes plus 3. Plus 3 into 2, 6. 6 e power 2 into pi by 2 is pi. Here cos 3 pi by 2 going to become 0. Sin 3 pi by 2 is minus 1. Minus 3 into minus 1 plus 3. Plus 3 into 2, 6. 6 into e power 2 into pi by 2. 2 into pi by 2 is pi. 6 plus 6 becomes 12 e power pi. This is option A. Okay. Cos 3 pi by 2 is 0. Sin 3 pi by 2 is minus 1. Minus into minus plus 3. 3 into 2, 6. 6 e power pi. Here also. Minus into minus plus 3 into 2, 6. 6 e power pi. 6 e power pi plus 6 e power pi. Simplify to, will add up to 12 e power pi. Option A is the answer. Next one, y equal to a power x. It's a very simple question asked many times. This type earlier, they're asking these type of questions. dy by dx is derivative of a power x. A power x into log a. Again differentiate. D square y by dx square is equal to log a is constant. Derivative of a power x is a power x into log a. So log a into log a is log a the whole square. So what you get is a power x into log a the whole square. Answer is option A. 19th one. Want to find y cube into d square y by dx square. Differentiate this with respect to x. Derivative of y square is 2y into dy by dx. Correct? Differentiating with respect to x. Derivative of ax square 2ax. Derivative of 2bx is 2b. Derivative of c is 0. Divide by 2. Correct? And write dy by dx as ax plus b divided by y. Correct? Divide the entire equation by 2. Now differentiate by using quotient rule. D square y by dx square. Denominator square. Y square. Denominator into derivative of numerator. Derivative of ax plus b is a. Minus numerator into differentiate the denominator. Derivative of y is dy by dx. dy by dx already we got in the previous step as ax plus b by y. That you substitute. So this becomes ay minus of ax plus b into dy by dx is ax plus b divided by y whole divided by y square. You can take LCM as y here. Correct, in the numerator. Therefore, d square y by dx square will simplify to d square y by dx square will be taking y as common denominator. Y into ay becomes ay square minus ax plus b into ax plus b. I'm going to get ax plus b the whole square. Whole thing is divided by y square. So this becomes a into what is y square, you can substitute. Y square is ax square plus 2bx plus c. Ax square plus 2bx plus c. Here open the bracket. Use a plus b whole square formula. What I get? A square x square plus b square plus 2abx. This y comes to denominator, becomes y into y square, becomes y cube. So what I get is a square x square plus 2bx plus ac minus a square x square minus b square minus 2abx. Correct? Whole thing is divided by y cube. So 2abx is going to cancel. A square x square is going to cancel. What remains is ac minus b square divided by y cube. That's to find y cube into d square y by dx square. Correct? Cross multiplied. So required answer is ac minus b square, which is option A. y cube into d square y by dx square is equal to how much? Answer is ac minus b square. Hope I understand this. Question asked in the year 1996. Move on to the next one. If be a polynomial, then the second derivative of f of e power x is how much? Let y be equal to f of e power x. Let y be equal to f of e power x. You have to find the second derivative of f of e power x. dy by dx. dy by dx is equal to what? You have dash of e power x into derivative of e power x, e power x. Again differentiate d square y by dx square. D square y by dx square is first function keep as it is. Derivative of e power x plus e power x into derivative of f dash is f double dash of e power x. You have to find the second derivative of f of e power x. Derivative of f of e power x is f dash of e power x into derivative of e power x. Again differentiate by using product rule. Correct? First into derivative of second. Just a minute, I made a mistake in this. I should apply the product rule, right? F of e power x. F of e power x is f dash of e power x. I think there is some mistake in the question. F of e power x, second derivative of f of e power x is asked. Just a minute, I was made a mistake in this. Sorry. F dash of e power x into derivative of e power x is e power x. Now I apply the product rule for this. First function keep as it is. Differentiate e power x. Derivative of e power x is e power x. Plus second function keep as it is. Derivative of f dash of e power x. Derivative of f dash of e power x is f double dash of e power x into derivative of e power x is e power x. Right? So this becomes equal to what? E power x into f dash of e power x plus e power x into e power x becomes e power 2x into f double dash of e power x. So answer is option D. F double dash of e power x into e power 2x plus f dash of e power x into e power x. Just apply product rule for this. First function keep as it is. Derivative of e power x is e power x plus second function keep as it is. Differentiate f dash of e power x, which is f double dash of e power x into derivative of e power x is e power x. E power x becomes e power 2x. So answer is option D. Hope I understand this. Move on to the next one. Type 2, implicit form. Here some of the important results are there. Left hand side is a homogeneous function actually. You see the power of each term is same. Power of x 2, power of y is 2. Here sum of the powers of x and y is 2. We call it as homogeneous function. If right hand side is 0, then the second derivative is going to be equal to 0. This was a question which was frequently asked earlier in many of the exams, but now it's there or not, we are not sure. But still the questions can be asked like this because homogeneous function you learn in a differential equation. Right hand side is 0, left hand side is a homogeneous function of degree 2. Then you can remember that d square y by dx square is equal to 0. Also it is an implicit function because x and y are mixed up on the left hand side. And if it takes this form ax square plus 2hxy plus by square equal to k, then d square y by dx square is equal to k into h square minus ab by hx plus by the whole cube. You can remember these two important forms. Okay, and this is a question which is found in NCERT miscellaneous exercise. This is the equation of circle x minus a the whole square plus y minus b the whole square equal to c square. Circle having center at a comma b and radius is c. That's why c is positive. 1 plus dy by dx the whole square power 3 by 2 by d square y by dx square. The modulus of that is going to be c. The radius represents the radius. 1 plus dy by dx the whole square power 3 by 2. Questions are not asked based on this. Still I have given it as one of the important point here. Questions can be asked in the upcoming exams. Okay. Discuss the questions based on this. Question asked in the year 2022, e power y plus e power y plus xy equal to e. To find the ordered pair dy by dx comma d square y by dx square at x equal to 0. Given equation is like this: e power y plus x into y is equal to e. At x equal to 0, find the corresponding value of y. When x equal to 0, y equal to how much? When x is equal to 0, correct, what do we get? E power y plus x is 0, 0 into y, 0 is equal to e means e power 1. Bases are same, therefore power should be same. Y is equal to 1. When x is 0, y is 1. That is important. Because x equal to 0 is given, y value is not given. We can find out by putting x equal to 0 in the given equation. Y is equal to 1. Differentiate this with respect to x. Differentiate with respect to x on both sides. What do you get? Derivative of e power y is e power y into y dash. Derivative of xy, x into y dash plus y into 1. And derivative of e is 0. E is a constant. Now we can put x equal to 0, y equal to 1. We'll get the value of y dash. Put x equal to 0, y equal to 1. Put x equal to 0, y is equal to 1. What we get? E power y is 1 into y dash. X is 0. 0 into y dash, 0. Y is 1, correct? So I'm getting e into y dash equal to minus 1. E into y dash is equal to minus 1. So what I'm going to get is y dash is equal to minus 1 divided by e. X is 0, y is 1, correct? Y is 1, you put e power 1 into y dash, 0 into y dash 0, y is 1. So e into y dash is minus 1, so y dash is minus 1 by e. So either it is option A or option C. Option B and option D are ruled out, correct? These two are not possible because I got dy by dx as minus 1 by e. Now we should differentiate this equation. Should differentiate this equation to get y double dash. Okay, so consider this equation now. E power y into y dash plus x into y dash plus y is equal to 0. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. What do you get? E power y into derivative of y dash is y double dash plus y dash into derivative of e power y is e power y into y dash. Correct? Apply product rule. First into derivative of second plus second into derivative of first. Coming to x y dash. Again apply product rule. X into derivative of y dash is y double dash plus y dash into derivative of x1 plus derivative of y is y dash equal to 0. Want to substitute x equal to 0, y equal to 1 and y dash equal to minus 1 by. All these three you have to substitute. Put x equal to 0. Put x equal to 0, y is equal to 1 and y dash is equal to minus 1 by. So that will get y double dash. Okay. E power y is 1. E power 1 into y double dash. Here y dash into y dash. Y dash is minus 1 by into minus 1 by 1 by e square into y dash. Y dash is how much? E power y. Y dash I put already. Y is how much? Y is 1. E power 1. X is 0. 0 into y double dash is 0. Y dash minus 1 by e. Again y dash minus 1 by e equal to 0. Correct? In this equation I am putting x equal to 0, y equal to 1 and y dash equal to minus 1 by e. 1 e is going to cancel here. So what I am going to get is e into y double dash. 1 e cancels. 1 by e minus 1 by e is equal to this minus 1 by, take that side. 1 by e minus 1 by will add up to 0. So what I am going to get is e into y double dash is equal to 1 by e. So y double dash is equal to 1 by e into e, that is 1 by e square. Correct? So y double dash is 1 by a square. Y dash is minus 1 by e. Y double dash is 1 by a square. Answer is option A. Option A is answer. This question was asked in the JEE mains also earlier to this. Next one. Sine of x plus y plus cos of x plus y equal log of x plus y. Want to find d square y by dx square. The given equation could be written as sine of x plus y plus cos of x plus y minus log of x plus y equal to 0. Correct? It is function of x plus y equal to 0. All the terms contains x plus y. So it is function of x plus y equal to 0. So x plus y is equal to f inverse of 0. F inverse of 0 is some constant, correct, k. So differentiate with respect to x. What do we get? Derivative of x is 1. Derivative of y is y dash. Derivative of k is 0. So I'm going to get y dash equal to minus 1. Second order derivative on y double dash. Y double dash. Derivative constant is 0. So d square y by dx square is 0. Option B. Function of x plus y equal to constant means derivative is minus 1. Second order derivative will be 0 because derivative of minus 1 is 0. Correct? X plus y equal to f inverse of 0. F inverse of 0 is some constant. Derivative constant is 0. Derivative of x 1. Derivative of y is y dash. So we get y dash equal to minus 1. Y double dash equal to 0. Next one. X plus y equal to tan inverse y given d square y by dx square equal to f of y into dy by dx. Want to find f of y equal to how much? So differentiate this equation. X plus y is equal to tan inverse y is given. Differentiate this with respect to x. What we get? Derivative of x1. Derivative of y is dy by dx. Derivative of tan inverse y is what? 1 by 1 plus y square into derivative of y, that is dy by dx. Can take dy by dx common. Dy by dx is common. What do you get? 1 by 1 plus y square minus 1. 1 by 1 plus y square minus 1. Taking dy by dx common from this. So what we get? Taking LCM inside the bracket. Denominator, common denominator is 1 plus y square. So I get 1 by 1. So 1 into 1. 1 minus of 1 plus y square. Correct? So what I'm going to get is 1 is equal to dy by dx into here 1 minus 1 0. So I'm getting minus y square divided by 1 plus y square. Correct? Cross multiply. So I'm going to get dy by dx is equal to 1 plus y square divided by minus y square, or minus you keep outside, you can write like this, minus of 1 plus y square by y square. You can separate the terms here. Separating the terms, I'll get minus 1 by y square, minus into plus minus, y square by y square is 1. Now again differentiate, d square y by dx square is equal to derivative of 1 by x square is minus 2 by x cube. Derivative of 1 by y square is minus 2 by y cube into dy by dx because I'm differentiating with respect to x. So minus of derivative of 1 by y square is minus 2 by y cube into dy by dx, and derivative of 1 is 0. So what I'm going to get is 2 by y cube into dy by dx. 2 by y cube is f of y. Correct? We can compare this form. The given form is like this. D square y by dx square equal to f of y into dy by dx. D square y by dx square equal to f of y into dy by dx. This is f of y. F of y is equal to 2 by y cube. Option B. On to the next one. This is a homogeneous function. Right answer is 0. So second order derivative is 0. It follows from the earlier result as shown here. From this it follows ax square plus 2hx square plus by square equal to 0 and d square y by dx square equal to 0. Remember that result. Okay. So answer is 0. Option A. Question asked 2 times in 1991 and 1995. Move on to the next one. This question is repeated, I think. Same question was done here, correct? Sine of x plus y. I think this question is repeated by mistake. Answer is 0, correct? Parametric form, type 3. The given equation takes this form, x equal f of t, y equal to g of t. We know how to find dy by dx, and d square y by dx square is d by dx of dy by dx, that is d by dt of dy by dx into dt by dx, follows by chain rule. D by dx of dy by dx, written as d by dt of dy by dx into dt by dx. Okay, so it follows by chain rule. Further, it should differentiate with respect to, I think it should be dx by dt. I think d by dx of dy by dx. Yeah, it's correct. Further differentiate t with respect to x, dt by dx. It's correct. Dt is going to cancel d by dx of dy by dx. I'll explain while working out the problems. X equal to a secant square theta, y equal to a tan square theta. I want to find d square y by dx square. As usual, find out dx by d theta, dy by d theta. Dx by d theta is constant into variable, constant key path is derivative of secant square theta is 2 secant theta into derivative of secant theta is secant theta tan theta, correct? Derivative of secant theta is secant theta tan theta. Constant key path is derivative of secant square theta is 2 secant theta into derivative of secant theta is secant theta tan theta. Dy by d theta is equal to constant into variable, constant key path is derivative of tan square theta is 2 tan theta into derivative of tan theta is secant square theta, correct? Therefore, find dy by dx ratio. Then you can find the second order derivative. Dy by dx. Dy by dx is equal to dy by d theta divided by dx by d theta. Dy by d theta is here 2a tan theta into secant square theta. Dx by d theta is here 2a secant theta becomes secant square theta into tan theta. Both numerator denominator is same, no? So ratio becomes 1. So dy by dx is 1 means d square y by dx square is 0. D square y by dx square is equal to 0. Answer is option A. Question asked in the year 2019. X1, can you try this? Find out dx by dt, dy by dt, then find dy by dx, then go for second order derivative, d square y by dx square. First find dx by dt. X is given as 2 by t square. 2 by t square means 2 into 1 by t square. So dx by dt. Constant into variable. Constant key path is derivative of 1 by t square is minus 2 by t cube. Derivative of 1 by t square is minus 2 by t cube. Derivative of 1 by x power n formula minus n by x power n plus 1. dy by dt. Y is given as t cube minus 1. dy by dt is how much? dy by dt is 3t square. Now find dy by dx. dy by dt divided by dx by dt. dy by dt is 3t square. Dx by dt is minus 4 by t cube. Correct? T cube goes up. So what you get is minus 3 by 4. T cube goes up. T cube into t square becomes t power 5. This is dy by dx. Now want to find the second order derivative, d square y by dx square. So differentiate this. D square y by dx square is defined as d by dx of dy by dx. d by dx of dy by dx. Correct? That is d by dx of dy by dx is what? Minus 3 by 4 t power 5. Want to find derivative of minus 3 by 4 t power 5 with respect to x, which is same as d by dt of minus 3 by 4 t power 5 into further differentiate t with respect to x, that is dt by dx. dt by dx is the reciprocal of dx by dt. So this will be equal to how much? Minus 3 by 4. Derivative of t power 5 is 5 t power 4 into dt by dx is reciprocal of this. Reciprocal of this what? Minus t cube divided by 4. dt by dx is reciprocal of dx by dt. So I'll write minus t cube divided by 4. Correct? Minus into minus will become plus. 3 into 5 is 15. 4 into 4 is 16. T cube into t power 4 is t power 7. So 15 by 16 t power 7. Option C is the answer. Hope you understand this. Similar type of question is found in NCERT exam that book also. Please work out that. Option C is the answer. On to the next one. X equal to 80 square, y is equal to 280. Here again parametric form with second order. Dx by dt is equal to derivative of 80 square is 280. Derivative of 280 is 2a. dy by dt is 2a. Therefore dy by dx is dy by dt divided by dx by dt. dy by dt is 2a. dx by dt is 280. 2a cancels 1 by t. Want to find second order derivative. D square y by dx square. D square y by dx square is defined as what? D by dx of dy by dx. D by dx of dy by dx. D by dx of dy by dx is 1 by t. D by dx of 1 by t means derivative of 1 by t with respect to x, that is minus 1 by t square into further differentiate t with respect to x, which is dt by dx. dt by dx is reciprocal of dx by dt. dx by dt already we have 280. So dt by dx is 1 by 280. So what we get is minus 1 by 2at cube, which is option D. It's a very familiar question found in many of the competitive exams. Option D is the answer. Move on to the next one. This is present in your NCERT miscellaneous exercise itself. dy by dx will get tan theta. Then you have to find d square y by dx square. We'll do it fast, not waste much time for this. Dx by d theta is equal to, theta is the parameter, constant keep as it is, differentiate the terms inside the bracket. Derivative of cos theta is minus sin theta. Here we shall apply the product rule. Theta into derivative of sin theta is cos theta plus sin theta into derivative of theta is 1. So that sin theta cancels. What we get is a theta cos theta. dy by d theta is equal to a into derivative of sin theta is cos theta minus, here you apply the product rule, theta into derivative of cos theta is minus sin theta plus cos theta into derivative of theta is 1. So what we get is a into cos theta plus theta sin theta minus sin theta, minus into plus is minus cos theta. So that cos theta is going to cancel. What I am going to get is a theta sin theta. Therefore dy by dx is equal to dy by d theta by dx by d theta. dy by d theta we got a theta sin theta. dx by d theta is a theta cos theta. A theta cancels. Sin theta by cos theta is tan theta. dy by dx. Now I go for d square y by dx square. Second order derivative. D square y by dx square is d by dx of dy by dx. Correct? So this is equal to d by dx of dy by dx is tan theta. Derivative of tan theta with respect to x is secant square theta into derivative of theta with respect to x d theta by dx. That is secant square theta into d theta by dx is reciprocal of dx by d theta. Dx by d theta we got a theta cos theta. Reciprocal of that is 1 by a theta cos theta. And 1 by cos is sec. Secant square into sec becomes secant cube theta. So answer is secant cube theta by a theta answer. So d square y by dx square. Write the answer here. Finally, d square y by dx square is equal to. Correct. 1 by cos is sec. Sec into secant square is secant cube theta. Secant cube theta divided by a theta, which is option C. On to the next one, we got finally type 4, that is formation of differential equation. All these results you have to remember because many times questions are asked based on this, so that directly we can answer. I'll just tell without saying y is equal to a cos mx plus b sin mx. In that case, d square y by dx square is equal to minus m square y, or I can tell d square y by dx square plus m square y equal to 0. Okay, y equal to a cos mx plus b sin mx. What is the answer? We have d square y by dx square is equal to minus m square y. Next one, y is equal to a into e power mx plus b into e power minus mx. In that case, d square y by dx square is equal to m square y. Okay. Next one we got y is equal to a into e power mx plus b into e power nx. In that case, d square y by dx square minus of m plus n dy by dx plus mn y equal to 0. Learn this. This is of trigonometric with exponential. Okay. Next one we got y equal to a cos of log x plus b sin of log x. Very standard question. X square into y2 plus x into y1 plus y equal to 0. Next one we got y equal to tan inverse x the whole square. This question already asked in 2014 CET exam. Tan inverse x the whole square. It's a 5-mark question for board exams, which happens to be a multiple choice question in CET exam. Okay, so you should remember the answer for this. Y equal to tan inverse x the whole square. What is the answer we get? X square plus 1 the whole square into y2 plus 2x into x square plus 1 into y1 equal to 2. I repeat once again, y equal to tan inverse x the whole square. What is the answer we get? X square plus 1 the whole square into y2 plus 2x into bracket x square plus 1 into y1 is equal to 2. Okay. Next we got some of the functions like sine of sine inverse x, cos of m sine inverse x, all those things. There are 4 questions of that type. 4 results I can tell. Y is equal to sine of m sine inverse x. In that case we have 1 minus x square into y2 minus x y1 plus m square y equal to 0. Next one, y equal to cos of m cos inverse x. In that case also same thing. 1 minus x square into y2 minus x y1 plus m square y equal to 0. If it is y equal to cos of m sin inverse x or sine of m cos inverse x, in all these 4 cases, whether it's sine of m sin inverse x or cos of m sin inverse x or cos of m cos inverse x or sine of m cos inverse x, in all the 4 cases, what is the result we have? 1 minus x square into y2 minus x y1 plus m square y equal to 0. If it is y equal to e power m sin inverse x or y equal to e power m cos inverse x, in that case 1 minus x square into y2 minus x y1 equal to m square y. Remember this. Okay, various results we have. And also we have, if it is y is equal to e power ax into sin bx or y is equal to e power x into cos bx, in that these 2 cases we have d square y by dx square minus 2a into dy by dx plus a square plus b square into y equal to 0. Okay, all these things you have to learn. And one more is that is y is equal to a into x power n plus 1 plus b by x power n. In that case, x square into d square y by dx square is equal to n into n plus 1 y. Hope I told all these formulas. Correct? And 1 or 2 are left, I think. Sin inverse x the whole square. Y equal to sin inverse x the whole square. Then we have 1 minus x square into y2 minus x y1 is equal to 2. Okay, even it is applicable for cos inverse x the whole square. Same thing, 1 minus x square into y2 minus x y1 equal to 2. And if it is y equal to sin inverse of x, then it is 1 minus x square into y2 minus x y1 equal to 0. So everything you should remember. Okay, write and study all these things. And on this question, on this result, there are 3 questions asked so far. Y equal to a into x power n plus 1 plus b by x power n. X square into second derivative equal to n into n plus 1 by. It's quite important. Even in 2020, this question was asked. This type of question was asked. 3 questions are asked, as I told you. One is straightforward here, KCET 1993, a into x power n plus 1 plus b by x power n, or b into x power minus n. X square into second derivative is n into n plus 1 by. Here, instead of a and b, they give the numbers here. Numbers a and b doesn't matter. Whether a and b is given or 2 and 3 is given. In both the case, it does not depend upon the values of a and b here. Correct? So answer is n into n plus 1 by. X square into d square y by dx square is n into n plus 1 by. So first and third, both answers are n into n plus 1 by. Here, a instead of n, the given numbers, instead of n plus 1 and n, see, observe, a into x power n plus 1. So n plus 1 is 4 or n is 3 if we compare. So d square y by dx square is equal to how much for this? We know if y is equal to a into x power n plus 1 plus b by x power n. In this case, what we have is x square into d square y by dx square is equal to n into n plus 1 y. N into n plus 1 by. Correct? So d square y by dx square is equal to how much? Here the given question is y is equal to, y is equal to a into x power 4 plus b by x cube. Correct? So that means you observe n plus 1 is 4. N plus 1 is 4 means n is equal to 3. Or if you compare here also, n is equal to 3. They ask to find d square y by dx square. What is my result? We have n into n plus 1 y divided by x square. N is equal to 3 by comparing, correct? So 3 into 3 plus 1 4 into y divided by x square. So what we get is 12y divided by x square. 12y divided by x square. Option B is answer. Quite important. Please learn this result. Move on to the next one. This I told already, tan inverse x the whole square. X square plus 1 the whole square into y2 plus 2x into x square plus 1 into y1 equal to 2. Answer is equal to 2. And this question, the given in terms of log, m sin inverse of x equal to log y. M sin inverse of x is equal to log y. I can convert this. What? Can convert this. Y is equal to e power m sin inverse x. Y is equal to e power m sin inverse x. Converting log to exponential form. Correct? So in that case, we know the result for this. Already I told. For this e power m sin inverse x or e power m cos inverse x, what is the result we have? 1 minus x square into y2 minus x y1 equal to m square y. So this is equal to m square y, option E. For this, what is the result we have? 1 minus x square into y2 minus x into y1 is equal to m square y. Instead of y2 they use symbol y double dash, y1 they use symbol y dash. On to the next question. Root r is equal to a into e power theta cot alpha. A and alpha real numbers. Want to find this? D square r by d theta square minus 4r cot square alpha. Question asked in the year 2011. So what we can do is, given root r is equal to a into e power theta cot alpha. First we will find dr by d theta. One method is we can do squaring on both sides and differentiate, or directly also we can differentiate. If we are doing squaring on both sides, this becomes root r square is r is equal to a square into e power 2 times theta cot alpha. Because e power theta cot alpha square will be e power 2 theta cot alpha. Squaring means the powers gets multiplied there. Okay, squaring on both sides I got like this. Now we will differentiate with respect to theta, because we want to find d square r by d theta square. First I will find dr by d theta. Differentiate with respect to theta. Dr by d theta is equal to constant into variable. Constant keep as it is. Derivative of e power x is e power x. E power 2 theta cot alpha into derivative of 2 theta cot alpha. 2 cot alpha is constant, correct? Derivative of theta with respect to theta is 1. Further, I should differentiate this power. Derivative of e power x is e power x only. But I need to differentiate the power because the power is not exactly x, it's something else. So further differentiate 2 theta cot alpha. 2 cot alpha is constant. Derivative of theta with respect to theta is 1. Now you see that a square into e power 2 theta cot alpha is nothing but r from this equation. Correct? A square into e power 2 theta cot alpha is nothing but r. So this becomes 2r cot alpha. Further differentiate with respect to theta to get d square r by d theta square. Differentiate with respect to theta again on both sides. What do you get? D square r by d theta square is equal to 2 cot alpha is constant. Further differentiate r with respect to theta, which is dr by d theta. Dr by d theta, which we got from the previous step as 2r cot alpha, that you substitute. So what do you get? 2 cot alpha into dr by d theta we got from the previous step as 2r cot alpha. Correct? So this becomes equal to 2 into 2 becomes 4r cot square alpha. Correct? So what I got? D square r by d theta square equal to 4r cot square alpha. So what I am going to get from this? D square r by d theta square. This take it to left hand side minus 4r cot square alpha, which is equal to 0. Hence required answer is 0. Option D. Hope you understand. I did squaring on both sides. Otherwise also we can differentiate directly. Okay. Root r square becomes r. A square e power theta cot alpha square will be e power 2 theta cot alpha. Differentiate with respect to theta. Dr by d theta. Correct? Constant into variable. Constant keep as this. Derivative of e power x is e power x. But this is not x. So further differentiate 2 theta cot alpha, which is 2 cot alpha into derivative of theta with respect to theta is 1. And this is nothing but r itself. Correct? A square into e power 2 theta cot alpha is r. So 2r cot alpha. Differentiate with respect to theta again on both sides. D square r by d theta square is equal to 2 cot alpha into derivative of r with respect to theta is dr by d theta. 2 cot alpha into dr by d theta we got from the previous step as 2r cot alpha. 2 into 2 becomes 4r cot alpha into cot alpha is cot square alpha. Hence we get d square r by d theta square minus 4r cot square alpha equal to 0. Option D is the answer. Y equal to cos square 3x by 2 minus sin square 3x by 2. This takes the form cos square theta minus sin square theta, which is cos 2 theta. Correct? Cos square theta minus sin square theta. What is cos square theta minus sin square theta? Cos 2 theta. Correct? Using double angle formula, trigonometry. So this becomes y is equal to cos of double of 3x by 2. Theta double is 2 theta. 3x by 2 double. 2 into 3x by 2. I should write. So this becomes equal to cos 3x. Y equal to cos 3x. Now differentiate. dy by dx. Derivative of cos 3x is minus 3 sin 3x. D square y by dx square. Again differentiate. Minus 3 into derivative of sin 3x is 3 times cos 3x. Is equal to minus 9 cos 3x. Cos 3x is y. So minus 9y is the answer. Hope you understand this. D square y by dx square. Constant into variable. Constant keep as it is. Derivative of sin 3x. 3 times cos 3x. Minus 9 into cos 3x. Cos 3x is y. Minus 9y. Option D is the answer. X equal to sin t. Y equal to cos pt. From x equal to sin t, I can write it as t is equal to sin inverse of x. X equal to sin t. So t is equal to sin inverse of x. Correct? Y is equal to cos pt will become cos of p into sin inverse of x. whether it is cos of p sin inverse of x or cos of p cos inverse of x or sin of p sin inverse of x or sin of p cos inverse of x. In all the four cases, what is the result we have? 1 minus x square into y2, 1 minus x square into y2 minus x y1 plus p square y is equal to 0. Okay, whether it is cos of p sin inverse x or cos of p cos inverse x or sin of p sin inverse x or sin of p cos inverse x. In all these four cases, we have this result: 1 minus x square into y2 minus x y1 plus p square y equal to 0. 1 minus x square y2 minus x y1 plus p square y equal to 0. From x equal to sin t, I wrote t equal to sin inverse of x, and this t equal to sin inverse of x is put in the other equation, y is equal to cos pt. So it becomes y equal to cos of p sin inverse of x. Answer is option D. On to the next one. These three questions can be related to that result which I gave: y equal to a cos mx plus b sin mx, d square y by dx square is equal to minus m square y. Here y is equal to a cos mx plus b sin mx. I think this should be d square y by dx square here. Okay, this is d square y by dx square. Y equal to a cos mx plus b sin mx. D square y by dx square is minus m square y for this option A. And x equal to a cos nt minus b sin nt. D square x by dt square is minus n square x. Minus n square x. And this is a cos 4t plus b sin 4t. In place of m it is 4. So d square x by dt square is minus 16. 4 square is 16. So minus 16x directly based on this result. Y is equal to a cos mx plus b sin mx. Learn this result. 3 questions are asked. Or that 4 times. This has appeared 2 times. Correct? A cos mx plus b sin mx. What is the result we have? D square y by dx square is equal to minus m square y. A cos bt, a cos mt plus b sin mt. M is 4 here. So d square x by dt square in place of, in terms of x the given. Y is replaced by x there. Okay. So answer is minus 16x. It follows from this result. All these 3 questions. Next is differentiation of a determinant. If a determinant is given where all the elements, third order determinant is given, all the elements are functions of x. How do you differentiate a determinant? Differentiate the first row, second row, third row, keep as it is. Plus differentiate the second row, keeping first row and third row as it is. Differentiate the third row, keeping the first and second row as it is. That is how you differentiate a determinant. And delta of x is like this. The second row and third row are constants. In that case, how to differentiate a determinant? Second row, third row, keep as it is. Just differentiate the first row. That is differentiation of a determinant. One such question is asked in 2017 actually, but this question has multiple answers. F of x, first row is a variable, second row and third row are constant. Dy by dx, the first option is correct. Even the third option is correct because we can interchange the rows and columns. The value of determinant is unaltered. There is from property of determinant actually, which is deleted from the NCERT book right now. So if you interchange the rows and columns, that is, if we take the transpose, the value of determinant is not going to change. So even that is correct. And there is some mistake in this. I think typing error is there. Here what they've done is L, M, N, A, B, C has been interchanged. Here it should be F dash, okay. One dash is there. F dash, G dash, H dash. What they've done in this option is they interchange the first row and third row and interchange the second row and third row. Okay. Even this option is going to work. Okay. There are multiple answers for this. And finally, this question as a miscellaneous I've included. Actually, it's not a topic from any of the topic which is discussed in differentiation. Actually, it's a determinant, expansion, and then differentiating. So I put it under the miscellaneous. Okay, only one question is there. It's appeared 3 times: 2013, 15, and 2024. Even last year also the question has been asked. So what we can do is just expand this directly. A is equal to Expanding this determinant, what we get? X into x square minus 1, expanding along the first row, correct? Minus 1 into, leaving the second column first row, what we get is x minus 1 plus 1 into 1 minus x. So what we get? This is x cube minus x plus 1 minus x. We will simplify to x cube minus x becomes minus 3x plus 2. If you differentiate this, dA by dx. Now it's a polynomial of degree 3. Differentiate this. Derivative of x cube 3x square. Derivative of 3x is 3. Derivative of 2 is 0. 3 is common. What we get is x square minus 1. If we expand the determinant, which is given in b here, b is equal to determinant of x1 1x, which is x square minus 1. So 3 times, what is x square minus 1? Nothing but b. So dA by dx is equal to 3b, option B. Okay, question is asked 3 times. I think once the question was asked in terms of A and B, and in another time the question was asked in terms of P and Q. In that case, they ask dP by dx in terms of Q. Instead of A and B, they use the symbol P and Q. Okay, so with this we completed all the questions of differentiation. Okay, only the methods of differentiation is included, not the differentiability part, and the Rolle's theorem and mean value theorem is not included. Many more videos I'll be uploading connected to KCET exams, even JEE exams, and NCERT exercise also I'll be starting. NCERT exemplar book also will discuss, and also which is not appeared till now, that is non-PYQs also I'll be discussing. Synopsis part of every chapter will be done in detail for KCET and NDA exams, even for JEE exams. Okay, in detail everything will be done one by one. I'll be uploading more and more videos in the coming days. Please subscribe to my channel, share it to your friends, and inform to others those who are not subscribed and not known about this channel. Okay, with this I conclude. Thank you.